Sir, good afternoon.
Good afternoon. So let us start our session. Let me introduce the learned speaker. Just a minute. So a very good afternoon to all of you. And we are very happy to have a great success in yesterday's program. In fact, it was a historical program, that is the centenary celebration of chemical engineering department, Jadavpur University. In fact, chemical engineering has emerged as a full-fledged discipline in Jadavpur University in 1921, and that was first time not only in our country, it was first time in Asia. And we are very happy that we have associated ourselves with our partner, that is Agilent Technologies. As a professor of chemical engineering, we have several installations we received from Agilent in my institute where I teach, that is Heritage Institute of Technology, and also in Jadavpur University. Jadavpur University, the Pro Vice Chancellor, Professor Chiranjeev Bhattacharya, who is the chairman of this particular conference. So in his lab, and there are so many labs that we have that. In fact, you can say the Agilent is a monopoly. And we are very happy that we got Dr. Vinay Jain, COE Manager and Application Scientist, ICPMS, Agilent Technologies, Manesar, India. So welcome, warm welcome, Vinay Jain ji. And I also welcome Mr. Mainak Mondal, the head of this Eastern region marketing. Mainak has got good association with our Ramakrishna Mission organization. And let me introduce our secretary, please. Let me introduce our secretary, Dr. Arun Kanti Vishesh, who was earlier in the level of the regional director, National Environmental Engineering Research Institute, CSIR, Government of India. Let me tell about Dr. Vinay Jain, working as COE Manager and ICPMS Application Scientist at Agilent Technologies, India. He is having PhD on analytical chemistry. He has more than 30 years of analytical and research experience in spectroscopic techniques, ICPMS, 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 QQQ, ICPMS, ICPQES, AAS, XRF, XRD. So many type of the determination, the determination kits. So he is a great expertise in various market segments such as pharma, food and farm products, packaging, chemical, clinical, environment, petroleum, Ayurveda and herbal. His area of specialization includes new analytical method development and validation as per regulatory guidelines. He has completed more than 28 research projects with various research and regulatory organizations of national and international importance. He is having 2 patents, 6 research publications, 2 chapters in various international handbooks, and 5 Agilent application notes in his credit. Received Tech Innovation Award in 2020 from Agilent Technologies, India. With this small introduction, let us request Dr. Vinay Jain to start his presentation, and I also request the other research scientists, few have joined and more will be joining when this talk will begin, to clarify any doubts, because it is a great opportunity, it's a rare opportunity to get a scientist like him, Dr. Vinay Jain. So, Dr. Vinay Jain, sir, please start your presentation.
Yeah, thanks, Swamiji. I'm getting some technical glitches. I'm not able to share my screen since it was disabled.
Let me see. Just a minute. Now you please try.
Yeah, thank you very much, sir. And I hope my screen is visible to everyone.
Yes, surely. And it is also we are having the live streaming in YouTube. If you go to the Vivekananda Institute of Environment Management, so in our channel, it is being visible. So very good. Please start your presentation.
Yeah, thank you, Swamiji, and thanks to the Vivekananda Institute of Environmental team for providing Agilent this an opportunity. Really, this is a big opportunity for the Agilent Technologies and for the team of Agilent Technology. And on behalf of the Agilent Technology, I will not take more than 15 to 20 minutes. In next 15 to 20 minutes, I will present the key highlights about how the Agilent Technology is leading the way in atomic spectroscopy innovation. Today, I am going to present one of the most innovative called as the development, which we have done recently in our lab. Basically, how the Agilent ICP-MS can be used for the authentication of T using the ICP-MS and with the statistical modeling. So, as you know, that tea is one of the most popular and widely consumed beverages in the world, and making it is a very valuable agriculture commodity. And in fact, if we can see, India is the second largest producer of the tea after China. And in fact, if we can talk about the northeastern part of the country, the states like Assam, West Bengal, and Tripura are the main states which where the tea is growing. But looking at the important, as you know, that the Darjeeling tea has is the most important tea, which has a market value, which is really provide a strength, or I can say flavor and fragrance to the Indian tea. Since few of the manufacturers, few of the traders, in order to get the market benefit, in order to get the price benefit, so what actually they are doing, they are just doing the mixing or the blending with the other tea and trading with the name of the Darjeeling tea. So ICP-MS is the technique which can also authenticate the tea, that this tea is present from which particular region. So in next coming slides, I will explain how we have done this innovative work at our Center of Excellence. Before that, let me explain that what are the different atomic spectroscopy solution Agilent have. This is really an innovative tech. Agilent really have the innovation in the atomic spectroscopy for the past 4 decades. So when we talk about the Agilent portfolio, let us start with the AS atomic absorption spectroscopy, which come under the 2 different models, the 55 series and the 200 series. This is the fast analysis. As we know, fast analysis AS, and here also we can couple the muffle furnace. We can hyphenate the vapor generation series for the estimation of the trace element like arsenic and the mercury. At the same time, we can also couple the graphite furnace for the estimation of the element we want to achieve the low detection limit like lead and cadmium. Second innovation in Agilent technology is the MPAS. This is nothing but the microwave plasma atomic emission spectroscopy, and this instrument runs on air. It means just plug and play. We have to plug the instrument and start doing the analysis. The running cost of this instrument is very less. As you know that our air comprises of approximately 78 to 79% of the air. So the nitrogen generator, which is coupled with this MPAS, provide the nitrogen to the MPAS. And the important and the advantage of this MPAS is that it improves the laboratory efficiency in terms of the return on investment and high performance to achieve the better detection limit as compared to the AS. Now, moving from MPAS, and this is a proprietary product of Agilent, and moving from MPAS to the ICP-OES. ICP-OES is the inductively coupled plasma optical emission spectroscopy, and basically it works in the dual mode, and Agilent has a patented technology again with the SVDV mode, where the system can run in both the XL as well as the radial mode. So I can say the MPAS is a technique which provide the detection limit in between the AS and the ICP-OES, and ICP-OES is simultaneously technique where we can do all the elements. close to 68 to 70 elements we can do in a single run. When coming to the mass spectroscopy, Agilent have the two ICP-MS, which is called as the single code ICP-MS, 7850 and 7900 ICP-MS. Both the system are robust, sensitive, accurate, and provide the precise result. And in fact, we can say that it reduces the time trap. And Agilent is the pioneer in the ICP-MS technology. And moving from the single code to the triple code, Agilent is again for the past 1 decade, Agilent is pioneer in terms of the 8900 ICP-MS, which can control any of the interferences which are generated while generating the plasma, while running the sample, with the help of the different use of the reaction gases. With the superior sensitivity, superior matrix tolerance, Agilent atomic spectroscopy provides the complete solution for the estimation of all the elements in the periodic table from lithium to uranium. Since I'm talking about the number of the techniques, I'm talking about the AAS, ICP, OES, MPS. So how we have to select the technique? The selection of the technique depends upon certain parameters. First and foremost, what is the regulatory requirement? If it is environmental, definitely we are looking for the US EPA requirement. What is the US EPA talks about? What is the CPCB guidelines talks about in India? What is the Regional Pollution Control Board guidelines talks about? So selection of the technique depends upon the regulatory requirement, which element we want to estimate. It is not that all the elements are possible by AAS, or all the element we can do by ICP-OES. So the selection of the technique depend upon the which element we have to study. For example, suppose I am taking a non-metal like boron, and if we want to estimate the boron at the lower ppb level, which is not possible by AS, it is really possible by MPAES, but not in the ppb level. Talking about the ppm level, yes, it is possible. Talking when we move from MPAES to ICP-OES, up to a certain ppb level, if suppose we are looking for 10 ppb, 15 ppb, then it's okay, we can work with the ICP-OES. But really, we are looking for in the lower ppb level, say 0.1 ppb, then ICP-MS is the best technology. Similarly, it is applicable for other elements also. So the selection of technique depend upon the regulatory requirement, first and foremost. Second is which element we want to study. Obviously, the direction limit, as I mentioned, if we really want to work in the PPT level or the lower PPP level, then ICP-MS is the ultimate technique to estimate all the elements in a single go. How many samples we want to estimate? Obviously, this is a customized, or I can say wish list of a user, how many samples we want to analyze. Obviously, if suppose we are looking for say 100 samples or say 200 sample of the environment or the drinking water, then definitely if we are working on the AS, it will take completely estimation of the say 18 elements in 100 sample. It means close to 1800 samples elements we want to do. It means obviously it will take a complete day. Whereas if suppose we want to do the same analysis on ICP-MS, it will take hardly 2 hours to estimate all the elements. So, and similarly, the sample quantity, if the sample quantity is less, ICP-MS will take only 0.1 ml of the sample for the estimation of close to 78 to 80 elements. Other than that, selection of the technique also depend upon the solution readiness and what type of the matrix we want to handle. So we are looking for any of the food and farm products. We are looking for the, as per the FSSAI requirement or pharma or Ayurveda, if we are talking about any USP guideline or IP guideline. Suppose we are working on the chemical and energy sector in terms of nowadays you can see the semiconductor crisis. If really we want to analyze the specialty chemical, then again we need the technique like the ICP-MS. Talking about the environment, obviously in the case of the if it is a soil, liquid, or the soil, water, or air, and we are looking for the toxic metal or the nutritional property present in the soil, then ICP-MS is the ultimate technique. FMCG, as you know that about 5 or 6 years back, when we heard a news called as the lead content in the Maggie. So it is very helpful technique. All these atomic spectroscopy technique are helpful on estimation of those particular toxic metal present in the FMCG products. Consumer good, now again a very interesting market where all the toys, as you know that our childs, they are using the toys, and most of the time they are chewing those toys, and while they are chewing those toys, there is a possibility that the paint or the ink which is on the surface of that particular toys. The child inhale all those toys, all those paints. So the testing of that paint coating should be is now an important sector where the government of India is also working with the BIS 9873, and we have a international guideline also, EN 71 Part 3. If any of the toy product exported from India should be tested as per the BIS and as per the EN guidelines. Metal and alloys, when we talk about the metal and alloys, if we suppose we have the requirement, general requirement, whether it is a brass, what is the property of, or what are the impurity profiling in different types of the brass, bronze, or sometimes we are looking for the purity of the gold, or the purity of the silver, purity of the platinum. Everything we can do by using all these techniques. Mining and geological, obviously the important sector, like the, if suppose we are looking for the mineral in ores, or sometimes like the cement and the limestone composition, we can do. Petroleum products, yes, important sector. Again, the different types of the petroleum products. Nowadays, you can see in few of the petrol pump, you can see the sulfur-free petrol or the lead-free petrol. For the estimation of those lead and sulfur, again, you need the technique like the ICP-MS. Clinical and a forensic, again, a very, very important workplace. If suppose any of the worker is working in a, say, electroplating industries, obviously there is a need to test the element like chromium or the nickel, which is used in the electroplating industry. And in India, most of the pathology lab, the big pathology labs, they are using our Agilent ICP-MS for the study of the toxic as well as the nutritional property of the different types of the clinical samples like the blood, serum, plasma, urine, skin, and organ. Coming from here, I'm directly coming to the ICP-MS. ICP-MS basically is a highly sensitive technique and multi-element analysis technique where we can estimate all the elements from lithium to uranium in a single go. Highly matrix tolerance. It has a large linear dynamic range. With the 10 or a dynamic range, it will provide the long-term precision. It can also do the speciation. When we talk about the speciation in terms of, we can do the oxidation state of the different elements. For example, suppose if I will take a small example of the water. In the water, most of the time, as you know, that it consists of the hexavalent chromium also. If really we want to study the oxidation state of the chromium 3 and chromium 6, then we can hyphenate the HPLC with the ICP-MS, and we can do the speciation, or I can say the oxidation state of the chromium. Similarly, if suppose we are looking for the methyl mercury or inorganic mercury, that also we can do by the ICP-MS. So this is, I can say, the internal schematic diagram of how the from here the sample entrance with the help in the nebulizer. In the nebulizer, with the help of the argon gas, it forms the fine aerosols. Only the fine aerosols enter into the plasma. This is the plasma torch, and here is the part of the plasma, and this is the RF coil. So the plasma in the when it is generating the plasma, so along with the plasma, along with the ionization, there is a formation of the photons, neutrals, as well as there is a formation of the polyatomic interferences. So here again, Agilent has the patented technology of the off-axis ion lenses, where it removes the photons and neutrals, and only the ions along with the polyatomic ions enter into the octapole reaction system. Again, a patented technology of the Agilent, where in the helium gas or in the helium mode, we can remove all the polyatomic interferences based on the kinetic energy discrimination principle, and our analyte enter into the quadrupole, which filters based on the mass to charge ratio. And once it is filtered, then the ions enter into the electron multiplier diode. It is a detector. We had the first, when the ions strike with the first diode, it releases the secondary ion and strike with the second diode. And like this, it is electron got multiplying and increase the sensitivity of the ICP-MS. This is just a background at how the ICP-MS works and how our sample travel from a liquid to the convert into the sample. So today I'm going to present about the Agilent, how the Agilent provides the technology-based solution to quantify the element in terms of highly sensitive instrument, long-term precision, high matrix tolerance. Any of the metrics you can run directly on the Agilent ICP-MS. It provides the high sample throughput. Within a minute, you will get the complete information about 70 to 78 elements in any of your matrix. It has a UHMI feature. The UHMI features talk about you can run 25% of the TDS sample directly on ICP-MS. As I mentioned, you can also do the speciation. It can remove the interferences. It can take care of the half mass correction, and everything you can calculate directly from the software. So Agilent offers the ICP-MS where you do not want to work with the ICP-MS, irrespective of the matrix, irrespective of the environmental matrix, irrespective of the food matrix, you can directly run on the system and the system will work. The Agilent ICP-MS, the 7850 will work hard for you. So how it is working? It is a smart ICP-MS. Today we are talking about everything is smart. Whenever we are going to the market, we are saying, oh, I want to purchase a smartphone. I am looking for a smartwatch. I'm looking for a smart car. So this first time as Agilent is launching a new ICP-MS, which is called as the smart ICP-MS. You can connect that ICP-MS with your mobile phone. Obviously, you are sitting any part of the globe and just connect with the IP address, and you can see what is running on into my system, how the data is processing on my system. So you can directly connect with the you can connect your ICP-MS with the mobile, and these are the silent features I can say of any of the Agilent ICP-MS. It provides the high performance for basic to the advanced routine application. For example, the simple drinking water to the soil to the sediment, everything we can do. It is a best-in-class performance for data quality. You will get accurate and the precise results, faster method development, easy workflow and user interface, simpler sample and standard preparation. On performance, it will provide the post-run performance check also whether our system is working fine or not, so that next time when we'll start using the ICP-MS, our ICP-MS will be in a good condition so that we can directly aspirate our sample the next day also. Reviewing and reporting the results is very easy. Directly, we will get everything from the software. Instrument status indicator, again, a very innovative part. If you can see on the left-hand side, it is called as the early maintenance feedback, which give you a message. It will give you a message in terms of if it is a red color, it means the cleaning is required. If it is into that particular part of that ICP-MS, or in that particular hardware or stuff of that ICP-MS, for example, changing of the tubing, when we need to change the cone, when we need to clean the cone, or sometimes we change the tubings. Everything is electronically, it is logbook into this software, and it will give a indicator, just like a traffic light color, the orange, red, or the green, we will get directly from the software. Along with the ICP-M, in the ICP-MS software, there is a rare earth metal double mass correction also, which is provided along with the ICP-MS. The four important feature of any of the ICP-MS which is required for the estimation of the trace level elements in the environmental samples. You need a robust plasma in terms of so that it can provide the low cerium oxide and cerium ratio, so that you will get you can reduce the drifts, errors, and maintenance, and you will not get a false positive result. So the Agilent 7850 provide the ICP-MS provide the plasma which is highly robust with the low cerium oxide cerium ratio. Due to the patented technology of the off-axis ion lenses, if you can see, it removes the photons directly. It removes the photons and only the and accelerated the ions. So it has it helps in accelerated the ions and provide the superior sensitivity so that we can easily do any of the analysis on the lower PPT level very easily. The patented technology of the helium collision mode, it removes the polyatomic interferences so that we will not get a false positive result across all the masses from lithium to uranium. It has a 10 order dynamic range. It means all the trace level analysis, the higher percentage level we can do in a single go. This is again a patented technology of the Agilent. It is called as the UHMI, Ultra High Matrix Introduction System. Where if you can see here, we are getting the cluster of the aerosols. It is diluted with the help of the argon gas, and only the fine aerosols enter into the plasma. It means it means we can not required to go into the lab for the manual dilution, and directly we can aspirate the higher TDS sample into the ICP-MS and reduce the chances of the manual error. And now I'm going to present a very innovative use of this ICP-MS, of this technology for the authentication of T by ICP-MS. Basically, there is a requirement of the EU, that the council regulations which talk about the in terms of the protected designation of the origin. So in the ICP-MS, we have used for the analysis, and we have used the MPP software, the Mass Hunter Mass Profiler Professional software, which basically is a chemometric software which process the data and provide us the graph in terms of this particular sample is present from which particular region. So why we need to determine the geographical origin of food, and it is most important because the labeling of geographical origin of all the perishable food is required to protect domestic producer of premium products and to protect consumers from overpayment. As I mentioned, the tea which is originated in the Darjeeling region has a high potential. Most of the time when we go to the market, we are always looking for the Darjeeling tea. So that you can protect that particular product in terms of to get the, so that the farmers or the traders will get a better benefits in terms of the pricing. Despite this requirement, there is a dissipative labeling of the geographical origin is frequently detected. And last but not the least, therefore, there is a continued interest in simple but robust method so that you can determine that this particular food is origin is in from which particular region. So for to study this, we have collected the sample from 8 different geographical regions of the north and eastern part of the India. Roots region, Kachar, Terai, Darjeeling region, Toklai, Tripura, Upper Assam, and the North Bank. So we have taken close to 0.5 gram of the sample, the grounded sample. We have done the microwave digestion. And by using the ultra pure grade of the nitric acid and the hydrochloric acid, we digested those samples using the microwave digestion, using the series program steps, and then cool and we remove microwave digestion vessel and make up to 40 ml by using the deionized water. And we directly aspirate all the complete periodic table from lithium to uranium by using the ICP-MS. While doing this study, we have done the method blank and the pre-spec sample to authenticate our sample, to authenticate the results are prepared simultaneously. So we have done close to 78 elements in all the samples, and we have selected close to 150 samples. But after screening, we observed that these 18 elements, boron, magnesium, aluminium, vanadium, chromium, manganese, cobalt, nickel, zinc, selenium, rubidium, strontium, molybdenum, cesium, barium, lanthanum, cerium, and neodymium. They are the 18 elements which really help in distinguishing the origin of the tea of all these 8 regions. And during the studies, and we have used the rhodium as an internal standard, and close to 280 samples we have run in the 11 hours. So here you can see the stability of the internal standard of while running the 11 hours, and this is in plus minus 20% of the limit. This clearly indicates that there is no significant matrix deposition occurred on the interface on the cones during the sequence, and the result which we are getting are accurate results. So after running this, we have used the MPP software. Obviously, the MPP software, the first step to we have applied the principal component analysis was applied. So after applying this, all these different steps, step 1, step 2, and step 3, and the result which we will receive from this study is that I will go to the next slide. So here is the 3-dimensional principal component analysis graph. If you can see the Kachar region, the tea originated in the Kachar region, it shows that it will come here in the 3D principal component analysis, and subsequently, if you can see for the Darjeeling, Dur regions, North Bank region, Rai region, Toklai region, Tripura region, and Upper Assam region. So all the 8 different types of the teas are distinguished or discriminate with the help of the isotopic analysis. A total of the, if we can combine with the x-axis, y-axis, and z-axis, a total of 72% of the variance ratio was captured in first 3 dimensions, which is again a good sign and indicate that yes, the ICP-MS data or the results generated from the ICP-MS helpful in generating or distinguish in between the different geographical origin of the tea. When we combine this data with the 2-dimensional graph, so here again we are getting the more than 52% of the total variance in PC1 and PC3. So here you can see the tea originated from the Tripura region, Upper Assam region, Darjeeling and Dood, Toklai, Kachar, and subsequently for the other regions also. Similarly, if suppose when we done the elemental loading in the 3-dimensional graph, so these are all the 18 elements. You can see how they are distinguished from each other, and this is a clear-cut separation of the geographical origin of tea based on the elemental profiling with the help of the MPP. So after this, we have done the class prediction analysis. So class prediction analysis is a useful technique that enables unknown samples to be assigned to a previously determined group in an unbiased fashion. So MPP software include the basically into the several classes of the class prediction, like SIMCA, like LDA, like PLSDA, like SVM, and others also. So during our study, I have used the LDA, linear discrimination analysis. At the same time, I also used the support vector machine also, which is basically used and commonly used for the food and for the class prediction in case of the food. All the interpretation were carried out using non-average location value. Since all the 150 samples, I have not taken the average. I have taken the non-average value so that I will get a clear-cut picture in terms of that yes, this particular region tea is originated from that particular region or not. In order to build the model, what we have done, we have selected randomly. We have selected the 12 samples from Darjeeling and Tripura, and 18 from other regions. So remaining 24 samples from the 8 regions we have used for the accuracy of the for both prediction the model, the LDA model as well as the SVM model. So if we can, when we apply the testing, we have done the testing of the prediction model based on the SVM and as well as the LDA. You can see in most of the cases we are getting the close to 90%, which is a clear-cut indication in terms of the data generated from the ICP-MS helps in distinguishing the tea originated from this particular region. So these are the called as the labeling, which we have given to the unknown sample. But basically, these sample are from the Kachar region, and when we apply it into the prediction model in the SVM model as well as in the LDA model, you can see correctly it is predicted as this particular tea is from the which particular region. So resilient ICP-MS help in sorry. So what is the advantage of the Agilent MPP with the ICP-MS? It provides the multiple means of statistical analysis, useful for the geographical origin analysis, and PCA reduces the complex data, Microsoft data, and mass spectroscopy data into a few key variables, and data processing using either supervised or unsupervised analysis is very easy. So what is the outcome of this study? The outcome of the study is that Agilent 7850 ICP-MS provide accurate results for multiple elements in 150 samples of the tea, and which we have collected from the 8 different regions. When we are applying the principal component analysis to the larger set of data, which clearly shows that only the 18 elements are responsible, which can distinguish in between the different region of the tea. 2 class prediction models, SVM and LDA, and we have applied here, and both the class prediction model give the clear indication that about the food authenticity of the tea, that yes, this particular tea is originated from this particular region. Both models correctly identified the geographical origin of all the known test samples, including high value samples from the Darjeeling region. The elemental fingerprint method has the potential to characterize the geographical origin of a wide range of the foodstuff. Similarly, we can also do the study in different types of the foodstuffs like the basmati rice or the rice is originated in different part of the India, or different types of the spices also we can do, or sometime we can also do the floricultures, or we can also do the honey, that this honey is originated from which particular region. The result can be used to confirm the origin of the authenticate to the products, identify the products which is adulterated or mislabeled. So I hope that I have justified the time of 15 to 20 minutes which is provided to me, and now the session is open for any of the questions. Any questions, please?
Hello, any questions, sir? Then accordingly we can respond, please.
It is really very wonderful to have such insights, but our respected Dr. Jain has provided to us. Such a wonderful presentation. I request the scholars and students to clarify any doubts if you are having. Generally, we work with the very simple type DCI system. That is a basic DCI system. In our institute, it is, I think that 6840. Moinak, is it 6840? Hello?
Manoj, I think in your system, what you have, it is a GC, but today it was
yes,
more of
that
atomic.
is a GCMS and it's I mean various varieties.
Yes, sir.
So it is really wonderful to us to know that all such endeavors that is being taken up by that Agilent. Any students or scholars, any question? Dr. Misha, you put some questions. Dr. Vishesh is putting questions.
Yes, sir. Please. Sir,
Your voice is not coming properly, sir.
He is asking that why he is using nebulizer.
Okay.
So, sir, the function of the nebulizer is that basically because we know that our sample are in the liquid form. So in case of the nebulizer, the role of the nebulizer is to convert that liquid with the help of the argon gas into the fine aerosols, so that only the fine aerosols, because all the fine aerosols which are generated into the plasma, only the fine aerosols which are generated in the spray chambers, the fine aerosols only enter into the plasma, and it will not affect the stability of the plasma, and on called as the high or called as the bigger aerosols, they are drained out from the spray chamber. So the role of the nebulizer is to form the fine aerosols. Hello. I hope I have answered your question, sir.
Happened. So for changeover, we have a drop of some 1 or a half minutes. So can you please repeat once?
So, sir, in case of the nebulizer converts the liquid into the fine aerosols with the help of the argon gas. So this is the role of the aerosols, so that only the fine aerosols enter into the plasma, and those fine aerosols which are entering into the plasma are converted into the ionization. So this is the role of the nebulizer.
Very good.
Another point is you are mentioned in some places smart EMF. What is the function of why you are calling it EMF? Electromotive force or
No.
some other thing?
So
actually.
EMF is the early maintenance feedback.
Feedback.
So the early maintenance feedback, it is a smart feature of the Agilent ICP-MS. It gives an indication, the early indications when we need the cleaning of the system, when we need the cleaning of the torch, when we need the cleaning of the tubings, when we need to change the tubings. So any of the small stuffs or the consumables which we are using while doing the analysis part from the hardware part. So the software will give a smart feature. With this feature, a user can understand when he had to do the called as the replacement or cleaning of that particular stuff.
Thank you very much, Dr. Jain.
Welcome, sir.
Mainak, I have one question regarding, not regarding presentation. Yesterday, anyone wants to put any question, please? Hello? Actually, Mainak,
Yes,
hello.
Maharaj. Yes, Maharaj.
Actually, I got that very complicated feedback form. So of course, definitely we will fill it up. We will fill it up, but is it that one copy you need or you need more copies? Have you seen that Akshi has sent?
Yeah, so Maharaj, all we need is if there is any questions or any feedback from the participants and who all are interested for this technology to further discuss with us or our experts. So if that a brief list is can be shared with us is more than enough, instead of just filling the form. I mean that should
Okay.
be good enough, sir.
Surely, that we will definitely do. Yes.
Yeah.
Surely.
And we'll be definitely welcome for any questions or any further discussion on this technology, sir. We'll be happy to have that in
Surely.
future.
Yeah.
Oh, Prashanjit has joined. How Prashanjit, how are you?
Yeah, fine, sir. How are you, sir?
I am fine. After long days, I have seen him. Any other the students? Why are you not putting your questions? Actually, there. Yes, please. Yes, we will share this definitely.
Sir, you are on mute, it seems.
Now, someone has commented it, unmute me so that I can put. দেখো তো কোনো চার্টে এসছে বোধহয় আছে না? So if there is no more questions, actually our Vice Chancellor, Professor Chiranjeev Bhattacharya, so he said that he is interested, but just now he was in a meeting, so he could not join this, but I will convey this message to him. Sumana, you have any questions? Sumana? Because your lab has lot of systems. Hello?
Yes, sir.
Your lab has lot of systems. So do you have any questions?
Sir, actually, I'm working with GC and GCMS.
Yes.
That's why actually I'm not working with this AS. So I don't have any question regarding this.
Okay. So many thanks to Dr. Jain, Mr. Mainak, and Prashanjit and all others. So it's really a wonderful session. So let us go ahead with the next part of this program. Uh, shall we dictate or shall we present this?
Thank
So
you,
let
sir.
me first dictate this because that
Thank
will
you so
be
much, sir.
okay. Okay, bye. Please. Actually, we were conducting yesterday the UG students present paper presentation and session for innovative ideas. So three papers were presented. uh, Three papers were presented, but there are other two papers. So that let us finish first, and then we will go for PG students and research scholars paper presentation. So the first paper which will be presented here is life cycle assessment, and that related, paper. So that will be presented by Chirashri and group. So Chirashri, are you here?
Yes,
Hello.
sir.
Please start your presentation. You are having 10 minutes time to present and they followed by discussion. So all total 15 minutes. And
Am I
after
audible?
that, there will be waste from wealth towards circular economy. That paper will be presented. The same is the timing. Okay, please.
हाँ विनय, इसमें ये हुआ थोड़ा बहुत, but a good part is इसके
Sir, can I share the screen now?
Really.
Hello, sir. Sir, am I audible?
Oh, surely.
Hello, am I audible, sir?
Oh, surely.
Oh,
Go
yes,
ahead.
yes. Okay, sir.
Go ahead. We have started the clock. Okay.
Okay. Good afternoon, my respected audience. This is myself, Chirosri Chaudhary, a fourth-year heritage student, and my fellow classmates, Oishika Mitra and Shumona Kormukar, will present the topic today on life cycle assessment for sustainable process system. So these are the agenda points we'll be looking at. So first we'll start with the definition, then we'll move on to the relevance of LCA in sustainable assessment. Afterwards, we'll look at some case studies of LCA, and moving forward, we'll be looking at the application of LCA in various aspects of life, for say business decisions. So firstly, the definition. So the first thing that comes into our mind is what is life cycle assessment? It is a methodology for assessing environmental impacts associated with all stages of the life cycle of a commercial product, process, or system. The usage are listed down below. Now we'll talk about the relevance of LCA in a sustainable process system. Firstly, let us understand what is a sustainable process system. It is a process which do not harm flora and fauna while leaving a positive impact. The process should be reliable, replicable, and most importantly, measurable. Hence, we use some strategic decisions along with some boundary conditions involving some methodologies and in order to bring out some optimum solutions which lessens the impact on environment.
I would then like to bring the focus to a more important part of LCA, that is the EIA cycle. It's the environmental impact assessment, which, to be honest, is much more than just a process for obtaining an environmental license. Generally, to develop any project, we need an EIA report. Without that, it's not possible. But the main reason for an EIA is that it aims to minimize or avoid or offset the environmental and social impacts. This promotes a sustainable development in an area where the project is being implemented. We would now look at the generic steps, which is an essential part of every EIA cycle report. the first and foremost, the most important part is the screening. It determines whether the environmental and the social impacts of the proposed development project is significant enough. Then we do the scoping, that is to establish the boundaries, setting the basis of analysis that will be conducted at each subsequent stages. Next is impact assessment and mitigation. It evaluates the socio-economic and environmental impacts of the planned project and its alternatives. And then we identify the mitigation measures and reduce those impacts. The most crucial part is now putting all the information we have gathered through all these various stages and forming the report. After that comes the implementation, which is done in the monitoring stage, and to effectively address the project's impact. The steps of and the phases of the LCA would be explained by my co-presenter Shumana next.
Phases of LCA. Phases of LCAs are 8 phases: raw material of the extraction for the nature, product design and manufacturing of the product using the raw materials, transportation or distribution of the product to the various cities, use or consumption and maintenance of the product, and then waste management or recycling process, and final disposal, and then reuses. Next slide. Goal and scope. Life cycle assessment aims to the quantity of the environmental impact that arise from the material input and output, and also material input and output are the during the life cycle of the product, and quantity the inputs and outputs. Waste management scenarios and consider landfilling, incinerating and recycling. And also this is the first stages, 3 stages: making stages, using stages and operating stages. Analysis. Life cycle assessment of energy is an approach in which all energies input to a product are according to direct energy input during manufacturing, and also accurate and valid as it is basic set of the data. 2 fundamental types: unit process data and environmental input output data. Life cycle costing is an important economics analysis is used in the selection of the alternative for the both pending and future costs. And also life cycle cost analysis are preventing maintenance cost and operating cost, also disposal cost and initial cost and service cost. Impact assessment. The phases also: raw material extraction of the natures, then product design and manufacturing of the product using the raw material, and part of the manufacturing of assembly and use the consumption and maintenance of the product, and last end of the cycle recycling. And also considering of the renewable source of the global warming, ozone development and acidification, and human toxicity. Interpretation and evolution. Raw material extraction and acquisition is the energy and material production, then manufacturing process to uses raw material, and end of the life treatment to disposal to processing recycle process. And also the input of the step of the incineration of the major burns and the impact, identification of the hotspot in the life cycle, sensitivity analysis, evaluation of the finding and recommendation, and also according to ISO 14044-2006, cycle assessment should include identifying significant issues based on the life cycle assessment and LCIF phases, and evaluation of the sensitivity and consequently. Next, Chirusri.
Thank you, Shumuna. So this is a case study of LCA on wind turbine. So what is a wind turbine? It is a device which converts kinetic energy of wind to electrical energy. It is a clean, efficient, sustainable energy system. However, during its life cycle, energy is consumed.
Sorry for interrupting. There's an echo in the background. Could you please check?
Sure. Is it okay right now?
Not clear though.
Hello?
Not clear. Now it's
Am I
fine.
audible?
Yeah, continue.
Okay. Well, however, during its life cycle, energy is consumed and CO2 emission happens. So, LCA is conducted. This is one of an example of a 2 megawatt wind turbine, where we find that the material phase and the manufacturing phase are the highest impact contributors. So, what is the remedy? The remedy is recycling of turbine parts at the end of the life cycle will help to recover energy almost 50%, and carbon footprints will be reduced drastically. Next. Now, this is a case study of LCA in wastewater treatment plant. Wastewater treatment plant removes contaminants from domestic and industrial water to produce an effluent for further use. It is not environmental friendly as it consumes energy and chemical. Hence, LCA is done to ascertain the degree of impact and environmental benefits or water saving. One such study of a plant is done of a university campus in Rajasthan, which is a semi-arid area. Here we find out that the electricity is the highest impact area. However, if we use the treated water for irrigation purpose, environmental burden will be reduced to a great extent. Next. We all know that the management of solid waste nowadays is really important. Hence, there are many options like recycling, incineration, landfilling, and composting. So, LCA is conducted in order to find out the least impact contributor. We see from the reports, the incineration has the highest human toxicity effect due to nitrogen oxide. Landfill has a significant contribution to global warming because of CO2 emission. And from all of these, we can conclude that composting, which is a natural process of recycling organic matter, is the most environmentally preferred option. Next. Product life cycle cradle to grave analysis. Now, LC has different variations like cradle to gate, cradle to cradle, and cradle to grave analysis. The cradle to grave analysis is a full life cycle assessment from resource extraction to disposal. The main stages for analysis are raw material, processing, design, and disposal. And factors considered here are raw material use, water use, energy use, waste production, waste disposal. We must keep in mind that environment impact is the main focus. Thank you. And now I would like to hand over the presentation to Oshika. Thank you for a patient hearing.
So, in a nutshell, what life cycle assessment actually tries to answer is what environmental impact does a single object have on this world? We would go through every stage to find out what it does, right from the raw material extraction to the processing to transportation, and even in the retail and the usage phase. Apart from being a government mandated license, even corporates require to do an LCA analysis of their products. Every time we go to a supermarket, we have the question in mind: how environmental friendly is the product we actually bought? What are the raw materials involved in the process and the sources from which they are taken? This comes under the product development and the R&D portion. We should also be concerned that how the goods are transported in the first place. Is it via rail or roads or airplanes? We should focus on finding better suppliers, and the sourcing creates a massive impact on the product footprint. Even in marketing and sales, LCA forms an important part. Every time we go to the supermarket, we see products labeled green or organic or something of that sort. But how exactly or why exactly is it that? To answer that, an LCA analysis is extremely important. Even in the strategic management stage, the transport actionable insights to the top management level. They'll take the decisions to create a more environmental friendly product. I've listed some advantages and disadvantages of the LCA cycle. That is, even though LCA is the only way out, in fact, to create a sustainable report, but it's very uh, studies or case specific. It cannot be transported across similar operations, and the inventory data is difficult to obtain. So estimates need to be used at certain stages. But the goal of the LCA is to not only create data, but also to facilitate decisions. It can include production or consumption of resources like energy or carbon emissions, and it provides a complete picture of the product, process, or service. This, for now, is the only way out to determine how sustainable any case study, like my friend said, or even any product is. So to conclude, I'd like to say that LCA is a very powerful and valuable tool for examining all the associated environmental products. And it appears to be the only method for examining all the attributed environmental impacts in a singular study. We would like to consider doing such a study as our final year present project and contribute more to this. Thank you for your valuable time. I'd like to end my presentation here, and we are now open for any questions you might have. These are some of the references we have used. Thank you. Hello.
Dr. Vishesh, please put your questions. Honorable Adjudicator is Dr. Arunkanti Bishash. He was the Regional Director of CSIR, National Environmental Engineering Research Institute. Presently, he is the Emeritus Faculty of Jadavpur University School of Water Resources Engineering and also the Secretary of Vivekananda Institute of Environment Management. He serves various high-power committees representing environment. So, Dr. Vishesh, please put your questions.
Tools, what you use for the analysis of the product, any product or develop. You are mentioning that solid waste management you are doing. What type of solid waste composting you know? How many type of the composting is doing at present? Composting methodology, we are talking about the composting, solid waste management composting. Whether you are having an idea what type of composting you are doing, how many type of composting is there?
Students, could you get the question? Hello?
How many types of composting is working for the in India, in West Bengal?
We
Types
sir,
of composting, you know, have you any idea?
yes, sir, we use many biological methods such as vermicomposting or
No. You see, you have to appear for the your class test just after a few days. So this is there in that syllabus also. What are the collection and transfer and methodologies of that? I hope you have already studied. Anyone of your group? One parameter or one method? For example, whether it require oxygen, whether it not require oxygen, or such type of things. Hello?
You are not following my question.
hello.
Yes.
Yes, sir.
Composting. Have you
What?
any? Are you busy this dumping ground? Solid waste dumping ground?
No, sir, we haven't had the opportunity to do that.
The everything is from the
Online.
online.
Yes. No, that
Hello,
open,
sir.
open dumping and then other, what are the other methods?
Hello, sir. Sir, am I audible?
Yes, one is open dumping. What are the other methods?
Well, sir, actually, there are many types of composting. One uses oxygen, like aerobic, another is done without oxygen, that is anaerobic. Actually,
Yes.
through this presentation, first thing is that yesterday we didn't know that such a methodology like LCA actually exists. Now we have actually understood that this kind of LCA exists, and from tomorrow onwards, whenever we will be going anywhere, like for example we are fourth year students, so whenever we will be entering the industries, we will looking at how LCA has an impact on different varieties in different places. So
No,
basically,
Sir has questioned that whether you know the types of composting. Or you have mentioned one vermicomposting. Then with my inputs, you have told that anaerobic and aerobic. I of course that I clearly not mentioned. So these are the types of composting you know, is it? It is all right. Hello.
yes sir, yes sir.
Okay.
But you are mentioning everywhere this LCA, life cycle methodology. Life cycle, what is life cycle? Say example.
Tell what is life cycle?
The life cycle for this.
It would involve assessing all the methods it requires for its production, right from the beginning. I mean, from the sheep whose wool we are taking to what is required while transporting it, even, and so that the consumers get it.
Many things involved for the life cycle. Yeah. Very process to understand the life cycle. Then cost effectiveness. Anyway, you just try to visit our dumping ground Dhapa and see how many types of the composting is there. Not only the secured landfilling, also in solid waste management. You are talking about the solid waste management. Only composting is not the methodology. So solid waste management means including this secured landfilling also. Anyway, I will not ask any question from this wastewater management. Wastewater management is the vast subject. Then again, the question will be what type of this treatment plant system is working in our vicinity. In anywhere nearby, near Bagajatin station, you are from your college, you visit once, then you will understand what is wastewater treatment system. Otherwise, it is not everything from the
online. It is not possible. Online, it is not possible.
Online, it is not possible.
In fact, in last lockdown, our one group they took up the lake project. They visited Santoshpur and Santoshpur Lake and took the water, analyzed all the parameters they could not analyze, but at least whatever is possible they analyzed like that.
Something is another
Yes.
methodology for this life cycle parameters. Anyway,
Yes, we would like to do that for our final year project as well. So as soon as things go back to normal or we'll have a chance to visit, we'll do that. Thank you, sir.
The practical visit you did.
Yeah, it's very much necessary from what I've understood till now.
Okay.
Thank you, sir.
Next. Our next presentation is waste from wealth towards circular economy. Waste from wealth towards circular economy. Circular economy, that means how the economy can be revived. That the presentation will tell you.
Hello. Hello, sir. Am I audible?
Yes, Saptarshi.
Yes, sir. Yes, I'm starting.
Yes, yes, please start.
Yes, sir. Yes, sir.
So is it visible? Hello?
Hello.
Yes, it is visible. You carry on.
Thank you.
Okay. Good afternoon, everyone. This is Rishabh Shah from Hated Institute of Technology. My fellow team members are Akash Mukherjee, Shaptashi Kundu. Our presentation is on wealth from west towards circular economy. Now, before we start, let us first understand what does circular economy actually mean. It is a model of production which involves sharing, reusing, repairing, and recycling existing material and then used as long as possible. It can also be said as the most sustainable post-production business model. It uses natural, cultural, and manufacturer stocks to improve the social and economical factors. Different between circular economy and linear economy. Circular economy is fundamentally different from linear economy. To put it simple, in linear economy, the raw material that we process into a product that is thrown away after use. But in circular economy, we close the cycles of all these raw material. It changes the way in which the value is created and how production is made more sustainable. There are a few concepts regarding this. Number one, the era of R. In a circular industrial economy, the decision takers are the individual object owners. Their motto is to maintain the value and utility of infrastructure, building, equipment, vehicles, and other manufacturing objects. And their component of the highest level through reusing, repairing, and remanufacture are central. The era of R is modern, economical, profitable, ecological, desirable, and socially variable. In simple word, it optimizes product use through reuse and serve life extension of goods and components. The second concept, the era of D. The era of D manages stocks of atom and molecules with the objective of maintaining the highest value and purity of the stocks. It implies a cultural change in waste management from volume reduction to value capture and non-destructive collection of used good and unmixed collection of used material, which increases the profitability of the resources come waste management. MFC. MFC is the gadget that convert natural issue to power utilizing microorganism as the biocatalyst, and the MFC technology is based on the redox reaction. There are two types of MFCs mentioned here. Number one, single chamber, and number two, dual chamber. For explaining these MFCs, my fellow team member Shaptashi Kundu will take on the presentation now.
Thank you, Rishabh, for giving me the opportunity. Now I'm going to explain what is a single chamber MFC and dual chamber. Basically, the MFC are classified on the basis of the number of chambers. One is a single chamber, another is the dual chamber. Now, single chamber is a kind of MFC where the basic anode compartment and cathode compartment are not separated by means of proton plate film. There are permeable cathode shapes one side of the mass of the cathode using oxygen from the air and letting proton diffuse through them. Now, dual chamber MFC. In a dual chamber MFC, the electrodes are separated by ion selective membrane, such as proton alternate membrane that approves solely protons to pass through it and now not to the solutions of the microvector. The other common design of twin chamber MFC, where hydrogen fraction meeting our anode with the anode in one phase and the cathode in the other. Now, the basic differences between the dual and a single chamber MFC. First, the absence of membrane in a single chamber MFC. Second, in a dual chamber, different conditions can be maintained in each compartment, whereas it is not possible in case of the single chambered one. The rate of oxygen diffusion into the anode without an ion permeable membrane, that is a single chambered MFC, is 2.7 times higher than the double chambered design. The advantage of a single chambered MFC is the reduced setup cost and also the higher power output. The main disadvantage of a single chambered MFC is a low coulombic efficiency, generally because of diffusion of oxygen into the anode, that is the consumption of oxygen by the bacteria. Now let us move to the basic anode effects of an MFC. The microorganisms plays an important role in the anode chamber. The microbe in the anode chamber produces H plus ion, that is proton, also electron through the responses by disintegrating the rich organic exhibit in the wastewater. The methodology of it is a methodology of treating wastewater. The most frequent use of material in the anode are the carbon materials, example graphite, fiber brush, carbon cloth, etc. The anode reactions is summarized below. As you can see, the biodegradable organics are broken down into hydrogen and electron. Now let's move to the next one, that is the cathode effect in an MFC. The proton produced in the anode chamber migrate into the cathode through the proton exchange membrane, which complete the electrical circuit. The electron travels from the cathode to the anode chamber and transmit onto oxygen. The cathode reactions are also as follows. Let's discuss some of the factors that affect the MFC performance. Firstly, the electrode material, as it was explained in the anode in the next slide, in the first slide. Then the equipment configuration, the amplification material, and also the substrate. These are the some of the main factors that affect the MFC performance, which is it's depicted in this chart. Now let's move to the next one. There are various losses in an MFC, mainly ohmic loss, activation loss, concentration loss, and the microbial loss. The ohmic loss happens because of the protection from electron move through the membrane electrode assembly and protection strength stream of the material through the CEM. Activation loss, also known as the activation loss, happens at whatever point a response happens and the cathode surface. The concentration loss is, or the polarization loss, happens at a rate for the imposter transport of species to alternatively from likewise for far concerning illustration conceivable breaking point present in the era. And finally, the microbial loss over an MFC, minute creature transport electrons starting with an substrate at low possibility to keep it going through the electron acceptor. Now I will hand it over to my fellow teammate Rishabh Shah to conclude the presentation. Rishabh, please.
As petroleum sources are consumed, energy crisis encourage researchers in the world to consider for an alternate source of energy. Moreover, using of fossil fuel can cause environment pollution. Clear fuels significantly used fuel cell or biocell, a new source of energy without any pollution, is suitable replacement of traditional fossil fuel. That's why that's when MFC comes in place. MFCs are one of the nearest technology to produce energy from different sources. The generated power in MFC is still too low, and researchers are working to improve it for commercial applications. These are the few references we have taken. Thank you.
Okay, your presentation is nice. You are mentioning the waste to wealth. What type of waste you are utilized in practically to wealth? Say example, solid waste or liquid waste. How you converted it to the wealth with your technology?
Hello, sir. We mainly intend to use wastewater here as the substrate which is present in the microbial fuel cell. So there are many organic compounds in the wastewater through which in the microbial catalysis we can produce electricity through MFC.
वो तो बहुत दूर का बात है. Recently, whether Have you visited any wastewater treatment system or place? Now
No,
only,
sir.
huh?
No, sir.
Yes. Where?
No, sir, we haven't.
You first visit wastewater treatment place or solid waste management there. That how
sir.
to convert this solid waste to the wealth. How to convert? We are converting this waste water to wealth. Then your labor will be fruitful. You are
Yes, sir.
writing very nicely. It's a very ornamental writer. But real life, you are not visiting any wastewater treatment plant. You are not seeing the solid waste management near Dhaba. In your college, near to your college, Dhaba is there. As one you visit, how you are converting this solid waste to the wealth.
Sure, sir. So
Yes.
actually, due to this pandemic situation, we couldn't start it like that.
Only energy.
Sure, sir.
From there, electricity is very far away. But real life real hand we can utilize these solid waste or liquid waste for the development of the surroundings. Anyway, your paper is
Sure, sir.
it is ornamental paper. Okay, এই তুমি বলো ওনাকে বলো ডেকে বলে দাও করতে হবে। করেন
Thank you very much. So this students presentation session is over. Now we will go to the PG state students and research scholars presentation. Our Dr. Dash has joined. Hello. Yes, Dr. Dash has joined. So Dr. Dash will conduct that session. Sir, did you get the participants list?
No, the presentation list.
Presentation list page. So accordingly, from that 1 to 7, you can carry
Yes,
out.
okay.
It's a 10 minutes presentation.
Yeah.
That will be sufficient for actually 6 o'clock. We are having another session. So if it is, if you can finish it by 5:50, that will be the best.
Okay.
Yes. So please carry on, sir. Dr. Professor Shudip Kumar Das, he was earlier head of the department of University of Calcutta, Department of Chemical Engineering. He is also the treasurer of Indian Chemical Society, founded by Acharya Prafulla Chandra Ray. And he several times he was a council member and also the secretary and treasurer of All India Council of Indian Institute of Chemical Engineers. He has so many papers. He has at least about 15 PhD he has guided. So he is a very acclaimed scientist. So with this, but apart from that, he is a very good man from his heart. So he is always associated with our Vivekananda Institute for all the activities. Today, the reunion of our Calcutta University Chemical Engineering Department is going on. Still, because of the students' interest, so he has agreed. I told that all the papers are from Jadavpur University, mostly or CGCRI. So it is better that since he is from not from that university, so he should judge and guide the students. Okay, sir, please carry out.
Thank you, Swamiji.
Yes.
So welcome to all in the National Symposium on Engineering Technology Management. So, dear participants, that in this session there will be seven lectures. 7 presenters will present their work, mainly PG students and research scholars. So time limit is 10 minutes plus 2 minutes for discussion. So I would like to invite the first paper, synthesis of dope layer double hydroxy. So please report
Yes,
the first
sir.
presenter.
Am I audible?
Yeah. Please, your name?
My name is Ohika Mondol.
Ohita, okay.
Yes, sir.
Okay, go ahead.
Is the presentation visible?
Yeah, visible. Go ahead.
Okay. Good evening, everyone. I am Ohika, and today I'm here to present on the topic of doped layer double hydroxide synthesis for removal of arsenic 5 and arsenic 3 from water. The experiments have been carried out in membrane laboratory in the Chemical Engineering Department, Jadavpur University. So coming on to the introduction slide, it doesn't require to tell that water is the most essential necessity of mankind and which one cannot put a price on. But we have to understand that there is a very limited resource for drinking and potable water in the world. And now with the ever-growing population and industries, water contamination is now a global concern that requires a very, very progressive and rationalized evaluation at all levels, because it is one of the main causes of infection and mortality in living organism. So there can be a number of heavy metals that can contaminate water, and arsenic is one of the most toxic and carcinogenic element which can contaminate water. So in India, there are several states that are affected by arsenic and other kinds of contaminants. I have added a bar graph to show this. So there exists quite a few procedure to treat the contaminated water. We can categorize them into 3 major categories. I will not discuss this elaborately here. So coming on to the membrane filtration process part, we know that there are 4 major categories here. One is microfiltration, then ultrafiltration, nanofiltration, and reverse osmosis. And among these 4, reverse osmosis is the most efficient one that can separate out all the inorganics and all the minerals from water. It can separate out the smallest iron and the heavy metals ions from the water. But we have to understand that the operating cost and the capital cost of reverse osmosis is very high because it requires a very high pressure. So the aim here is to replace RO membrane with UF membrane so that it can give high efficiency for arsenic removal but can operate in lower pressure range. So I'll talk about the synthesis procedure. About the adsorbent, I will try to incorporate in the UF membrane, which is in my case layer double hydroxide nanoparticle. And so coming on to the LDH, layer double hydroxide part, first we have to know what is it. So LDH are basically 2-dimensional layered nanomaterial that belong to anionic clay family. The general formula of LDH, I have written it here, and the M2 plus and M3 plus indicates the divalent and trivalent metal cations, and X is the ratio of M2 plus and M3 plus. ANs are the interlayer anions that can exist in the structure, and M is the number of water molecule that exist in the interlayer. So the possible types for metal cations in LDH depends on their radii, on their size. The divalent metal ions that are found commonly in the laminates can be magnesium, it can be nickel, zinc, iron, cobalt, etc. And common trivalent metal ions that can found in LDH are aluminium, iron, manganese, chromium, etc. So there exists a very weak force in the interlayer region, and the anion exchange ability of LDH depends on the type of interlayer anions. So the polyvalent anions are easily inserted into the interlayer space, while the low valent anions can be easily exchanged. So if we talk a little about the structure of LDH, it has a brucite-like structure. Brucite is MgOH2, magnesium hydroxide. The neutral layers in LDH are stacked upon each other, and if substitution of some divalent ions in brucite structure occurs by trivalent ions by isomorphic substitution, then it can result to the formation of a positively charged mixed metal hydroxide layer. And the intercalation of anions in this interlayer region, basically, it can balance the residual positive charge in the hydroxide layer. So the structure resembles like this now. So coming on to the advantages of LDH as absorbent, there are quite a few. So it is a nanomaterial, it has a large specific surface area for adsorption, and also the characteristics and properties are flexible and adjustable. The layer spacing is adjustable, and also the composition is adjustable sometimes. So we can tune it accordingly, and it gives good anion exchangeability, and it has also like high adsorption efficiency, and the synthesis procedure is quite simpler compared to other material, and it costs lower. So the experimental work which have been carried out in the lab is, I have synthesized two types of LDH. One is the pristine magnesium aluminum LDH. A lot of studies and reports have been published on this pristine LDH. So there is, nothing extra which I can enlighten about this kind of LDH. But the second one which I have synthesized in lab is the manganese doped MgAl LDH. So I have doped it with manganese to see if it shows better removal compared to the pristine one. So the materials which are needed for this synthesis procedure is magnesium nitrate and aluminum nitrate salts, and some kind of base. In my case, I have used sodium hydroxide and water. And for the second one, along with this material, we just need magnesium nitrate salt, which is extra. So for the synthesis procedure, I have followed the co-precipitation method. There are quite a few methods as well, but I think it is the most advantageous method for my case. So firstly, I have prepared the salt solution separately, and I have mixed them. Then I have increased the pH of the mixed salt solution using the sodium hydroxide, and then I have kept the solution under vigorous mixing for around 24 hours. Then I have centrifuged the precipitate, and then I have dried the precipitate at 60 degrees centigrade for 24 to 48 days, and then I have crushed it, and we have the synthesized final products here. This is the pristine MgAl LDH, and this is the manganese doped LDH. So for the removal experiments, what we have done is, like, we have prepared a series of arsenic 5 solutions with different initial concentration at ambient temperature. Then a dosage of 0.5 gram per liter LDH were dispersed in the solutions. Then they were shaken until the equilibrium was reached, and the solution were centrifuged and filtered, and the initial concentration and final concentration after treating it with LDH, we have measured the quantity of arsenic. And we have prepared 6 number of solution with different initial concentration. Ci indicates the initial concentration, and Ce dash and Ce basically indicates the final concentration after treating the solution with pristine MgAl LDH and the manganese doped one. So these are the results, and this is the adsorption isotherm which I have drawn. And this blue line, this blue plot is for the doped one, and this one is for the pristine one. And as we can see, this doped LDH gives a lot more absorption efficiency removal than the pristine one. So then I have used the Langmuir and Freundlich isotherm model to see if in which model the data is fitted best. So this is the Langmuir isotherm and this is the Freundlich isotherm. And for the I have seen that the R-square value in Langmuir isotherm is more than the Freundlich isotherm. So we can say that it follows the Langmuir model. So it indicates that the adsorption is a physisorption and multilayer adsorption is occurring here. So for the removal mechanism, as I was not able to do all the characteristic studies on this LDH, I cannot say for sure what removal mechanism this LDH is following. But as the previous studies shows, LDH is good at anion exchange. So mostly the separation occurs by the interlayer anion exchange, and in some doped material, it has also been reported that some surface complexation mechanism also occurs. So what happens is that the OH group in the surface is getting replaced by the heavy metal ions, which is present in the water. And in the interlayer as well, there the anions are exchanged with each other. And the interlayer anion is getting replaced by the metal ion. So after that, I have studied that graphene oxide and other kinds of adsorbent nanocomposite can work as a very efficient adsorbent. So I have tried to I have tried to prepare a nanocomposite from LDH and graphene oxide as well. So for that procedure, I followed these simple mechanisms, this simple process. So firstly, graphene oxide and the LDH in 1:2 ratio was added in 100 milliliter water, and then the solution was ultrasonicated.
Wow, 1 minute left.
To prepare the dispersion well, and then it is centrifuged and the PPT was washed off, and the drying was done at 60 degrees centigrade, and the product was we get after drying. The product we get after drying. So this leaves for a lot of future work as well. As I have said before, the characterization studies were not done properly. So I need to yet include all the data of characterization analysis. And also I am planning to incorporate the composite in the UF membrane and adsorb. I am also trying to study the adsorption for the other heavy metal as well with arsenic. So, and we have to see the economic and industrial aspects of it as well. So that is the end of my presentation. These are some references I have used, and this is the acknowledgement, and thank you.
Okay, thank you very much for your very excellent presentation.
Thank you.
Now the paper is open for discussion. If anybody can ask any question. So what is basic difference between membrane separation and adsorptive separation?
Yes, sir.
What is basic difference between membrane separation and adsorptive separation? Because you are using the adsorption mechanism, all these things, Langmuir adsorption, isotherm.
Yes, sir. So the in membrane filtration process, what happens is basically for the first three I mean the microfiltration and ultrafiltration, nanofiltration, sieving mechanism occurs, right? Depending on the pores of the membranes, the contaminants, the pollutants in the water are trapped in the membrane, and we get the filtered, treated water. In the adsorbent, for the adsorbent process, I mean, there is a gap where we have to, like after the treatment, we have to filter out the adsorbent as well. So my thought was, if I incorporate the adsorbent in the membrane itself, then there is no need for the filtration after the process, right?
No. Why we called it a membrane separation? Adsorptive separation.
Yes, sir.
The mechanism is adsorptive. You are applying the absorptive mechanism.
Yes,
So
sir.
it should not call the membrane separation. It's adsorptive separation. We do good adsorbent.
No, sir. I mean, I have said before, the reverse osmosis is like the most efficient one, right? But we need a lot of pressure for reverse osmosis. So my aim was here to replace reverse osmosis membrane, RO membrane, with ultrafiltration membrane. So I mean, I have understood your question, but after the adsorption by any adsorbent, we have to filter out those adsorbents from the water itself, right? But if we incorporate the adsorbent in the membrane itself, then we don't need to do that part afterwards.
No, I am not very convinced because membrane is not an adsorptive process.
Yes, sir, it's not. I mean, I am using it
Again,
as a filter.
the Langmuir adsorption is monolayer adsorption. Application of Langmuir adsorption is a monolayer adsorption. Bentley's adsorption is a multi-layer adsorption. So think about that. Okay, thank you very much.
Okay, sir. Thank you.
Our next presenter, I don't have the full name also here. So an overview of gene expression alteration in plants. That's.
Am I audible, sir?
Yeah, you are audible.
Okay, sir. So can you see my screen?
No. Previous screen is already there.
Okay.
Ms. Mondal, please close your screen.
So yes, sir. Once.
Is it visible, sir?
Yeah, visible. Oh, go ahead.
Okay, sir. Myself, Ardhantu Kundu. I'm going to present a paper entitled An Overview of Gene Expression Alterations in Plants Following Electromagnetic Irradiation. The paper is authored by myself, Professor Bhaskar Gupta, and Dr. Amirul Islam Mollik. Okay, so why should we investigate EM irradiation-induced gene expression alterations in plants? Basically, humans are primarily exposed to cell phone or near body antennas exposure, and these antennas are emitting very low level of RF power with adaptive control, like minus 92 dBm to minus 102 dBm. And if you convert it to milliwatt, then we can convert it using this particular formula. So this is a typical screenshot of my mobile phone that I have taken on 24th of November and at Hooghly, West Bengal. So here you can see that through this particular settings, you can find out the radiated power level from your mobile phone. This is typically at that particular range. However, in case of plants, crops, and fruits, they're getting continuous exposure to EM irradiation from multiple cell tower antennas. And those are simultaneous exposure at 900 megahertz, 1800 megahertz, 2.15, 2.35, 2.45, 3.5, 5.2, and 5.8, respectively, if we think of sub-6 gigahertz communication. So basically, plant tissues are possessing very high permittivity and electrical conductivity or loss tangent due to presence of water, liquid substances, and free ions. So here we have measured the permittivity and loss tangent of different coconut tissue layers. So basically the green skin of the coconut, then yellow pulp region, and the fresh waters. So these are the permittivity curve for 3 different tissue layers, and these are the loss tangent. Now, basically, plants are possessing quite high surface to volume ratio compared to humans and any other animals because of taking more amount of light and gases through their leaves. And thus, the electromagnetic energy absorption rate capabilities, that is the specific absorption rate that we get in our cell phone for human head. Here we are trying to characterize for different plant models. In plants, fruits and flowers are quite high or at least comparable, while we compare it with the human phantom model. So here, this is a basically a typical plant model that is exposed to a linearly polarized plane wave radiation. And as per the FCC, or Federal Communications Commission guideline, at 2150 megahertz, and this is the specific absorption rate distribution, or basically the electromagnetic energy absorption rate distribution, how that is getting distributed on the model. Now, thus, it is very important to investigate and discuss the electromagnetic irradiation induced biological responses in different plants, be it at molecular level, or at gene expression level, or at physiological level. Because earlier we have already established in literature that plants are absorbing sufficient amount of electromagnetic energy like humans. So now, what is the consequent biological effects at molecular or gene expression levels that we need to find out? So in next few slides, we'll find out those things. So here we are going to discuss EM radiation-induced molecular responses or gene expression alterations in different plants. So this is the first paper where in the figure you can find out this is a mode stirred reverberation chamber. This is basically a metallic chamber, and the metals can completely reflect back the unintended electromagnetic radiation that is present in the open environment due to different wireless communication systems. And we are completely enclosing this particular region, and there is no unintended radiation inside this metallic chamber. So this is a huge chamber with these dimensions. Now there is a particular antenna. This is number 2, and there are stars which are basically rotating at 3 different axes. And this is a plywood chamber in which we are trying to grow a tomato plant up to 3 weeks. And then basically this wooden chamber, in this small wooden chamber, is basically electromagnetically transparent. So electromagnetic energy can go through this plywood chamber. And this is the controlling system. So these tomato plants were grown up to 3 weeks, and then they have been grown with a photo period of 16 hours to 8 hours dark at 26 degrees centigrade during the daytime and 21 degrees centigrade during the dark night time, with 150 micromole per meter square per second inverse light intensity. So the plants were transferred to the mode stirred reverberation chamber 24 hours before conducting the electromagnetic radiation exposure experiment, so that there is no stress due to the movement procedure. And for control or SAM exposed plants, we are trying to basically enclose this particular wooden chamber with aluminum foil, so that aluminum foil is having a very high conductivity, and as a consequence that will also reflect back the radiation from this antenna, and inside that aluminum foil there will be no radiation almost. As a consequence, this will be acting as a control sample. Finally, we'll be collecting after the exposure the control and EM treatment plant leaf samples, and that will be frozen in liquid nitrogen immediately. And this total experiment has been replicated 3 times. Now, the radiation exposure is at 900 megahertz frequency with amplitude of 5 volt per meter and 40 volt per meter depending upon the cases, and the duration of exposure is in between 2 to 10 minutes. Then we are sampling the leaves, and we are extracting mRNA, and then cDNA synthesis is done, and finally we are doing the RT-PCR test. So to find out the expression of the targeted stress sensitive genes, and those genes are actin, chloroplast mRNA binding protein or CMBP, calmodulin, and proteinase inhibitor. Basically, actin is the housekeeping gene with respect to which we are trying to normalize the expression for other targeted genes. So here you can find in these 3 curves at your right that this is the expression for, the first one is the expression for calmodulin gene, second one is CMBP or calcium mRNA binding protein, and this is the chlorophyll mRNA binding protein, and this is the PAN2 or proteinase inhibitor, and the black bars are basically the irradiation treated bars, and white bars are basically the control samples. So here you can see after 15 minutes of exposure, if you collect the sample, then there is upregulation of the EM radiation treated sample of calmodulin gene. And after 30 minutes as well as after 60 minutes, if you collect the samples, there is a significant upregulation of the gene with respect to the control. The similar phenomenon is observed in case of CMBP and PIN2 as well. Now, if we want to find out if there is a dose-dependent relationship, because these are the results due to the 900 megahertz 5 volt per meter for 10 minutes of exposure. Now, this is 40 volt per meter for 10 minutes at 900. This is 5 volt per meter for 10 minutes, and this is 5 volt per meter at 2 minutes. So you see, for both 40 volt per meter and 5 volt per meter for 10 minutes of exposure, the upregulation is significant at 15 and 30 minutes. But for 2 minutes, it's not that much significant and very close to the control samples. Thus, it is seen that EMF could constitute a genuine stress factor on tomato plants, similar to injurious treatments like leaf flaming or electrical stimulation or insect bite. Calmodulin is basically a major receptor of Ca2+ and plays an important role in early events of cell stress responses, whereas CMBP and PIN2 are expressed after wound, such as flaming or insect bite, etc. Thus, EM radiation is perceived by plant as a stress factor. However, no direct link is found between EM amplitude and gene expressions. Thus, it is an all or nothing concept. Now, in case
one
of
minute left.
Okay, in case of busy factor, they have been also exposed due to the radiation exposure. Now, these are some of the references where you can find that the radiation is basically upregulating these particular genes. So these are some more references. Now, this experiment we have conducted at ISER Kolkata on Swarnaprabha rice plants. So these are 40 days old rice plants, and they have been exposed to 2 or 30 minutes radiation at 1837.50 megahertz with 2.75 milliwatt per square meter. And these are the control. So here you can find out this is basically the radiation room, and this is the control room separated by a metallic maze. And this is the radiating antenna, and this is the RF signal generator. So these are the primers that we have used for RT-PCR test and synthesized. And finally, these are the results. Here also you can find that the calmodulin gene is upregulated along with BG, phytochrome B, and phytochrome C. And this is another experiment where you can find that we have periodically exposed the rice plants up to 12 days or up to 32 days with 6 hours a day radiation. And here also you can find that PIN1, phytochrome B, and phytochrome C, these genes are upregulated for 12 days old, and calmodulin, CDPK1, and phytochrome C and phytochrome B, these have been upregulated due to the periodic exposure. And finally, this result here you can find that due to the one-time 2.5 hour exposure, here in case of Shatabdi rice plant, the BG gene is upregulated along with CDPK1, phytochrome B, and phytochrome C. So how to minimize the microwave plant interaction for a sustainable growth? Here, what you can say, basically the short duration as well as long duration EM radiation induced alterations in stress sensitive gene expressions should be investigated at a larger scale with associated physiological responses. Thus, the EMR dose dependent relationships can be understood in a better manner. Next, the minimum feasible power density that is sufficient for seamless wireless connectivity, that is another primary factor. And effective implementation of smaller cell size with more of frequency reuse, that is, we need to install more number of cell towers, and each of the cell tower antenna is emitting less amount of electromagnetic power. And once we understand the EMR dose dependent relationship at molecular and physiological levels, we need to reevaluate and harmonize the existing global and national electromagnetic regulatory guidelines to protect plants along with humans. So thank you so much. This is my contact information, and I'm open for questions.
Thank you. The paper is now open for discussion. Anybody have any question, please ask. So I am asking one question, that is particularly in the case of rice or tomato, whatever you did the experiment.
Yes.
It is hampered the production rate.
Sir, actually here we can find that this
the early stage you did the experiment.
Phytochrome B and phytochrome C, these are getting upregulated. So if these two genes are upregulated for rice particularly, then it can reduce, it can delay the flowering stage. So at the flowering stage will be delayed. As a consequence, if we think of 120 days or 125 days of total life cycle of a particular rice plant, then if the flowering is getting delayed, then maybe the total crop production may be reduced. But I have not gone up to that stage. I have studied up to 32 days or up to 40 days of radiation exposure. Okay. But actually, it is the interpretation that we have found with the experts.
Yeah. Okay. Thank you.
Thank you, sir.
If there is no question, so Thank you, Mr. Kundu, for the very excellent
Thank you.
presentation.
Thank you, sir.
So we go for the next presentation. ये बताया सबने क्या था? Next presentation. Fermentative conversion of COOH, carbon dioxide hydrogen gas mixture.
Yes, sir.
Yeah.
Sir, am I audible?
Yeah, audible. Your name is Dibyendu, right?
Dinabandhu, sir.
Dinabandhu, acha,
Yes,
Dinabandhu.
sir.
Dinabandhu?
Yes, sir.
Okay, go ahead.
Yes, sir. Good afternoon, sir. I am Dinabandhu Manna, under the supervision of Professor Ranjana Chaudhary, ma'am, Chemical Engineering Department, Jadavpur University. Today, I want to discuss about the topic in this area. The Sustainable Development Goals have several 17 aspects. So our focus is in the 7: ensure access, affordable, reliable, sustainable, and modern energy for all. So lignocellulosic biomass is an interesting feedstock to produce syngas. Lignocellulosic biomass containing lignin, cellulose, and hemicellulose, and small amount of pectin and ash. The huge potential of our country that agro waste can be available 587459 kiloton per year. Now we can categorize lignocellulosic biomass into two parts. One is post-harvesting residue and another is post-processing residue. For example, for rice production, rice straw is post-harvesting residue and rice husk is post-processing residue. Now we can categorize the feedstock in the basis of lignin. Lignin can give the rigidity of the stem. So here it is high lignin, medium lignin, and low lignin. So it can be different by the regional variation and also the seasonal variation, because rice can be produced 3 times in a year in India, and there is some difference between region also. So, suppose it is different between district wise also. Now we can concept that is that if we go for biorefinery, we can go through these 3 platforms: sugar platform, carboxylate platform, and combined syngas platform. Sugar platform is that we can pretreat, acid pretreat or alkali pretreat or salt pretreatment in the lignocellulosic biomass first to expose the xylose and glucose, and then it will be fermented by the microorganism, and then bio alcohol, it is bioethanol or biobutanol or higher alcohol will be produced. Carboxylate platform, we can go through the via fatty acid generation, and from there we can produce the biofuel. And syngas platform is the hybridization of thermochemical and biochemical platform. Thermochemical is platform like pyrolysis or gasification. First, rice stock we can gasify or pyrolysis. So syngas is produced at 700 degree to maybe 900 degree centigrade in that range, and then we can collect the gas and then it will be ferment. So if the lignin content is very high, we does not go for sugar platform, then it will be go for syngas platform. This is the pathway. This is called Wood-Lungdahl pathway, via which the CO2, H2 can be synthesized in this way. But the major challenge is that CO2 and H2 is in gaseous phase, but the solubility of H2, the mass transfer from the gaseous phase to liquid phase is a major challenge, and the microorganism that can be convert that gas into alcohol is rarely available. That is namely Clostridium carboxydivoron, Clostridium lungdahli. So our aim is that to optimize the kinetic parameter. We use the Monod kinetics and also Halden, and we use mixed consortia. We collected from paddy field, agricultural field level. We collect some mud, and then we can several repeatedly experiment. We can isolate UAC, JuChe1. And this our material, this is our RCM, reinforced Clostridium medium, peptone, meat extract, yeast extract, sodium chloride, L16HCl, sodium acetate, and this is resin, and we can prepare through according to ATCC. And we have in our lab carbon dioxide and hydrogen cylinder, and we produce the simulated gas mixture, and there is we can use the argon also, and from there we can use that gas. So this is our schematic diagram. Modified reinforced Clostridium medium has we have a setup for 300 ml first, and 10% the inoculum we have charged initially. Then from the top we have the by water displacement method, we from the overhead we purge the gas in the system, 150 ml gas and 150 ml the broth medium with inoculum, and then we will be in the incubator in 37 degrees centigrade. It will be in different time, batch time 4, 8, 12 up to 24-hour batch time. Then we will come out that broth, and then we centrifuge at 5000 RPM for 5 minutes, and from there supernatant should be separated, and the dry cell weight we can collect, and supernatant we go for the absorbance for the further analysis. And this is our experimental setup. In the left, it is our control only media, reinforced Clostridium media, and this is our setup. And we can clearly visualize the change of the color. And so it is the confirmation that bacterial growth has been arise. So initially, the partial we started with a fixed CO2 70%, hydrogen 20%, and argon 10%. Then partial pressure of CO2 should be reduced up to 40%, and from there we can by dicel weight. Here we measure the biomass concentration, and at 10 minutes, this is the maximum the concentration we have achieved. and also the as the inoculum is compatible with this fermentation route, so there is no lag. And then we vary the hydrogen percentage when the CO2 is fixed, and then it is up to 40 to 10%. But here we see that the biomass production reduced because H2 have an inhibitory effect in the system. And then we plot the biomass, initial biomass concentration and final biomass concentration in the log plot versus time. And here we can see that our all R square is greater than 0.95 up to 9 hours. So we can generate, as we can assume that this is the straight line equation, and we have the straight line equation. This is for hydrogen, and we go for RSM method, and then in one axis partial pressure of hydrogen, in another axis it is partial pressure of CO2, and another in specific growth rate.
One minute left.
Yes, sir. Then this is the optimum parameter value, the maximum from there, monod and combined Halden model we have studied, and maximum specific growth rate 0.45, and monod constant is 0.09 atm, and CO2 4.8 atm, and inhibition constant 0.1. So the conclusion is that we achieved that successfully Clostridium that mixed culture has been grown in our media. And we also combine the monod and Halden model. Those are references, and thank you so much.
So thank you, Dibyendu, for your excellent presentation. Now the paper is open for discussion. If you have any question. You carried the experiment synthetic, that is from cylinder, you take the carbon dioxide, hydrogen, all these things, okay?
Yeah, yes, sir.
How it is feasible in a commercial scale?
Sir, actually, this is simulated, and also we are doing.
It is simulated. Practical.
In practical,
sir, you cannot do the simulated thing, na?
Yes, sir.
You have to bring the carbon dioxide from maybe from power plant with a lot of other materials.
For real syngas, we have lab scale pyrolyzer, and we generate also the syngas, and we are doing pyrolysis, and at different temperature we are fermenting this session and this media, and it is also successfully run, sir. And we are doing for large scale implementation for Aspen modeling, and there are some also gasification plan, and they are trying to feasible that this process is feasible. So we are trying that for experiment pyrolysis. We collect the gas, and it initially the gas is very hot, then we cooled, and then we ferment, so it will be coming, sir, a good result also. And we are going for Aspen modeling, our next plan of work, sir.
Okay, thank you very much.
Yes, sir. Thank you so much.
Our next presentation is pyrolysis. Pyrolysis of FR4 type printed circuit boards.
Hello. Yeah,
okay.
I'm here. Just a moment, sir.
Yes.
Is my screen visible?
Visible.
Okay.
Go ahead.
Thank you. Shall I start, sir?
Yes.
Okay. Thank you. Good evening. Myself, Bishwajit Devnath. So I'm going to present on pyrolysis of FR4 type printed circuit boards, sustainable metal recovery. This is the outline of my presentation. So introduction. So what is electronic waste? Electronic waste is any end of life electrical or electronic equipment and their accessories that have a power source and or require a power source for functioning that can be defined as e-waste. So it is also known as WEEE, that is waste electrical and electronic equipment in the waste. So different geography, different name. If you look at the numbers, in 2019 itself, nearly 53.6 million metric tons of e-waste was generated. And it is predicted that by 2030, it will be 74.7 million metric tons, which is equivalent to, I mean, the 2019 generation was equivalent to 5,445 Eiffel Towers. If you look at the BRICS nations, so they generated nearly 33% of the total e-waste generated, and India itself generated 3.23 million metric tons, which is the second highest in the world. Now, if you look at the compositions, it is composed of several things: metals, printed circuit boards, cables. But we are focused here on the printed circuit board part because it, first of all, it consists of nearly 3 to 6% of the total weight percentage, and there's a lot of copper, gold, and silver present there, which the concentration is 10 times than in the natural ores. That's what makes this good candidate for urban mining. So types of printed circuit board, there are several types of printed circuit boards present, but these two types of printed circuit boards are used widely in the industry. One is the FR2 type and the FR4 type. The FR stands for fire retardant type. So we are focused on the FR4 type, which is the epoxy based, and it has an extra layer of multiple extra layer of glass fibers, which give mechanical strength. So this is a quick overview to give the idea of the source. The FR2 types are used in old desk TVs and other small electronics, household electronics, where the sturdiness is not important. And on the right side, you see the our day-to-day electronics where the FR4 type printed circuit board is used. Now, this is an general or a holistic composition of printed circuit board. So you can see it contains a lot of metals, ceramics are there, plastics are there. So it's a hodgepodge matrix. So metals are there, plastics are there, so we need to recover these resources. So if we look at the literature on the printed circuit board, so we will see, sorry, yeah, if we look at the literature, so this is the basically this is the pyrolysis scheme. So while we're doing pyrolysis, it's getting through, it's going through a thermal cracking process. So it generates the volatiles. From the volatiles we get the pyrogas and the pyro oil, and the residue we get there we can recover the metals and other stuff. So if you look at the literature, as I was saying, in the recent literature, the literature is highly focused on the type of reactors, oil yield. Sometimes it's looking at a certain amount of a particular metal, something like that. But what we find the research gap here is that in most of the cases that the source is not clearly mentioned. It says that the type is not clearly mentioned, whether it is FR2 or FR4. They say it is from computer, it is from mobile, that's all. And the second thing is, in an overall way, how the material recovery can be done from FR4 type printed circuit boards, that has also not been clearly mentioned, or types of the study are scant. So coming to the research questions that we formulated, so how pyrolysis can be helpful for FR4 type PCB treatment? What are the different fractions that can be recovered, and what are the potential reusability of these recovered fractions? So the objectives are to find the composition of the FR4 type PCB, to study the pyrolysis of FR4 type PCB, and to identify the potential required fractions and their reusability. Now the experimental part. So as you can see on the right hand side, the motherboard was taken, and it was from all the electronic components were removed using plier and other tools, and then these were cut into small pieces which were used for our experiments. So in the pyrolysis process itself, we have a pyrolyzer, which it contains a preheated furnace. It is a fixed bed type reactor. So the temperature, we conducted the experiments at different temperatures and found that 623 Kelvin is the perfect temperature, or the optimum temperature for resource recovery. Nitrogen was introduced at 1 to 2 LPM to maintain the inert atmosphere. The residence time was 30 to 45 minutes, and the setup was attached with a bulb condenser and followed by two auxiliary condensers where pyro oil was recovered by rinsing with acetone after the reaction, of course. And then the residue which we got after cooling down, of course, there were crushed, sieved to recover the carbonaceous part first, and then later the metals and other glass fibers were recovered. For recovery of the glass fibers, we had to because those were laden with carbonaceous particles, so we had to burn them at a higher temperature to remove those carbon particles, because those were next to separable. So coming to the results. So first the characterizations. So same analysis was carried out to understand the surface morphology. As you can see, there is a rod-like structure of the non-metallic fraction. So the same was carried out of the non-metallic fraction only. And the pyrochar, if you see on the second picture, the pyrochar, you can see there are pores distributed over the surface. So there is a possibility that this char can be used for absorption purposes. Coming to the next, the EDX was carried out. So from the EDX, we found both basic and rare earth metals are present. Copper, tin, and iron are available in the majority, and some noble and rare earth metals were also present in the PCB. So this was carried out with the raw PCB, ground raw PCB, not the pyrolyzed version. So and platinum and titanium are also present there. So this is the so we can see there's a lot of amount of a lot of different types of metals are present in printed circuit boards. FTIR was carried out for the raw PCB and the recovered pyro oil as well as, and we can see that there are different types of materials present there. The left hand side one is the raw PCB, and the right hand side one is of the pyro oil. So the most important thing is that the phenolic compounds are there in the phenolic, because this one particular one is based on epoxy resin, and there are many phenol groups there. So that was identified in the PCB itself, and in the pyro oil itself, we found phenolic groups as well. So in the oil, phenolic compounds were recovered. So this is the approximate or the andesite analysis of the FR4 type PCB. So the ash content is very high. So the carbonaceous part is comparatively low. That's why the tar and gas are also comparatively low, but the residue is very,
1 minute is left.
Yeah, I'm almost there. So it's so we can see the ash is there. So that's the most important part. So these are the recovered fractions. So we recovered char, metals, and glass fibers, as well as pyro oil from the experiments. So as we can see, the residue of the pyrochar contains char, glass fiber, and metals, and we recovered all these things successfully. And these needs a little bit more of downstream processing for further application. 623 Kelvin was found out as the suitable temperature because the highest oil yield is in this particular temperature. And from the same images, as we mentioned, that it could be a good potential candidate for adsorption, and literature is already there that has been done. So it supports that, and the oil contains some phenolic compounds and unsaturated ester as well, so which is a potential source of chemicals. To conclude, pyrolysis is a greener alternative to incineration. We found that 623 Kelvin was the most suitable temperature. The char obtained is useful as adsorbent. We could recover the glass fibers and metals as well, and the oil contains a lot of phenolic compounds and unsaturated esters, etc. So those are potential source of chemicals, and so pyrolysis could be a very sustainable technology with high resource recovery potential in the future, especially with respect to electronic waste. I would like to thank my guides, and Professor Ranjana Chaudhuri and Professor Shazan Kumar Ghosh, and also West Bengal State Fellowship Scheme for funding my research. These are the references. Thank you.
Thank you, Vishwajit Devnath, for your nice presentation. Now the paper is open for discussion. You didn't try for the heavy metal or precious metal collection?
No, my part, sir, basically my primary aim is to recover as much resource as possible. So what you were trying to say is for the downcycling, I mean, the downstream processing of the charts and others. So I could not approach that way, but surely I will try my, in my next ventures, I will try to do that.
Because this time in Olympics, all the medals are prepared
Yeah,
from
yeah.
this material.
They were all recovered from the mobile phones.
Mobile phones.
Yeah. In 2018 itself, it was announced that they will do it from the e-waste. So it was a beautiful example of urban mining.
Circular economy also.
Yes.
So if there is no question, so thank you, Vishwajit, once again for your very nice and excellent presentation. Thank you.
Thank you, sir.
Our next paper is MgAlTi oxide composite nano adsorbent for multi-metal adsorption process, I think.
Good afternoon, sir. Am I audible?
Yeah, you're audible.
I'm sharing my screen now. So, hello everyone, I'm Shomapraj Banerjee, and I will be presenting my work on MgAlTi oxide composite nanoadsorbent for multi-metal removal. The metals in questions are arsenic, lead, cadmium, and iron.
Your skin is not visible.
I have already shared my screen, sir.
No, not visible.
Is it visible now?
No. Maybe some problem in my computer also.
I'm going to share it again.
I'm closing my computer again. I am joining. Maybe
it is visible. I think it is visible.
maybe the problem in my computer. Maybe. Okay.
Is it visible now?
Now it is visible. Okay, go ahead.
So I will be presenting my work on MgAlTi oxide composite nanoadsorbent for multi-metal removal from water. So first I will be talking about heavy metal toxicity and the causes for this. So most of the heavy metal toxicity that comes into our environment, our soil and water, is by anthropogenic activities like excessive mining, wastewater, irrigation, and application of chemical fertilizers, pesticides, etc. So from the target metals I have chosen, arsenic has the most impact on our environment and our water consumption. Arsenic pyrite oxidation due to fluctuation of the water level through exploitation of shallow or main aquifer is one of the main reasons for arsenic toxicity. And other heavy metals like cadmium, zinc, lead, iron in groundwater comes from leaching from the discharge effluent, leading to serious health applications. And then there are natural causes like volcanic activity, metal corrosion, metal evaporation from soil and water sediment, resuspension, etc., contributing to the heavy metal toxicity in our environment. So the common methods for heavy metal removal are like precipitation, where metal ions to insoluble hydroxide, sulfide, and phosphate carbonate, etc., are prepared, and those insoluble chemicals are then separated by filtration. A similar method is coagulation and flocculation, where positively charged coagulant is used to reduce surface negative charge and then make the suspension coagulate, and then flocculant is added to bind the positively charged aggregates, and then they are filtered out from the solution. Then comes adsorptions. Adsorption materials with high porosity or surface area and active functional groups are used to entrap metal ions either by van der Waals force or chemical reaction on bond formation. Then there comes ion exchange and membrane separation, where resins with strong sulfonic acid group, and in case of membrane separations, nanofiltration, RO, FO, or
Okay, I second it.
Yes, sir.
Yes, go ahead.
So I will now talk about adsorbents for heavy metal removal. So adsorbents have large surface area, high adsorption capacity, which can be achieved through nanoparticles. Major adsorbents for arsenic are metal oxide composite, carbon nanotubes, etc. So I have shown the process of adsorption through the simple flow chart, and it occurs in either single step or in combinations of steps such as film or external diffusion, pore diffusion, surface diffusion, and adsorption on the pore surface. So the objective is synthesizing a nanoadsorbent with high absorption capacity for removal of toxic heavy metals, a stable metal oxide composite adsorbent nanoparticles for arsenic separation and other hybrid applications, and manufacture a nanoparticle with by using a scalable process, so we can minimize the dose and minimize the cost and ease of manufacturing. And lastly, understanding the adsorption mechanism of prepared novel metal oxide composite nanoparticles. So in previously in literature, alumina, titanium, and magnesium oxide has been separately used as adsorption before, but the study in trimetallic composite oxides had been very rare in recent literature. Also, porous kind of nanoparticles happen to have large surface area, and the pore volume helps in capturing more ions in the way that can be used to maximize the heavy metal capture. So my adsorbent was prepared by evaporation induced self-assembly method, a sol gel method where we use a block copolymer as a soft template where the metal oxides self-assemble themselves to create a certain structure. This is a method process of a little modification of a process made by Yuan et al. The nanoparticles were calcinated at 400 degrees and 900 degrees centigrade. So this is the XRD of my nanoparticles. As you can see, the 900-degree calcined nanoparticles showed higher crystallinity and different phases, which match with the hogmomite phase. Hogmomite is a mineral, naturally occurring mineral in which contains the three metals, magnesium, aluminum, and titanium. So we can say that that a combined phase has been created. In 400 degree centigrade calcinated material, the crystallinity is little lesser, which can be seen from the noise in the XRD and lower and then less number of peaks. But from that, we can identify that the cubic phase of magnesium oxide has been visible. Then the BET surface area has been calculated. So 900 degree calcinated particles have lower surface area, but 400 rich particles, 400 degree centigrade calcinated particles have higher surface area. And from the isotherms, the hysteresis loop suggests that the 400 degree calcinated particles have H2 type hysteresis loop, which are characteristics of mesoporous materials. In 900 degrees centigrade, the hysteresis loop change, which is characteristics of slit-like pores. So we can say that higher temperature calcination changes the pore geometry of the nanoparticles. Here is the SEM and EDX of my particles. From the same particle, the approximate size was seen to be less than 10 nanometers. So for a better morphological study, HRTM image will be necessary. So I will be doing that in future. So from EDX, we can see that that three metals are metal precursors, which I have used, are present in the particle in almost the same ratio, 3:1:1. I used in the synthesis. Now I come to the adsorption isotherms in equilibrium study. So the nanoparticle has shown tremendous adsorption capacity for all the metals I have chosen, especially for arsenic 5 and arsenic 3, which has given a very high adsorption capacity. And for lead and cadmium also, it has shown extremely high capacity in comparison to other existing nanoparticles. The adsorption capacity for iron is little lesser than other target metals, but it is still a lot higher than other reported nanoparticles. Now I have done a study for competing ions, as in groundwater there will always be other ions which will compete for the adsorption sites. So I have so far used the competing ion study with arsenic 5 effluent, and as we can see that little decrease in arsenic absorption has been shown with other competing anions present in the water, but it is still the adsorption capacity is still pretty high. even with competition. And we can see that the decrease in adsorption capacity is not that much, showing the nanoparticle have selectivity for arsenic 5 ions. Now I have done some FATI characterization to try to explain the mechanism. As we can see that the particles after immersion in water changes in hydroxide form. So we can see a large peak at near about 300, 3,500, and this peak is characteristics of hydroxide OH vibrations. So we can see that the nanoparticle after immersion in water carries a lot of OH groups, and after the adsorptions, that broad and long peak of OH group disappears. So from that we can say that the OH groups work as sites for adsorption. So in case of anionic species, OH groups are gets protonated, and OH2 plus groups act as adsorption sites for anionic metal species.
We have 1 minute left.
So I will come to my conclusion. So as you can see, 400-degree calcinated particles are mesopores, which transform to slit-like pores when calcinated at 900 degrees centigrade. The nanoparticles have high surface area and favorable pore size distribution. Nanoparticles are showing very high adsorption capacity, especially with arsenic 5 and arsenic 3 with respect to other existing adsorptions. And the process is scalable and cost effective. So we can think about industrial applications, and with other large scale pilot scale experiments after studying pilot scale experiments. So I would like to acknowledge the National Symposium on Engineering, Technology and Management and Chemical Centenary Celebration of Chemical Engineering Department for this platform. I also acknowledge my guide, Professor Chiranjeev Bhattacharya and Dr. Ranjan for their very valued advice and support. The DST for the funds and other group members of Membrane Research Lab. These are the references. Thank you, everyone.
You please go to your first slide, front page of the slide.
Yeah, sure.
Now the paper. Thank you, Mr. Banerjee, for your nice presentation, and I like to invite audience. If there is any question is there, please ask the question. You prepare the oxide composite by sol gel technique, yes?
Yes, sol gel technique with a soft template as a polymer, a block copolymer is a soft template, so that the metal ions orient themselves with a self assembly according to the structure of that template. So after calcination, the templates goes away and the metal oxide structure remains.
What is the BET surface area of this metal oxide?
BET surface area of 400-degree calcium samples have been near about 175 meters square per gram.
So it depends on temperature.
Yes, I have seen that higher temperature calcination reduces the surface area.
That's right. Okay, thank you very much.
Thank you, sir.
For your nice presentation. Your name is?
Somokraj Banerjee.
Somokraj Banerjee. Okay, thank you.
Thank you, sir.
Our next paper is experimental studies on power plant blue-green algae, I think.
Yes, sir. Yes, sir. I'm sharing mine.
What's your name?
So my name is Shumona Das.
Sumona.
Just a minute, sir.
Okay.
Sir, is this visible?
Yes.
Okay. Good afternoon, everyone. Myself Shmona Das. I am pursuing PhD under the supervision of Professor Ranjana Chaudhary, Chemical Engineering Department, Jadavpur University. Now, it is everyone's concern that from the last decades, it is observed that the increasing level of greenhouse gas emission to the atmosphere is due to rapid industrialization, growth of industrialization, and which is a great threat for climate change. And in this pie chart, you can see that the maximum level of atmospheric CO2 emission is from industrial sector as well as from transport sectors, that is almost 65%. And in case of industries, mainly includes the coal fired thermal power stations are the main prime source of CO2 emitters in into the atmosphere. So in order to reduce this CO2 emission, I'm using some biochemical process to capture this atmospheric CO2 using algae. And why I am using this algae? Because this algae has a capability to uptake a high atmospheric CO2 concentrations from the atmosphere, and it also grow very fast. It is available everywhere, and from this algal biomass we can extract lipid also, which can be further used for production of 3G biofuel, that is biodiesel, etc. And from the biomass we can also produce some biochemicals like plant pigments like chlorophyll, beta carotene, xanthophyll, etc. And from the extracted oil we can also extract this omega-3 fatty acids, that is DHA, DPA, etc. Thank you. And then next is the research gap of this study is very few reported studies are available on power plant algae, and no studies are available on slow pyrolysis of power plant algae for production of biochar. Now come to the next slide. This is a integrated system of a algal cultivation unit. Here in this picture, you can see that from the coal-based thermal power plants, here the algae very efficiently capture the CO2 and produce using this algal cultivation unit. We use this algal biomass for oil extraction processes for further production of biodiesels or any pigments of pyro oil using this some other residue algal biomass. And using this pyrolysis process we can convert this algal biomass into pyrochar, pyrogas, as well as followed by the gasification, fermentation, and anaerobic digestion method. We can also produce syngas, alcohol, hydrogen, and methane also. Here I am using this algal strain, which is mainly collected from the water bodies of Sagardigi thermal power plant, that is Leptolingia subtilis JUCHU1. And this is basically cyanobacteria and having a size range of 0.5 to 60 micrometer. Now come to the next slide. These are the aims of my experimental work: determination of biomass and lipid production behavior of Leptolingia subtilis during photoautotrophic growth in batch reactor as carbon source, determination of values of growth kinetic parameters, namely mainly mu max, Ks, Ki of this algal strain, and lastly determination of the yield of pyrochar from the pyrolysis of dry algal biomass of Leptolingia subtilis by varying the temperature from 300 to 700 degrees Celsius. This is the overall research scheme of my experimental work. Here, I followed two different processes. First one is biochemical process, which mainly includes the cultivation, harvesting, and extraction, oil extraction processes. And the other one is thermochemical process, which mainly includes after extracting the oil, the residual biomass is used for pyrolysis process to obtain the biochar. These are the methodology of my experimental work. Biochemical process mainly includes the batch mode experiment conducted under photoautotrophic condition. The batch study, the experimental setup is 250 ml of conical flask, which is equipped with two glass tube for gas exchange. The parameters are CO2 concentration. The liquid phase of CO2 concentration is 1.24 to 4.95 millimolar, and the gas phase concentration is 5 to 20%. Light intensity is 2.5 K lux, and incubation temperature is 37 degree Celsius. The experimental study have been carried out for 0 to 5 days as a culture duration, and after that the respective interval the oil have been extracted from the dry algal biomass. After collection of algal biomass, the dry algal biomass have been depigmented with acetone and ANH solution in 3:4 ratio. After that, using the mixture of chloroform and methanol in 2:1 ratio, the biomass have been homogenized in homogenizer, and after that the centrifugation, the rest of the supernatant has been collected, which containing the solvent and oil part, and put into the hot air oven for evaporation of rest of the solvent. Sorry. And the thermochemical process mainly includes the pyrolysis process. After oil extraction, the 1 gram of dialgal biomass have been used for pyrolysis process in semi-batch reactor under isothermal condition. The pyrolysis temperature have been vary in the range of 300 to 700 degrees Celsius. The reaction time was varied from 5 to 20 minutes, and the residual mass constituents have been measured, and the biochar was also measured. These are some of the calculations which I have used in this experimental study for conversion of gas phase to liquid phase concentration of CO2. The Henry's law have been used, and this here the monode model have been used for determination of growth kinetic parameters. And the second one is in the thermochemical process, the first order kinetics have been used to calculate the weight of residue and the weight of char.
1 minute left.
Yes, sir. Now come to the result part. This is a biomass concentration versus time plot. Here you can see that with increase in CO2 concentration, the biomass also increases up to 15% of CO2, and after that it declines. That is the growth get inhibited. That therefore the maximum biomass concentration has been observed to be 0.27286 gram per liter at 15% on third day of cultivation. This is the mu versus S plot and double reciprocal plot of monode equation. Here using this, you can see that with increase in concentration, CO2 concentration, the growth rate also increases up to 15%. After that, it declines. That means this follows a Halden model. Up to the monode model, up to 15%, it follows the monode model, which has been used for calculation of mu max and Ks, and that is 0.6064 day inverse, and K is the value of K is 0.0165 gram per liter, and the inhibition constant, the value of inhibition constant Ki is 1.7429 gram per liter. Here in this bar plot, you can see that with increase in CO2 concentration, the lipid also increases up to 15%. 15%, that is 12.5% lipid content is the highest at 15% CO2 as inlet concentration. Now, here in figure 4, you can see that with increase in temperature, in a plot of weight of residue versus time plot, the weight of residue of dry biomass was decreased with increase in temperature, whereas the volatile weight of volatile versus time plot, with increase in pyrolysis temperature, the weight of volatile matter increases with time, and the amount of biochar varies from 26 to 44% as the pyrolysis temperature is decreased from 700 to 300, and the maximum biochar have been obtained to be 44% at 300 degree Celsius. Now, these are the conclusions. The major focus of the present study was to determine growth kinetic parameters and monitor the lipid accumulation ability of the blue-green alga Leptolimbia subtilis by varying the CO2 concentration range from 5 to 20%. The maximum biomass concentration have been obtained at 15% CO2 concentration, and the as I already previously mentioned, the mu max Ks value is 0.6064 day inverse, and the Ks value and Ki value is 1.7429 gram per liter. The maximum lipid concentration is 12.5% in at 15% inlet CO2 concentration, and the biochar maximum biochar is 44% at generated at 300 degrees Celsius. So therefore, we can say that this Leptolimbia subtilis is a very fast growing blue-green algae and also accumulate lipid very efficiently, and is a very classified as oleaginous species, and a potential source for biofuel as well as biochemical production and also biochar. These are some of the references which I've been using this presentation. Thank you.
Okay, thank you, Sumana, for your very good presentation.
Thank you, sir.
This paper is now open for discussion. If you have any question, you can raise the question. So my question is,
yes, sir.
We are preparing the biochar. Biochar is 45, I think 44% at 400 degrees centigrade. It depends on the temperature. If you increase the temperature, biochar amount will raise.
Yes, sir. If I increase the temperature, then the biochar yield of biochar also increases in this algal strains. For this algal strain, I think.
For the quality of the biochar.
That
if you use for the adsorbent purpose, then the surface area or morphology changes. Depends on temperature. Depends on temperature.
That I not yet, sir, analyzed now.
Yeah. No, any idea from literature?
No, sir, I don't have any idea.
Okay, thank you. Thank you, Subhana, for a very excellent presentation.
Thank you, sir.
Our last presentation on the subject of jute industry derived biochar for treatment of metal bearing effluents.
Yes, sir. Am I audible?
Yeah.
I'm sharing my screen. Gudiya. बस ठीक है ऑडियो ऑन है yeah. Good afternoon, everyone. I'm Dr. Lata Ramrakhani from CGCRI. Good afternoon, sir.
Good afternoon. Very good afternoon, Lata ji.
Yeah, sir. Sir, today I'm going to represent the absorption study using jute industry waste derived biochar for heavy metal removal. So the next slide. Now the jute, what is jute caddies? Jute caddies is the waste material derived from the jute industries. It is a unspinnable tiny jute fiber, dust particle having in it machine oil, greases and other things. Normally these jute particle or the jute caddies are the biodegradable material, but it is not that much harmful to the environment. There are various recyclable application is suggested in the literature, like production of fuel for the boiler, handmade paper, composite, biogas, bioenergy production, etc. But nothing has been commercialized for the large scale level. Now the proposed application is biochar development for the toxic heavy metal removal for wastewater treatment. Now this is the biochar developed from the jute caddies. Now this is the research activity. The jute waste was collected from the nearby industry in Howrah, that is Gloucester jute mills, and the carbonization is carried out by the sulfuric, using sulfuric acid, not by the pyrolysis process. And the bioabsorption study was conducted for various metals like zinc, lead, copper, nickel, cadmium, cobalt, etc. And the developed biochar was also used for real effluent treatment from electroplating industry and the jute industry. And the bioabsorption removal mechanism was studied using various analytic techniques like XPX, SRF, FESM, etc. Now, the final part is for the circular economy is the fate of metal linden bioabsorbent. So, zinc linden spent biochar was used as a micro fertilizer for the plant. So, this is my total research activity. Now, this is the characteristics of the biochar developed from the jute caddies. It is showing very low surface area. It is only 0.32. It's a fibrous material and non-porous material, low cost and eco-friendly, but it's showing high removal efficiency of metal removal. Other also characteristics features like particle size, zeta potential, carbon nitrogen ratios, Raman spectra, all and XRF analysis were also carried out. Now this is the optimization results of bioabsorption study. It shows more than 99% removal of various heavy metals, studied heavy metals, and the optimization was carried out for the zinc removal studies using various environmental factors like pH, solid ratio, liquid solid ratio, that is biomass value, that is around 10 gram per liter. Then isotherm studies and kinetic studies were also carried out. It shows means the R square for the Langmuir and the Pranjich is almost similar, and that is 0.96 and 0.94 respectively. So it is it's showing the monolayer as well as the multi-layer absorption of the metals on the biochar surface. Now this is the point of zero charge, which is studied by zeta potential method, and it shows a negative zeta potential value. That means the biochar has no charge at different pH. Now this is the Raman spectra of the developed biochar. It is shows the partial graphitic nature. Graphitization is partial because D band is also appear as a disorder structure of the amorphous carbon, and the slight increase in the D disorder means the D band shows that the presence of zinc metal on it. Now this is the FESM characterization. It shows a fine shiny particle on the surface of biochar after zinc absorption, and the zinc peak is also appear by EDEX analysis, and this is the mapping structure of the zinc, which just shows the even distribution on the surface of the biochar. Now this is the XPS analysis. The XPS scanning spectra of zinc-leaded biochar shows the peak of ZnP2 and 2p peak. And this is the third graph is for deconvolution of the zinc 2p, which shows the means compounding structure, that is Zn oxide, Zn silicate, and the zinc sulfate on its surface. Now this is the FTIR spectra, which confirm the presence of amine, carboxylic, phosphate, hydroxyl, carbonyl, and sulfalhydryl group on the biochar surface and control biochar surface, and the shift in the peak of the groups like amine, carboxyl, and phosphate indicates that these three groups are mainly involved in the zinc remediation. Now, we have collected 3 different effluent from electroplating industries and characterized for metal ion content as well as the other physiological parameters like TDS, COD, BOD, and other things. So in the electroplating effluent mainly contain zincs, which is in the high concentration like 168 ppm, 132 ppm, and third effluent is 45 ppm. So our doublet biochar shows similar efficiency, that is more than 95% removal in the real effluent system also. So the biochar is very efficient for the remote treatment of electroplating effluent. Now the management of zinc, this is the picture of effluent before and after treatment. Now this is the management of zinc loaded spent biochar. So this is carried out as a micro fertilizer for the plants. So we have collected the garden soil, which is considered to as a control soil, and the 10% weight, 10 weight % control biochar used as a control biochar mixed soil, and variation in 5, 10, and 15% of zinc loaded biochar mixture for zinc microfertilizer. So we can see the difference in the growth pattern also. Adding with the addition of 10 and 15% of zinc linden biochar shows higher growth in comparison to the garden soil control biochar. So this is the growth parameters obtained from the results of a pot experiment. It also shows the germination rate, means increase in germination rate, that is around 40 to 50% increase in the germination rate of the plants in the soil, as well as the increase in the total length of the plant also observed. Now the biochemical and physiological parameters like protein concentration, chlorophyll content also slightly increased in the 15% loaded zinc linden biochar and 10% loaded zinc linden biochar. Now we also conducted the antioxidant enzyme activity like superoxide dismutase enzymes and catalase enzymes. These 2 enzymes are the indicator of the stress level, means identifying the stress level in the plants. So if there is an increase in these enzymes, this shows that the plant is facing the stress level, and the zinc is having, due to zinc, and zinc shows some toxicity. But we have found there is no increase in the these enzyme activity level in the plants of the plant. 15% incorporate means grown 15% zinc linden biochar grown pots. So that means this much level of zinc is suitable for the plant growth, and it is not toxic for the plants. Now this is the concluding remarks from our study, that the jute waste derived biochar was used for the electroplating industry effluent and produce the clean water. Then zinc linden biochar was used as a microfertilizer. So it will complete the circular economy for the industries. And this paper has been recently published, means it's going to be online in next month, in clean technologies and environmental policies. Now, we can conclude that the utilization of jute caddies activated biochar for metal zinc removal and exploit the microfertilizer. This will help in converting waste to wealth. And this is the green and clean process for waste management in line with Swachh and Swachh Bharat mission of our country. Now, my future plan is development of hybrid technology for wastewater treatment involving absorption unit integrated with ceramic membrane microfiltration process, elucidation of bioabsorption mechanism, heavy metal removal study in more other real water systems. Then desorption study also will be carried out using biochar for the biochar regeneration and spent biochar management studies. Now, this is the prototype we have developed for the integrated technology. The study will be conducted in this prototype for real effluent treatment. And this is the ceramic membrane module, and this is the adsorption unit. And treated water will be collected in this plastic container. Now, the acknowledgement, I will thanks the DST for financial support, DST Women Scientists 2B scheme, and CSIR also, and the director for giving me the permission for conducting this project, and all the member of membrane separation and technology division. Thank you, sir.
Thank you, Lataji.
Thank you, sir. How are you, sir?
Fine, sir.
Yes.
Fine, ma'am. Fine, ma'am. This is
Yeah,
an excellent presentation from Delhi West to Wealth, and
Yes.
also it directly explain the possibility of circular economy.
Yes,
What is
thank-
circular economy? How can utilize this waste material to a valuable product? So this is a classical example project presented by Lataji.
Thank you, sir.
So thank you very much.
Hmm.
So I can conclude this session. There are seven papers. All are excellently presented in in this conference, and I congratulate all the speakers for their work, especially lastly the Lataji. He is our colleagues in different places. We have worked together. So thank you, Lataji, and thank you all the speakers.
Thank you very much, sir.
And also the thank you, Swamiji, to introduce me in this platform once again. This year actually we are busy in our department. As alumni association conducted a international seminar 17, 18, and 19. So we are busy there. So we could not join this program this year. So once again I thank you. Thank you all. Thank you, Swamiji.
Thank you, sir.
Thank you.
We have already contacted Dr. Kunal Sharkar. Dr. Kunal Sharkar is a very, very celebrated cardiologist. And in fact, you can say the most famous cardiologist of this country. And still he has so much, you can say, love for education and academic matters that whenever we request, sir has extended his hands in form of lecture and in form of other mode of service. So he is traveling. Presently, he is in Agartala. So he is traveling. He just rang up to me a few minutes before and said that I shall be joining just. Meanwhile, Devolina is also here. So we can have the Devolina's self-introduction already. Of course, we have already circulated the book, that is a book of abstracts. there all these things have been printed, but still we can have some before presentation some one-to-one interaction with Devolina, and then when Dr. Sharkar join, then immediately he will start his lecture. How is that idea, Devolina?
I'm okay with that, but I still have a few things to work on my presentation. So if I present
you can
after
switch,
Dr.
yes, or surely, yes.
Yeah. Good morning. I mean, it's good
Yes.
morning for me. Good evening for all of you.
Yes. Surely. Carry on. You tell about little bit of your alma mater and your present work and all these things.
Yeah.
Some
So
reminiscences regarding your alma mater. if you can remember.
Of course. And it is
Yesterday we have a
privilege.
very exhaustive session. So where we used to take classes and I mean we used to attend the classes. So that same room we sat, and then our teachers, we were some of the teachers we were very much afraid of, but they this time they were very gently they I mean talked to us, and that was a, you can say, memorable experience. I have had all the photos and the videos of that we will share just after say a few days, I mean 2-3 days, and I will upload this in our Vivekananda Institute channel also. Yes, Devolina, please continue.
Yeah, so it is a privilege to be presenting at the centenary celebration for Jadavpur University. Of course, like I'm much younger alumni. That's the way I would like to think, but it's been almost 20 years. I'm a 2003 graduate from the Chemical Engineering Department. I did decide to study further, and I completed my PhD from Louisiana State University in 2010. So those were very interesting times because when I joined Jadavpur University, I was focused on just going through 4 years of college and then getting a job and then settling down probably somewhere. But life had different ideas. So after 4 years, when I joined a software company, I felt the need to be back in chemical engineering very much. So that's where I'm still working in chemical engineering field. I did after my PhD, I worked with the United States Environmental Protection Agency, where we did science for policy for quite some time. And then I came back into the Texas A&M University system. Here I've been working on the transition energy, natural gas for the past 7 years. I've been developing research as the Associate Director of the Gas and Fuels Research Center. So the Gas and Fuels Research Center was set up in association with Texas A&M University and Texas A&M University Qatar, because Qatar is one of the largest natural gas reserves in the world. That made it very much timely, and our efforts have been geared towards natural gas. Some of the work I'll be explaining in my talk today. And very recently, right after COVID hit, it was a very difficult time and a game-changing situation for a lot of us. So we have been moving into disaster resilience space and looking at resilient systems modeling, optimization, and the similar types of work in food, energy, water systems. So we are looking into disaster resilience in food, energy, water systems currently. Anything else that you would like to know? Maybe I'll stop my video if that's okay at this time.
Actually, Dr. Sharkar told that I will be joining by 5-7 minutes. Actually, he is in Agartala and he is traveling. So there is some little bit of delay because of this. Otherwise, you were supposed to join at 6 o'clock. So but is that our time is also limited. That is let me ask you once again. Ask him once again. So we are eagerly waiting, and now sir has joined, Dr. Kunal Sharkar. Dr. Sharkar has needs no introduction. In fact, we are organizing this program. The one issue is very much there, that is sustainability. And regarding this sustainable life system, Dr. Sharkar is the greatest support. Dr. Sharkar, হ্যাঁ স্যার আমি দেখে নিয়েছি স্যার চালু করে দিয়েছি Dr. Sharkar is the greatest support for the humanity, and that's why and he is so busy, but still he has so much love for the academic sessions. So whenever we request, he comes and joins. So without any delay, let us request respected Dr. Sharkar, Dr. Kunal Sharkar, to start his presentation and also address the gathering. Sir, please. Sir, you are muted.
Am I audible now? Can you hear
surely.
me?
Oh, surely. Surely, sir.
Thank you. Maharaj, thank you. And first of all, thank you again for thinking of me, to sharing a few of our thoughts with your gathering, who are always thinking, ideating, and exploring many aspects of science, human life, sustainability, and survival. My apologies for being a little bit late, because we were traveling today, and we are somewhere in the vicinity of Darjeeling, as I tell you. It's rather cold. But the place is wonderful. The roads were terrible, a little bit like the life that all of us lead. I wanted to share a few thoughts with you, about probably no matter what we talk on today, from cinema to cooking, from sports to communication, from entertainment to electronics. I think the world right now is completely obsessed, engrossed, and very anxious with one worry. And that one worry is the worry as what the new COVID variant is going to unleash on the human world. It is already unleashing itself on the human world, and what may or may not be in store for us in India, and how do people read the early signs of what are the shape of things to come. Now, there is no point, going back into the origin or the genesis of this problem. There are many divergent versions. There are not many. There are a couple of divergent versions as to how humanity way into the 21st century found itself at peril of this. Is it been man-made, or has it been a kind of a zoonotic disease which skipped species and affected human beings? You can subscribe to any of the stories that goes around,
But I, for my purpose, I'm quite convinced that this is almost a self-made problem. This is almost a self-made disaster. But having lived to it ever since, I think, 13th of January, which was 2020, when the World Health Organization first declared this to be a pandemic, and a few weeks before that, this original virus, the Wuhan strain, was identified first in the University of Shanghai, and thereafter, and almost the very same day, it was identified in a university of Bangkok. Rumor has it that this, first of all, let us understand from the scientific perspective, that if this has to be a kind of a man-made disaster, then what led us into it? We need to understand this concept. And what led us into this disaster? One theory is, because look, many of us were fed with the bat theory in the beginning. It was said that the bats are a reservoir of many viruses, and the coronaviruses are nothing very rare. Coronaviruses, the influenza virus that we deal with or have dealt with for millions of years, is a coronavirus. And somehow many of these viruses find an animal reservoir in the bats. So it was originally being touted around that one of the scientists who was researching with the bat viruses somewhere helped this in the transmission of the virus from the bat to the humans. There could have been an intermediary species involved, but there were a lot of holes in that story. And one of the principal holes in the story was that there are areas in China, in central China, which have bat caves and infested with bats, etc. But that was thousands and thousands of miles away from the epicenter where it all began. That was in the Wuhan, the Wuhan Virological Institute. So why did we lead ourselves down this path? We led it because of competition among scientists and competition among scientific institutions. What was the nature of competition amongst the scientific institution? There is a term in science which is called the gain of function research. What do we mean by gain of function research? You see, every genetic material, every life form is evolving over a passage of time. And we have been gained. You know, it was just by the way, people often discuss that how is the 2020 pandemic different from the pandemic we saw 102 years ago, 1918 to 1920, 21. You see, the essential difference is one word, and that word is knowledge. Because somewhere in 1897, 1898, the world first got an idea what the viruses originally were. In the days of Robert Koch, in the days of Louis Pasteur, people who pioneered the study of original infectious theory of disease, microbiology, etc. What did we believe before that? That why do we fall sick? You see, before we had the idea, before we had the concept that the microbes unseen to the human eye are the main causes of the infective diseases, the medieval and the pre-medieval world used to believe in a theory that was called the miasma theory. What is the meaning of the word miasma? The word miasma basically means bad air, foul air. So whatever happened in the very beginning, if you look back to the ancient Greeks, the early Romans, every disease was attributed to religion, the curse of the gods. And over the next few centuries, when we started thinking about the cause of disease, especially from Hippocrates to Galen to Vesalius in Middle Europe, then from being the curse of God, it became the kind of foul air in the circulation. And that was the miasma theory, which stayed in circulation for many centuries. And it was only in 1896, 1897 that we had an idea, before that, a few years before that, we had an idea what bacteria were. And bacteria, the work regarding bacteria were done by many people, principal amongst whom was Robert Koch, Louis Pasteur, etc. Later on, towards the end of the 19th century, we had a basic idea that, look, there can actually be infectious agents which are even smaller than bacteria, and these were called the viruses. We had no idea. Look, we were thinking of microbial agents smaller than a bacteria. We were thinking of viruses. There were some very, very primitive chromatographic techniques which enabled some initial photographs of a virus, imprints of a virus. If memory serves me right, that technology used to be called diffraction chromatography or something like that. But it was not until 1934, 1935, that the first electron microscopy was possible. So just go through the evolution of science. We have thought about a virus. We don't know what a virus actually is. What does it? What is it? What is its constitution? We are thinking of the virus, and a good 15 years after the previous pandemic dies down, that through the work of a couple of scientists, much of the work of early electron micrography was done in Russia, was done in Soviet Russia, that we are able to get into the structure of a virus. So that is a difference. The difference between the 1919 pandemic and the 2019 pandemic basically is what is called knowledge. In the century that has gone in between, we have learned about the ultrastructure, and we have also learned that these ultrastructures are prone to change with time. Whoever you believe in, God, nature, evolution, that is constantly, you see, these building blocks of life, these ribonucleic acid, based on a simple repetitive sequence of 4 bases, adenosine, thiamine, cytosine, guanine. So these 4 it's like your binary code comprises of 0 and 1. The human genetic code comprises of these 4 letters, A, T, C, G. And it is A, T, C, G happening in different combinations that constitutes the great variety of life. And as we were saying, that it was in 1930s that enabled that we have the first electron micrography picture. And just think about it. It is not for another 20 years that till we have Crick and Watson from University of Cambridge was awarded the Nobel Prize for the structure of DNA and structure of RNA, the famous right-handed helical model, the Watson-Crick model of the fundamental of life. When did that happen? 1953. And look how science traverses. Think about the journey of science. We have to wait till 2005, 2006, till the first complete map of the human genome is done. But probably what enabled this business was the Watson-Crick's work from University of Cambridge that defines the right-handed helical, double helical structure of the DNA. And then half of it is called the RNA. And we know that the RNA and the DNA evolves. When some of you who are interested in the history of science, look up the history of discovery of RNA and DNA at the University of Cambridge, because injustice was done. I think there was a lady in the team, probably her name was McLean. I'm so sorry for that. Memory, I forget her name. And she had done most of the work along with Dr. Watson and Dr. Crick. And the poor lady was denied the honors and she did not share the Nobel Prize. Anyway, life at certain times doesn't seem to be very justified. So once we now know, when we have a picture of the structure, we now know what the chemical composition of the building blocks of life are. We also know that because of the agency of nature, environment, this thing will change. And what we were trying to do in the lab, not for the first time, we have done it many times before, we were trying to compete with nature. We were trying to play God. And this act of trying to play God inside the lab is called the gain of function research. So we are trying, in our insolence, in our scientific arrogance of trying to do in matter of years what nature would do in matter of era or millennia. We are trying to outcompete one another and say that, look, this virus X would have evolved like this over the next 100 years. But my team of immunologists and virologists have been able to outcompete nature and do it within 1 year. And it was believed this was probably a project of University of Carolina. And what the Wuhan scientists were doing is they were just doing the dirty work, because this is risky work. This is probably doesn't even have all the approvals and compliances, the ethical clearances it needs. And the Wuhan lab was just doing the dirty work. And this was not only an idea of the Americans, this was funded by the Americans. And some of the funding permissions were signed by people like Tony Fauci, Dr. Anthony Fauci. So this is the first lesson to learn, that please don't try to play God. We've tried to play God once very often. And after this very unstable complex of RNA with the spike proteins were released in nature, it has undergone many mutations. One question that most of you are in the domain of science. So I have been asked this question quite a few times, that look, for the scientists in China to know that they are actually playing around with a pathogenic virus. You're playing around with many viruses at a given point of time. But for the scientists to know that they were actually playing around with a pathogenic virus, they must have conducted human experiments. The short answer to that is no, they did not need to conduct human experiments, because they were actually experimenting on the effects that the virus has on human lung cells, on the pulmonary alveoli. And the structure of the pulmonary alveoli these structures were cultured in the lab. You don't need the whole human being to do the dastardly experiments, like Dr. Mengele, the devious scientist associated with Adolf Hitler used to do. So you don't need to do that anymore. So the human alveolar cells, the human pulmonary cells can now actually be cultured in the lab. And this was called mice cloning. And mice cloning made it possible for the scientists. So, you remember the story when Archimedes dipped into the bathtub of water and the theory of flotation came to his mind. He jumped up and said, "Eureka, eureka." And these people, I'm sure they were brilliant scientists. So when they restructured, there is something called a base deletion. There is a furin base deletion in the structure from the SARS-CoV virus 1, which was a natural virus. So they played around with many permutation and combination, and they switched to one of the genetic sequences in the spike protein. And then they jumped across and said, "Eureka," because they could now see in the cloned cells that the spike protein was actually penetrating the human alveolar cells. And thus, the great demon of SARS-CoV-2 was created. And ever since, did they spread it out in the community accidentally? Did it happen intentionally? God alone knows. Nobody knows that. You need to re-invoke Sherlock Holmes to tell that story to you and me. But once this demon, this ultra microscopic Frankenstein has been unleashed on humanity, it actually has changed many a times. And why does it change? Because you see, RNA is a very unstable molecule. And RNA has got RNA is not actually a living molecule. It is like a chemical with an expiry date. If you leave an isolated RNA molecule out there in nature, it will stay viable for a certain period of time and then it will die. It has to find a host. And whenever it finds a host, because of the genetic signals and triggers, it will go through an incessant and endless, enthusiastic process of multiplying itself. And the act of multiplication, because whenever a chemical compound, it's like putting 1,000 papers inside an industrial mass photocopying machine. If you put 1,000 papers into a mass photocopying machine, not all the photocopies will come out an exact detailed replica of the other. There will be errors in margin, there will be differences in ink density, there will be maybe the top and bottom or the right and left alignment will look a little bit different. So similarly, when there is such a frenetic multiplication of the RNA structure, it is inevitable that there will be some changes. And there has been probably more than 25, 30,000 variations and mutations that has happened. A mutation happens in the genetic code. And when you have many such mutations, the mutation gives rise to a variant. So it is a mutation that gives rise to a variant. The variant doesn't give rise to a mutation. It doesn't work around that way. And even if, say, there was a mutation a day, but still, ever since 2019, you and I have mainly been concerned with the troublemaking ones. And the troublemaking ones, the original one was called the Wuhan wild strain. Then we had the Kent virus, later on called the Alpha. Then there was another strain in South Africa called the Beta. Then there was the one in India called the Delta. And now this one, Omicron, first isolated in South Africa. Now, just a one line of scientific tribute. The world should be in debt of South Africa, because if you put China's timescale chronology in perspective, China took about 8 to 9 months to announce this virus to the world. India took about 4 months to make up its mind that they were actually handling a new variant called Delta. And within a month of India formally announcing the Delta, it was like wildfire in India, and it was like wildfire all over the world. But South Africa just acted on the clinical hunch, because look, what is different about South Africa is a country which has lived through many viral onslaughts of virus and other infective diseases. The most noted amongst that was the onslaught in England. We were working in London in the cardiothoracic wards. Every ward used to have 10, 20 AIDS patients in them. And we junior doctors were kind of kicked up the ladder and put in front of the queue. Every week, we were compelled to do lung biopsies in at least 2-3 HIV patients. No senior doctor would ever go and do a lung biopsy in an AIDS patient. What did we ever learn from the lung biopsies? We don't know, but we did many of those. Anyway, so South Africa, AIDS is still there. AIDS is still endemic. You see, India did a fantastic job of AIDS control. And it is a scientific statement to say that along with the scientists, if there is one community to which, to whom you need to salute, that why AIDS did not become a ravaging epidemic and later on an endemic in India, is actually those unfortunate people, the community, the professional community of prostitutes in India. The way the prostitutes in India and the red light districts conducted themselves, organized themselves, took to all the preventive health guidelines that the government gave them. If not for them, India would have been, run up and down and put through the paper shredder because of the HIV pandemic. That's a different story. I'll tell that story to you in a different day. So South Africa just acted on the hunch that they were seeing a lot of youngish people in the clinics who had very mild symptoms. These symptoms are not the traditional symptoms of a corona SARS-CoV-2. Very few people even had fever. Most people just had headache and a sore throat. And they thought that, look, since we've seen that many of variants around us, even though these symptoms looked quite harmless, looked quite mild, let's go on doing some genomic sampling of these viruses and see whether it has a resemblance to SARS-CoV-2. They were really not thinking initially in terms of SARS-CoV-2 having mutated. They were really thinking in terms of a prevailing influenza-type virus, more innocuous virus, which was trying to look like SARS-CoV-2. And at the end of their genetic analysis, which was done within a week, can you imagine this? Fantastic work within a period of week. They found out a lot of mutations in the about 52 mutations in the entire genetic code. Of 37 mutations were in the spike protein. And the scientists came to a conclusion. You see, there is still debate in the virological community that whether this is a common cold virus trying to act as a corona COVID-2, or whether this is a COVID-2, which in some patient, because they have tried to identify an index case, which was a gentleman who was receiving who was terribly immunocompromised, a post-HIV patient most probably, who had a common cold and who contracted SARS-CoV-2 as well. And because in the same patient, in the same subject, you had a common cold virus and the SARS-CoV-2 virus, that probably they embraced one another. It's like something that happens in the zoo, that you try to mate a donkey with a tiger and come up a donkey with a horse and come up with a hybrid. It's like one of these hybrid genetic exchanges. So what is the property of this Omicron? First of all, we need to remind ourselves that if this virus has now got on addicted to this job of mutations and taking on these many disguises, we will very shortly run out of Greek alphabets. Because the other night, it was last night, I was studying the Greek alphabets, and I found out that only 7 alphabets are left after O. So if there are 7 more mutants, after that, the World Health Organization will have to choose the Hindi, the Persian, the Mandarin, or some other language, because they only have 7 alphabets left in the Greek lineage. That's a different story on a lighter note. So this business, what have we seen so far? Let's summarize it. There's a lot of confusion going around. It will be confusing for some period of time. There is no one, least of all myself, who can give you absolute, crystalline clarity in this matter. But what we have seen is the scientists somehow have come to a consensus that this is the parent superstructure is that of SARS-CoV-2 with little bits and pieces of common cold added to it and lots of genetic variation. And what that has resulted in, number one, is higher transmissibility. So it's spreading from 1 to 2, 2 to 3, 3 to 4 very, very fast. How fast? As scientists, you and I should be able to put a number to it. So when we had the original Wuhan wild strain, all of you by this time must be familiar with this index called an R number. The R number signifies the transmissibility of a virus. Now, there is something, once again, funny with the way R numbers are calculated, because R number calculation depends on 3 or 4 factors. It depends upon the incubation, it depends upon the transmissibility, it depends upon the host factors. So originally, some people somewhere must have done a statistical study with all these factors into consideration, and then attributed an R number to a virus causing a certain disease, like influenza causing fever, like measles causing fever and skin rashes. But later on, you see, like on a daily basis, when people say the R number has changed, this has changed, make no mistake, people are not really recalculating the R number on a daily basis. What they are doing is they are doing a shortcut R number calculation. What they are saying is, say, for example, in India, if 15 days ago, the R number was 0.93 for so many infections, then so many weeks later, for that many tests and test positivity, the R number, if on a proportional basis, you are allocating the R number. Say from 0.89, it has now increased to 0.94. So I used to wonder, being a bit dull, that how come people are calculating ascertaining the R number, because R number is an interplay of 3 or 4 factors. It's not very easy to calculate. And then I realized that people are not calculating it. They're just back calculating it. Anyway, so if you consider that the Wuhan original virus had an R number of around 1.5 to 2. So for every person, it could easily affect 2 more people. When we come to Delta, when we came to the Kent virus, then the R number increased. It increased from about to 2.5 or less than 3. When we looked at the Delta, which came out of India, the R number increased from about 3.5 to 4. So it was even more transmissible. But what was really malicious about Delta is it caused tremendously early disease. It caused this hypersensitivity syndrome in our immune system. And whilst the original strain was causing the cytokine storm and the hypersensitivity crisis, after about 7 days, 6 days, at the end of 1 week, this fellow was producing the hypersensitivity storm at the end of 3 days, 2 to 3 days. So everything, all the bad effects were accelerated. On that scale, if you look up some of the studies that have come out in the last couple of days, the R number of Omicron is probably in excess of 3.5. South Africa says 3.5. UK, which is in a state of panic, says it's 3.5 to 5. So it is greatly transmissible, point number 1. Point number 2, because of this disguise in terms of many of the mutations in his genetic code, it seems to be overstepping the immunity both from previous infection and from vaccines quite easily. So as a rule of the thumb, if you consider, every vaccine is a little bit different. I'm just telling you what is conventional wisdom right now. So if you thought, if you had, say, a vaccine A, vaccines which were used. Take, for example, Covishield. Most of the world data is based on Pfizer. I'm just taking Covishield as an example. So if you had a Covishield vaccine, then your protection from being infected from Delta, you see, Covishield was not made with Delta in mind. Covishield was made with the Kent virus and the Wuhan original strain in mind. And because there was such a lot of investment, financial and scientific, into making of vaccines, you could not expect the scientists to go on making a vaccine every 3 months. It's not possible. Probably some more will come out. But when you say it's not possible, it is actually possible, because the influenza vaccine gets modified 3 times a year, and that vaccine is available for public consumption twice a year. Anyway, so we were talking about the avoidance of vaccines. So what is happening is, supposing I have got a Covishield vaccine, my protection, supposing if the alpha, the UK strain, was still around, it would give me almost 90% protection against alpha. But alpha in the meantime has been superseded by delta. So the protection from delta now drops down to 70%. Which means it is expected that 30% of people, even after having received Covishield, would get the infection. And what is happening? What is happening with say, Covishield and Omicron? With Covishield and Omicron, the protection from infection has dropped down to 30%, at best 40%. So it is avoiding the vaccine-related and the disease-related immunity very easily. So these two are the bad news. Now, what is the good news? The good news is it still continues to be pretty mild disease. So if you look at the clinical community, if you look at there is a division in the world that exists as of this evening. There is a division between the virologists and the immunologists who are tearing their hair out because they're very upset about the fact that you have this fellow who's spreading at will. And at the same time, the clinical infectious disease specialists are telling them, look, why are you losing your sleep over this? Because this happens to be something which is just producing common cold-like symptoms. People don't even get high fever from this. Now, I'll tell you why people are worried about it. So we discussed about avoidance of infection, easy transmissibility. What is the current idea about hospitalization? So if you took the delta as an index situation, then for delta as an index situation, Omicron's hospitalization rates is about 1/10. So for every 10, why did people need hospitalization in the first place? You only needed hospitalization. There were other reasons, but the primary reason was if your oxygen, you couldn't get oxygen support at home, you could take medicines at home, but the principal reason for hospitalization was support with oxygen treatment, plain and simple. So people going into hospitals were categorized into either they were in wards or high dependency areas or critical care areas or on the ventilators. You had 4 categories of people inside a ward. So for every say 10,000 cases, if you look at the number of people who were in these 4 categories of hospitalization, general wards, high dependency, critical care, and ventilators, it's in the ratio of 1:10. It is 1/10 of what happened during Delta. So there is right now in the world, this Omicron business is really. If you look at the numbers are being popped out with great speed in 2 locations, South Africa and UK. But the philosophy, the attitude, the approach to the problem is very different in South Africa than it is in UK. In UK, the Prime Minister, Boris Johnson, you must have seen him. He's a great chap, but I think he's always in great need of a comb. The one who has never combed his hair even once in his life. Boris Johnson completely went ballistics the other day. He called out the army. They are going hammer and tongs about the 3rd vaccination, etc., etc. Why? Why is UK behaving in such a ballistic fashion? UK is behaving in such a ballistic fashion because, look, number one, no country, UK included, can ever afford to go into a lockdown type situation again. And UK, like religion is a big factor in India, UK's entire politics hinges upon one factor, that is a National Health Service. And over the years, even UK has already had 3 waves. So through their first, second, third wave of COVID, they were hugely criticized for not having expanded the NHS capacity over these many years. So UK is actually very afraid that, look, the hospitalization may be 1/10, but what about the number of cases? If the number of cases are 50 times more, and in the hospitalization is 1/10, then I have 5 times more hospitalization. And look, I don't have that hospital capacity, because in the meantime, for the last 2 years, all the patients in the waiting list, from a heart to a knee to brain to abdominal surgery, gynecological, whatever, all the people, UK just has a single door healthcare system. So UK is extremely anxious that whether it is a itch, whether it is a sore throat, whether it is high fever, they are petrified of the fact that this business may overwhelm their healthcare system. South Africa has a mixed healthcare system of a state and private, and they have, South Africa and England have equivalent population. South Africa has 61 million, they have 63 million. So somehow, I honestly, for all it matters, having been quite familiar with the UK's health system, spent 11 years of my life there, I really find UK's reaction a little bit excessive. So how should we respond to the situation? As somebody said, there was a Dr. Chetty from South Africa speaking last night. I listened to every word he said, seemed to be a great man of wisdom. So some of the important things he said was that, look, we all accept the fact that by and large, this is a mild disease. So it is perhaps not justified. We should continue testing. Nobody is saying that, look, approach it from a very callous attitude, stop testing. No, let us continue to test. Let us continue to pick up the conditions. But let us not just flash the ever-increasing RT-PCR numbers as the be-all and end-all index of the pandemic activity. So we need to retrain our mind a little bit and now say at this stage that along with the RT-PCR numbers, we also need to look at the intermediate endpoint of hospitalization. How many people are actually getting to need hospitalized? So that would tell you and me that what is the pressure on healthcare facility. And it would also tell you and me that is the virus continuing to behave in a clinically mild way? And obviously we have death, but you see, death is a surrogate marker because look, 80% of the initial tests in South Africa, the main center where the first 1 lakh cases were picked up was in the Pretoria district. South Africa is a little bit like India, like Bombay became Mumbai. South Africa has changed all the names. So Pretoria is not called Pretoria anymore. Pretoria is called Shane. So it's called the Shane district. So the Shane district, there is a hospital named after the great ANC leader, Steve Biko. So Steve Biko Hospital in the Shane district really had all the world's repository of data from over there. So all in all, let us now start thinking in the last few minutes about ourselves, about the truth nearer home. I think, my common sense tells me that, look, whatever comes to England comes to America, comes to India. Because England is just like a long lost brother. It may be an ex-colonial master who separated from us by 9,000 kilometers, but there is that much of connection, even in the post-pandemic periods. I think there are still 15 flights a day. In normal situation, you have some 30, 35 flights a day between United Kingdom and India. So with that amount of intermingling happening between the population, I just follow this principle. Whatever comes to England comes to India. You see, beta virus came to South Africa. Beta virus did not come to India because you do not have that amount of fistulous connection between these two populations. But UK is like the 31st state of India at this point of time. Profuse communications. And with due respects to all our compatriots, health workers, scientists, everybody, our vigilance at the port of entry or the airports remain far from being satisfactory. You saw what happened 3 days ago. The young boy who came from Abu Dhabi, there was excitement going on that the boy was Omicron positive. The boy was at least RT-PCR positive, detected in Hyderabad. And the reaction of the Hyderabad healthcare, airport healthcare, whoever they were, was put that fellow on a flight to Kolkata. Not my problem, you know. Your RT-PCR positive, made him sit in the flight with 200 other people and shipped him over to Kolkata. So if that is the degree of lapses that our vigilance is prone to, you see, sooner or later, a respiratory pandemic will come. But in India, the important thing is we cannot drop our guards simply because what are we looking at? A population of 64 million in South Africa and 66 million in the UK. We are, of course, all of us know we are 1.3 billion. We are 134 million. So the population effect in India runs the risk of being tremendously multiplied. So healthcare capacity in India is always at a premium. And not just healthcare capacity, but healthcare expertise. People get very upset if you quote the figure that even at the height of the disastrous second wave, you know, when we had about a 10% hospital mortality, and some states were running 5% overall case fatality ratios, India had 100,000 ventilators. At no point of time could we use even half of them, simply because you don't have that many doctors who are capable or who are trained to use ventilators. So we have a capacity problem. We have an expertise problem. And our healthcare capacity, it doesn't take much. You know, you can sneeze 20 times and India's healthcare capacity can be overwhelmed. So we have to be in our public behavior precautionary phase. And that would mean avoiding large crowds. If you want to congregate, do congregate outdoors. If you have to be in a room, make sure the room is ventilated. And for God's sake, let us not give up the practice of, if you pick up in literature, there is a couple of papers who have now come out. This is, I think, you know, this is Europeans trying to proselytize the world. Are masks of any use, etc., etc.? Please don't get into that scientific quagmire at this point of time. Accept once and for all that masks will be of great use. Nothing is infallible, you know. A mask, the pore of a mask is 3 times larger than the size of a virus. But that's a different story. The mask doesn't stop the virus. The mask stops the droplets. But the mask does not stop an aerosol. So do not be in an aerosol generating situation. We have to be careful about our public transport, about our public behavior, because India will, given half a chance, will produce fantastic numbers. But I still don't figure it out. How will India diagnose the Omicron? Because the government of India has been very miserly with the genomic testing facilities. The whole of Eastern India, with about 35, 40 crore people, has one center. So anybody who's a suspect, by the time the genomic test comes, they are beyond their quarantine day. So it's a little bit self-defeating. There is a shortcut RT-PCR method called the S-gene deletion method, but I think 90% of the RT-PCR facilities do not have. I think it's called the Thermo Fisher kit. They do not have that Thermo Fisher kit. So in conclusion, friends, I think, you know, if you are real optimist, if you are one of those great believers in that it is time that God, who's been unkind to us for about a good part of 22 months, that God is showing us his kindness, you would tend to believe in this teleological notion that this is a God-sent free vaccination. And because this mutant, after it washes through the population, would perhaps give us more robust immunity than what previous immunizations and vaccinations did, because it is spreading fast, causing mild disease. And inevitably, it will give us a different kind of immunity, both antibody immunity and T-cell immunity. So yes, you can look at it in that way. But in trying to look at it in that way for the long term, let us not upset the sociological and healthcare balance in the short term. That is my take on the issue. And I really feel, I don't think, even if we have a kind of amplification of numbers, as is being feared, maybe in February or sometime, I do not think that the mortality or the healthcare damage quotient will be significant. 35,000 people die in India every day anyway. 7,000 people die from road traffic accidents every day. 6,000 people die from heart attacks and strokes every day. About 2,000 people dies of tuberculosis every day. So let us not think that death is something which doesn't happen or unknown. It is undeniable in life. It happens. So I am not personally very scared of Omicron. The same way we were scared as doctors. We were terribly petrified of Delta. It is not even 1% of Delta as far as its lethality is concerned. But in India, we cannot upset the sociological, the economic balance. And I'm really very, very concerned about education, the children in school, the young guys who are in schools and colleges. Because I think we threw out the baby with the bathwater when we shut our schools and colleges for 22 months. No country in the world ever did it. And thereby, protected, probably kept some more people alive, but at the cost of their careers. So resumption of education, which is just about getting back to its some kind of semi-normality, I'm very afraid that there will perhaps be another knee-jerk reaction, which again throws the resumption of education in back gear. So it is from that point of view that we need social restraint. We need, the great, by this time, the great mantra of COVID, appropriate behaviors. Some of the new medicines which are coming, especially Pfizer's Paxlovid, Merck's Molnupiravir it's a bit of a damn squib. Its last report, the effectivity is down to 30%, but Paxlovid seems to be a little bit more promising. But after all, if it is a very mild disease, why will you take that many tablets and very expensive treatment for? We still need to vaccinate because one thing we did not discuss before is that vaccines are still giving us, we believe, the scientists believe, that the vaccines are still giving us robust protection from serious disease. So one of the reasons may be that why Omicron does not produce such fearful clinical symptoms is simply because maybe one of the factors could be the effect of vaccines or previous exposure to the disease itself. So these are some of the thoughts in front of us. Yes, do I believe that that the virus mutating, increasing its transmissibility and decreasing its lethality, does this signify the end of the pandemic? I think it does, but we have to remember that the end will not come as one full stop, but it will come up like in the theater, in the drama scripts. You have ... So it's going to linger on for some time. It is going to linger on for some time. This is nature's. If you believe in God and nature, this is God and nature are probably together announcing to you and me. It is their mechanism of making this pandemic endemic in society. But in the process where an epidemic changes to an endemic, we must not cause more disturbance, more derailment, and more damage than what has already happened. So let's hold on to our common sense. Let's hold on to our compassion. Let's hold on to the same fundamental principles that we have held on for the last 20 months. And I, for one, believe, I can see Shamiji sitting in front of Swami Vivekananda's portrait with a wonderful garland behind him. So that young man, in his last 5 years, 3 years in Kolkata, probably rushed out to attend to about 6 or 7 epidemics, starting from, I think, 3 epidemics of cholera, 2 epidemics of plague. So people like him in the early 20th century lived through the times when the city, Kolkata at least, used to have 3 epidemics a year. So let us not get frustrated. Our resilience and our battle has to continue, and all of us put together will come out of this. It'll take time. The timetable has not been announced, not to me, not to you. So we can look back at it once this bad news is over, but do persevere. God bless. And should you have any questions, I'm happy to take it. Thank you.
Dr. Sharkar, Dr. Debalina Sengupta has sent one chat message that please see that vaccination. What is the message?
I can go ahead and ask the question
Yes,
that's
surely.
Thank you very much, Dr. Sarkar, for this exceptional.
I'm not very good in these small things. So I think your question has been that getting the Omicron or whatever after vaccination, right?
It could be Omicron, but it may have been the Delta variant.
Yeah,
like if
you see,
have
because
got it.
because what I fleetingly mentioned too was the fact that in the evolution of the vaccines, you see, the prototype has changed. Because if we really wanted cast iron protection from infection, then you needed to have that one unwavering virus. So, for example, your prototype was the Wuhan wild strain. Then you needed the Wuhan wild strain to go around with no changes, and then you would see no infection. And the virus would just vaporize. So it doesn't, because it is changing all the time, and we are not able to keep up with the changing. And so the first guard drops. The first guard, which is a prevention from infection, gets lower and lower. But still we believe that because protection from serious disease is probably given by the T lymphocytes, the cellular immunity. So the cellular immunity, I think, is still holding on. And I tell you, between you and me, another reason is that half the world has been vaccinated with the mRNA vaccine, Pfizer and Moderna. You see, mRNA virologically represents a great leap of science because it's very specific, very well targeted, very modern, etc. But mRNA has a great disadvantage because you can, if you try to picturize, mRNA vaccine is like a bullet, right? So you aim at somebody, it will go and hit that person right in the head. It's like a assassin's bullet, very well targeted. Covishield is like a grenade, it's a little bit primitive. So it's like a grenade. You've thrown a grenade at me. So it may not take me out, but it will cause a fair amount of damage in the vicinity, right? The area of damage is more. And the Covaxin, which is a live attenuated, that is like a bomb. So it will be there for a short period of time, but it will cause more havoc because it has everything in it. So as an Indian, you and I can be a little bit sad for the fact that we did not vaccinate more people with Covaxin. Only 10% of India, 9% of India got Covaxin. I don't know what happened to the manufacturing plants. 96% got Covishield. So in hindsight, the old Indian version of the old-fashioned live vaccine, they maybe their memory will be a bit short. Their antibody memory may be a bit short, but it has everything in it. It has the whole concoction. So, and you saw that in Israel. If you followed what happened in Israel, you saw that because Israel in no time, they hardly have a population of 25-30 million. So in no time, they vaccinated the whole population with Pfizer twice. And then when Delta came, far before Omicron, they were struggling because Pfizer did not cope very well with Delta. Neither did Johnson & Johnson because their old prototypes were different. So people say that, if you believe in conspiracy theory, people say Omicron is a conspiracy by the big pharma. They will come up with vaccine 2.0 and sell billions of vaccine all over the world. Share prices have gone up, blah, blah, blah. So probably Dan Brown's new novel will be based on the vaccine conspiracy theory. Who knows?
Yeah.
But that's
Dr.
it.
Sarkar, may I ask a question to you? I'm Sarup.
Yes. Yes,
So,
Sarup.
yeah, it's a really great pleasure to listen to you. I know you treated my father long ago, and I'm eternally grateful for that. He had to go through a
No,
bypass
Sarup,
surgery, and
never be grateful to a doctor. You see, a doctor's curse of life is that he's got to work for a living, So
no, but you are effectively a magician in that. So basically, I knew you were a great doctor, but I didn't know you were a great orator. Your talk has been wonderful. So the question for you is that I did some work on developing a new kind of mask, and there are some publications on that which I made. You commented on the fact that when you are indoor, your mask doesn't protect against aerosol. It might protect against droplet. That's absolutely correct.
Yeah.
The point is that then what do we do when we are indoor? The festive season is coming here.
Open the windows.
Open the windows and maybe maintain distance.
You have to have cross ventilation, you see.
I see. Yeah,
why does Africa have less COVID? Because their temperature is higher. They don't have winter, and half of the places they don't have air conditioning. They never shut windows. All their windows are open.
I see. In India too, right? So that's an advantage probably for India.
Sometime back, the vice chancellor of Vishwabharati was telling me, I don't know whether his data is correct or not. He was saying that Vishwabharati had very few COVID. I asked him why. He said, look, our classes, half the classes are held in the open. So
Very good.
I asked him, sir, is it really so that your classes are held in the open or you don't hold classes at all? I see. So he did. He said, no, you are...
Another philosophical question is that with all what we are doing, when do you think the end would be? You mentioned the end won't be a full stop. It would be a gradual.
Don't look. You see, don't look for an end. It's a little bit like a chronic marriage. The story goes on. So from an epidemic, it's like husband and wife who quarrel. Quarreling never goes away. The frequency decreases, the heat dissipates. This disease is bound to remain as an endemic. Bound.
I see. Now that's really
like, you see, as we talk, tuberculosis is still there. You think about 1892, Robert Koch was banging his head on the wall. He was trying to, when he isolated Mycobacterium tuberculosis, people had all funny theories of tuberculosis. When Treponema was isolated for syphilis. So it's all the diseases are there. And, if we had 100 diseases so far, this will be 101. So the next generation of doctors, when they treat some funny lung picture with, shadows in the lung 7 days after pneumonia, this will be a differential diagnosis coming up now. It will stay.
That's a great point. Yeah.
It will stay in society, but mind you, some viruses have disappeared. Having said that, say H1N1 did exactly the same thing. H1N1 mutated. H1N1 did not spread across the world. It remained localized in certain geographies. And outside of the certain geographies, it started going into these fast mutation cycles till ultimately H1N1 swine flu disappeared. But there are some, like, 1919 pandemic, which Gandhiji got, that was swine flu. There was some there were some samples that people isolated later on. That was H1N1. So which means what? Which means H1N1 has been around for 90 years.
Right. Yeah.
So there is no reason for you and me to get impatient in the third year. So if we believe that H1N1 was swine flu, in 1919 and you are still thinking of H1N1 in 2002, it means that fellow has been around for 100 years in different form.
Yeah, the problem is that I do not see the end to be near at this
No, there will
point.
be,
Yeah.
there will be decrease in incidence. It will stay in society. It will have different expressions in different parts of the world. And it is almost certainly to be an endemic disease. Almost certainly.
Thank you. Thank you very much.
Thank you for Professor Sharkar.
Maharaj,
Hello.
how are you keeping and how are you, Maharaj, how are you doing with your classes and your students? How are they getting on?
Actually, 50% is that physical classes,
Yes, you
mostly
were
in the lab sessions and the practical sessions. The
Right.
text, the lecture classes are online.
Right. So probably it will be a mix of both for some
Yes,
time.
yes, yes. I think around another 4 or 5 months it will continue like that. And I heard that mostly software industries in Kolkata, so they will continue at least for 1 year, this home, work from home system.
Yeah, that is why Kolkata rental prices are falling, you see. So
Yes.
everything is economic effect. Anyway, pray for us, pray for the healthcare workers.
Yes.
And
Yes.
let us hope I think if we've seen through February, we will be okay, not to worry.
Let us see, sir. Let us hope for the best.
All the
Thank you, sir. Thank you.
Thank you. And thank you for thinking of us. God bless you.
Yes.
Pranam.
Yes, sir.
Thank you.
Thank you, Dr. Sarkar.
So, what should be our plan? Who will speak first, Devalina or Swarup?
I think
Or-
Devalina should go first, but I can cut it down, my talk, Maharajji. I can
But
make it
I
brief.
don't like that you cut it, because it is a permanent thing. It is being recorded and it will go for you can say at least few years in a YouTube live video.
Sure, no problem. So Devalina should go first, and then
Yes,
because
yes.
that was the
Surely.
agenda,
Surely.
and then I can follow up. But I can maybe take a quick break and come back.
Okay, sure.
Okay.
So Devalina, please start.
Okay, thank you so
Introduce
much.
yourself and start. Already all your introduction and other things that I have printed in the book, and the book has been circulated to everyone. But still, if you speak something about yourself, that will be our pleasure. Okay.
Absolutely. Thank you so much. So it is a pleasure to be speaking after Dr. Sarkar. It was an amazing lecture, listening to all the current situation in COVID. I'll move a little bit over to some of the other pressing needs of our society currently. And my focus is going to be on sustainability of energy and water systems. I'm going to have a very different take from the engineering domain, especially from chemical engineering domain, and discuss some of the analytical tools for resource conservation, decarbonization, and analyzing the energy mix of the future. So a very brief background. I had a discussion a little bit earlier on my past positions. Currently, I am the Associate Director of the Teas Gas and Fuels Research Center at Texas A&M University. I also hold joint appointment as a Water Energy Food Nexus Coordinator for Texas A&M Energy Institute. And I'm also a graduate faculty at the R.T. McFerrin Department of Chemical Engineering at the Texas A&M University. My past positions have included lecturer at the department, a postdoctoral appointment at the department. And one of my career highlights was having an ORISE postdoctoral fellow position at the U.S. Environmental Protection Agency. I got my doctorate from Louisiana State and a bachelor's from Jadavpur University back in 2003. So at the 100-year celebration, I'm kind of more recent and more young graduate of the university, the chemical engineering department at JU. I also have pretty good connections with the American Institute of Chemical Engineers. I'm currently the chair of the Fuels and Petrochemicals Division. I've also held past chair position at the Environmental Division at AICG. I've held several programming roles. I've chaired multiple sessions with the AICG, and I continue to be an active volunteer with the American Institute of Chemical Engineers. Moving over to the topic of today's discussion, I will be discussing sustainability primarily in the context of process systems engineering domain of chemical engineering. I'll start with what is sustainability, then I'll go over a few cases and thoughts on sustainability for water systems, sustainability for energy systems, especially in the transition energy phase of natural gas, and future energy mix of biomass. And then finally, I will conclude with some topics on sustainability and resilience, resilience to disasters. And here I'm mainly going to focus on the educational aspects of sustainability. Finally, a couple of concluding remarks. So sustainability is a complex topic, and it has several interpretations, actors, and stakeholders. It may mean multiple things to multiple people, and coming from a third world country, as India, there has been a lot of these things we do naturally because we are so resource constrained. But putting this out is very important, that sustainability is a balance between people, profit, and planet, the very famous three-pronged Venn diagram of sustainability. We also have multiple ways in which we can try to attain this. Some of the popular ones currently are rainwater harvesting, solar energy, electric or hybrid cars, wind energy, renewable fuels, and the likes. However, the focus of today's discussion is going to be on how can chemical engineering knowledge with an emphasis on process systems engineering be utilized to achieve goals towards sustainability. So process systems engineering is that domain of chemical engineering where you are dealing with design, simulation, optimization, and modeling systems, especially in the context of chemicals and chemical related products. And this also includes our raw material conversion from traditional conventional oil and gas to fuels and other likes of that. So primarily the tools and techniques that we use in process systems domain is modeling, simulation, design and optimization, and of course, control of processes. So that in a sense covers the domain of process systems engineering. Now, before I go into the technical aspects, I wanted to give an overview of the global sustainability initiatives. So this is a famous 1987 United Nations Brundtland Commission definition, which defines sustainability as meeting the needs of present without compromising the ability of future generations to meet their own needs. Now, that being said, that 1987 definition has evolved over the years. Back in 2000, the United Nations went for the 30-year plan vision for 30 years. Very recently in 2015, those plans which were initially called Millennium Development Goals, were transformed into Global Goals for Sustainable Development, or also known as SDGs. And what you see here are the 17 Sustainable Development Goals that the United Nations currently are working on. And if you see here, clean water and sanitation, affordable and clean energy, industry, innovation, infrastructure, sustainable cities and communities, life below water, life on land. Some of these are very, very related, very closely related to chemical engineering and what chemical engineers do for a living. So it is very important for us to think about sustainability and incorporation of sustainability into our engineering, especially chemical engineering domain. As I said, starting in 2000, the MDGs and the SDGs currently have been tracking the progress of nations towards sustainable development. About 140 developing countries in the world today are seeking ways to meet their development needs with the constraints of increased threat of climate change. These 17 SDGs have about 169 targets, and these are included in the 2030 Agenda for Sustainable Development as Plan of Action for People, Planet, and Prosperity. This is aimed at targeting extreme poverty, which is recognized as the greatest global challenge and indispensable requirement for sustainable development. Now, as engineers, we do have the unique opportunity to provide sound science, quantification, analytical methods, engineering solutions, and to inform and develop the policies towards meeting these targets. So the future of engineering does look like we have to work together with social, environmental, and technological experts, and not only after our graduation or after in our work life, but starting it from very bottom grassroots levels. Even before we go into engineering domains, we can start working in these directions so that we can provide linking and bridging expertise towards sustainable development. So now I'll go into some of the case studies that where we can implement. I'm going to explain some theories and also explain some ways in which we can use these theoretical approaches to change things for the future, or how we can approach some of the pressing challenges of our current industrial needs. So here I'm going to talk about water systems. This gives a global water management or water cycle at a type 1 scale that we call global scale. Here we see the water cycle where you have groundwater and surface waters, precipitation, and evaporation from lakes and oceans that keep the water cycle going on. What we do, this work, the concept that we developed here has been published in Incorporating Systems Thinking and Engineering Design Curriculum. So how can we think about the systems approach and incorporate it into engineering design curriculum? And so in this water system supports our primarily the systems that are managed typically by local and individual entities, local authorities and individual entities. We have rural and domestic livestock. We have public water supply. We have farmland and irrigation. And a very major part of water consumption comes in the power generation and industrial use sector. So these are which the systems which intercept this natural water cycle to get into our use phase of the water for human and livestock consumption. The typical interception that happens of this water, I've given an example of an industrial process system component. And here I'm talking about business systems and water management networks. Physical and chemical processes that prepare the water for use from and discharge into the natural water system. So if you look at the types of systems that I'm talking about, and this has been explained in our book very explicitly, but the physical and chemical processes that prepare the water for the use and after it is discharged, how it is discharged into the natural water systems, that is an interception of that water cycle that we initially talked about in the type 1 scale or type 1 system. So how does this work? How do we intercept the water and what happens in here? Here is a superstructure representation of the same problem that I just pictorially depicted. But this is the way we approach an optimization model for the water source interceptor sink modeling method. Here, the overarching principle that we use is industrial ecology. Process systems analysis is used for energy, mass, and property integration with targets of minimum discharge, cost, and environmental compliance through mathematical modeling techniques and tools. This provides us potential for economic savings, and we also have developed anchor tenant approach for industrial ecology. So I'm not going to go into the details of all the methods and approaches, but we have given some like pointers towards openly available literature sources for these issues. And if you don't have access to any of these papers that I've mentioned in the work, I'll be happy to provide you with a copy of those. So mass integration is a technique that is used in this case for developing total quantity of water inlet and outlet from different industries. We can use this. Property integration deals more with the quantity or quality of the water, say at the inlet, and primarily outlet quality. It depends on the type of processes in the process. For example, battery waste is different from refinery waste or petrochemicals waste. So it is necessary for the sustainability of local regional water quality for health, safety, and economic development. And energy integration is energy requirement for the processes supporting water treatment and utilities that require operating costs. So minimization of purchased utilities can be achieved by integrating with excess process energy that is currently wasted in our systems. So this is an example of how we can incorporate such water source interceptor sink models in industrial ecology sector. I have given a very close to home example where this sort of model can be implemented. I have great hopes that someday we will be able to do this, for example, in the Haldia industrial ecological zone. And here, this is an existing map of Haldia industrial zone, which can be also, they have existing industries and they have industrial zones, and they have potential future industries that can be developed there. Here you see that they have the big names in the Haldia petrochemicals region, the petrochemical industry, the Haldia refinery, the Exide industries, and the likes of that. So how would you approach the industrial ecology approach? How would you implement that in a industrial zone like this? So here, let's say you have plant 1, plant 2, plant 3, and plant I, or where a lot of these industries have wastes that are generated from these plants. They also have resources that are required for these plants. So instead of having a individual resource uses and doing that interception that we saw a couple of slides back, where you have a business unit which is taking water from the source and having individualized plants which deal with the water pre-treatment as well as the post-treatment. You can have centralized facility of fresh resource inlet where the water is prepared to a certain extent and transported to these plants. And then there is centralized mixing and interception system So after the water is used in these plants, there is a centralized system to accept the wastes and then treat those wastes. So here I've just put in some names, no connection at all. But if we were to do something like this, how could we do this? So energy, refinery, petrochemicals, and battery manufacturing, let's say, they have all different water requirements, but also all different wastewater processes. So that could be a way where some of these can be connected. The other parts that come into place is who will provide the energy. So a lot of the petrochemical processes as well as refinery processes have excess heat in the form of waste heat that is currently not utilized efficiently. So those energy can be helping in providing energy and power to these centralized water treatment sources. And then you can think of completely new industries that can be making use of this existing infrastructure that is built, and you can provide incentives for those new industries to come in these regions. Now, where does potential sustainability map for water management come in this picture? So here we are looking at the 3 pillars of sustainability, again, economy, society, and environment. This is a overall diagram of how your extraction of water for industrial development is being used. You're creating the economic value to the society. You also have wastewater recovery and recycling that can potentially have savings. Wastewater can potentially impact humans and livestock, so that is an avoidance that you have to make. And wastewater potentially impacts waterways and agricultural land, so you are making benefit in that direction if you're able to recycle and reuse some of this wastewater. So in a sense, we are targeting the economy and economic capital. So industrial investment is required for pre-treatment. Investment for discharge control is required. And we have requirements for energy for water pre-treatment and post-treatment. And we also have to meet government-imposed regulations for discharge limits. So these are targeted. If you are targeting these areas, you are going towards corporate social responsibility with minimal impact on environment, and take advantage of existing industries in the region with low-grade energy recovery, while maximizing profit and minimizing costs of energy use, cleanup, and litigations that you have to face. An example case has been given in the book chapter. Here we are looking at craft pulping process for paper for paper industry. Here, the left side of the diagram shows your input and output and the entire process of the paper manufacturing, which if you combine into input-output model on the right, it shows the total water content and water inlets and water outlets. There are maximum water comes from the wood chips and the washers. You also have some filter water and screening water. And then on the right, you have the waste that is generated from this system. So typically you would be using all of the water that's coming in, and you discharge all of the water that's going out. However, there are multiple ways in which you can look at a recovery network. Here we have put in a black box diagram of a recovery network. Also, what we have done here is we have looked at the different flow rates of the water and the compositions. So here we are not only looking at the mass balance, but also the property balance of the water in terms of what are the components in this water, and to what extent do we need to recover the water, to what extent can we recover the water. So if you see on the right, we have a recovery network model, and this recovery network could entail multiple different technologies. However, once we have been able to recover that water, we recycle it back so that we minimize the freshwater target from the system. So the moisture in the wood chips cannot be changed, but the washer waters we can change. So initially we were using 13,995 tons of water per year. Now it has been reduced to about 9,832 in total of the water that is fresh water that is required. So we are able to put through the recovery network and through this modeling exercise, we are able to put back a significant amount of water in the fresh feed. The next diagram here shows the different steps that we can take in the recycling. So current use is shown by the 52,197 value. We are able to do a direct recycle and reduce the water water amount that is required in the fresh. That is the direct recycle stream. If we have a single interception, we can go take that down to 19,615 freshwater. And then with new technology to enable self-recycling, we can go down to a freshwater target of 9,832. So what I want to convey here is that through rigorous process optimization and targeting and benchmarking of technologies, we are able to do the systematic method of where should we intercept, what is the best method of interception, how much can we recycle, how much can we generate, and bring this into a centralized recovery network framework. With that, I complete the water system. Now I'll move on to sustainability for energy systems. This is a very popular diagram called the Lawrence Livermore National Laboratory Sankey diagram that shows the US energy consumption. These numbers are for 2019, but they have not changed over the past several years. So I'll just take it at about 100 quads of energy is consumed in the United States every year. Out of this energy, we have a mix of energy resources, primarily petroleum, natural gas, and coal, with inclusion of solar, nuclear, hybrid, wind, geothermal, and biomass. So all of this energy goes into electricity generation primarily, and then we have residential, commercial, industrial, and transportation uses. The important part that I want to point out here is that maximum amount of energy that is consumed in the United States ends up as rejected or waste energy. So if you see the numbers, they are tremendously mind-boggling. About 65% of energy is wasted from electricity generation, 35% from residential, same from commercial. About 51% of industrial energy is wasted, and about 79%, a staggering number, is wasted in transportation. So only about 1/3 of that 100 quad of energy ends up in our energy services, and the rest 2/3 end up as rejected energy. So significant opportunities exist in reducing rejected energy, either by increasing process efficiency or utilizing it for new processes. So PSC techniques and methods can provide solutions for these sectors. Now I'll move into the annual energy outlook for the future. So if you look at the different energy resources that I showed in the previous diagram, natural gas is expected to see a huge rise in the United States over the next 30 years. Crude oil and coal are going to be phased out and reduced significantly in their consumption patterns. Same for the sectors of consumption, electric power and industrial use is expected to rise, whereas transportation energy is expected to fall. These are very important and interesting numbers because with rising population, this energy mix and energy change is going to impact the future of energy, how we look at it. So natural gas is, as I said, it's expected to rise as a primary energy source. So that's why we call it sometimes a transition energy. And consumption is expected to rise in the power generation and industrial sectors. So I'll focus on natural gas as the transition energy. In the United States, natural gas is produced primarily in 5 states. Texas and Pennsylvania currently hold the lion's share of that energy production. And mainly this production is currently coming from natural gas, which is coming from shale explorations. If you see the blue section in the graph here, it is tight and shale gas that is expected to rise over the next 30 years. So natural gas is clean burning hydrocarbon compared to coal or crude oil. Since 2006, 2007, US has seen an increase in production in this sector. Texas and Pennsylvania have been a center of this activity. And natural gas provides domestic energy and plays key role in energy security and independence of the United States. Now, several ecological, economic, and societal issues have been reported that hinder sustainable development of this resource in this country. Now, some of those sustainability challenges, I won't go into the details of all of them, but some of them are coming from the upstream where the fracking wells use water currently, and the water use and disposal for hydraulic fracturing is a tremendous challenge that people are facing to develop this resource. Even though they have significant amounts of this resource, they are not able to do that because of the requirements for water use and disposal. Also, the water comes out with naturally occurring radioactive materials that come from this shale plays. So there is not a very concrete way of dealing with those in current infrastructure. The second part is comes when you're processing the natural gas that comes out of the ground. Natural gas, as we know, is a combination of methane, primarily methane, and it also has some heavier hydrocarbons. The typical shale gas wells have a higher amount of higher hydrocarbons, the C2, C3, C4s, than traditional natural gas wells, which means that you need to do something with these higher hydrocarbons. And there is currently not enough infrastructure to utilize these natural gas liquids. So that means that you have to dispose that off through either flaring or venting, and that causes global warming or greenhouse gas emissions to occur at these plant sites due to these flaring and venting. Also, there is lack of pipeline infrastructure. So this is typically in Pennsylvania. Pennsylvania didn't have an elaborate pipeline infrastructure that Texas had due to an industrial zone existing in that in the Texas region, but Pennsylvania is primarily residential and very little commercial activities other than the industrial belts of steel manufacturing and others. But anyway, so Pennsylvania was primarily coal-based economies, and that meant that you do not have the pipeline infrastructure. The terrain is also very different in Pennsylvania, which hinders the development of the pipeline infrastructure. And finally, the consumers who will be consuming this gas that is being produced, there is not enough monetization opportunities at those locations, even if they have this huge resource. So it's typically going into residential and commercial, but monetization into higher value products is not happening. Also, if you're trying to go towards electric power, there were typically coal-based power plants existing. And with new technology, with new resource, you have to develop the technology for gas-based power generation instead of coal-based power generation. And finally, the last trick that we have to solve is US used to be an LNG importer where liquefied natural gas was brought into the country from other regions of the world. Now with this abundance of natural gas, they are aiming to be a net exporter of natural gas through LNG. And that means that you have to repurpose existing infrastructure from being an importer to an exporter to the LNG market. So these are some of the challenges. So one of the ways in which these challenges are being met, especially in to deal with the lack of pipeline infrastructure, is distributed mobile processing of these resources. So I will explain one of these challenges. We have work that is going on in all of these 4 areas, but I'm going to talk about one of our research areas where we are looking at carbon dioxide as a problem and how can we convert that carbon dioxide capture and utilize it in tandem with natural gas, such as methane molecule. This is a work with our collaborators in Texas A&M, Qatar. And this is my role in this is a collaborator role, where we have been designing novel catalysts and processes for carbon dioxide conversion from micro to macro scale. The project aims at, is primarily targeted towards Qatar. Qatar has established itself as the gas processing world capital and has continued to build world-class industrial cities for the exploitation of its oil and gas resources. Simultaneously, Qatar is making significant efforts to lower carbon dioxide emissions. Capture CO2 must always be accompanied with either storage or conversion. Our research project focuses on developing novel catalysts and processes for CO2 conversion in the presence of methane to lower carbon dioxide emissions while diversifying the monetization of Qatar's resources to produce clean fuels and value-added chemicals. So reforming is the technology that we are targeting for this. There are 3 different types of reforming primarily. The most industrial used reforming method is the steam reforming. So steam reforming is used for hydrogen production, primarily hydrogen production in the industry. Apart from this, there's partial oxidation and dry reforming method. We are targeting the dry reforming and improving the dry reforming methodology. So if you see the molecules, the steam reforming produces about 3:1 ratio of hydrogen to carbon monoxide, which is syngas, an important intermediate. Partial oxidation produces 2:1 ratio, and dry reforming produces 1:1 ratio. Now, out of these, dry reforming has the highest energy footprint because it is a very highly endothermic process. Steam methane reforming is also endothermic, whereas partial oxidation is exothermic. Now, if we were given a choice, we would have produced all of this by partial oxidation. However, oxygen generation requires a significant amount of energy. So the energy balance kind of like balances out when you are doing the steam reforming as compared to partial oxidation. However, now focusing on the dry reforming, it has that high energy, hence higher carbon footprint, but it also has an undesired ratio for downstream syngas use. So the syngas, that 1:1 ratio, is not desirable for most of the applications. For example, gas to liquid synthesis through Fischer-Tropsch, or methanol production and the likes. Now, to overcome, now to add to this problem, there is also a significant challenge of carbon generation in this process, where catalyst deactivation causes loss and frequent shutdowns of the reaction system. So to overcome these challenges, we did significant thermodynamic modeling in simulation, and we came up with a sweet spot where we were getting good syngas ratio as well as a very low carbon footprint, by dividing this single reactor reformer into 2 reactor reforming system. We used a cheap catalyst in the first reactor where our goal was to deposit as much carbon as possible and making sure that that carbon was coming from the carbon dioxide part of our reaction. And then getting the temperatures high up enough so that we can put that gas mixture into the reformer with the expensive catalyst to get a syngas out of the system. And that syngas ratio was greater than 2, which is desired for downstream processing. So we have been able to reduce the energy by at least 50% compared to regular steam methane reforming, and with at least 65% of CO2 conversion compared to dry reforming process. Now, this novel capture technology has been patented and it's out for commercialization. So if you're interested to know more about it, we'll be happy to share information with you all. Now I'll very quickly focus a little bit about future energy biomass. I know India is big on biomass conversions and ethanol from various feedstocks, so I'll just go briefly over biomass. Biomass can be used as an energy feedstock in various forms. We have animal waste, forest and crop residues, agricultural crops and residues. We have sewage, we have industrial waste, and we have municipal solid waste, the organic fraction of MSW. So the biomass can be used as an energy feedstock. As I said, it can be classified as virgin biomass grown for the purpose solely for energy. Also, it is the only renewable resource that can provide the carbon and hydrogen atoms needed for chemicals. So significant research has been conducted for its utilization in fuels and chemicals, as well as its use in direct energy. So we have significant publications in this regard, which also includes my book on chemicals from biomass. I'll be happy to share information on that, but it's also mentioned here. The main thing for biomass use as an energy feedstock is that it requires significant amounts of energy to make that biomass amenable for chemicals and fuel generation. So that energy balance kind of sometimes has caused a challenge in this direction. So how do we do the balance for such things? So this gives an overview of that work that I had done on integrating bioprocesses into existing chemical complexes. So if you remember the topic of the industrial water use and reuse, it's similar in concept how you can use an existing industrial infrastructure and integrate some of these bioprocesses, making use of that excess heat, making use of that excess energy that is currently wasted in industrial systems. And how can you integrate that or use that energy to grow these new chemicals and plants that that can be made from this existing infrastructure. So I won't go into the details. I just wanted to mention that this has used multi-scale process systems engineering, optimization, process development, sensitivity analysis, and total cost accounting methodology through process integration methods for the development of this work. Finally, I'll come to an example of sustainable supply chain design for biofuels. This is the corn ethanol supply chain that exists in the United States. I focused on the corn to ethanol conversion at the US EPA. I did an analytical study of over 200 biorefineries and about 146 petroleum refineries, going over 90 pollutants and environmental release data. The key finding for my research was that emissions from refineries, petroleum refineries on a per megajoule basis is less than that for ethanol biorefineries. Now, of course, there are the positive impact that biofuels have is in the corn growth phase, but in the conversion phase of the ethanol, corn to ethanol, when compared to refineries, petroleum refineries, the numbers are not very promising, and that was my key finding. So I did a study of multiple databases that gave me plant information, databases on environmental releases, process models that model the environmental releases, as well as modifications that can be coming under policy changes and case studies. This paper was published in the International Journal of Life Cycle Assessment, which is one of the leading journals in this area. And this used tools of data mining, analytics, process analysis, and life cycle assessment. And these are some of the results that we had from that work. So finally, I'll touch upon education and how can we bring in education in sustainable development to the chemical engineering domain. And this is this is also the title of one of my book chapters, which is Incorporating Systems Thinking in the Engineering Design Curriculum and Path Forward for Sustainability Education. So according to my understanding and knowledge, I strongly recommend bringing in sustainability and systems thinking in the engineering design curriculum. How we can do it, it is very a wide area of work, so we can have multiple ways in which we can incorporate this, but design curriculum is the only place where I think sustainability has its home. I remember when I was in undergraduate school in Jadavpur University, we had 7 semesters of design going from multiple aspects of design. I don't know if design is taught in the same way now, but if we can incorporate sustainability thinking and teaching in that in those 7 semesters of design, sustainability is not something that can be taught in a single curriculum, according to my understanding, in a single course, but it needs to be infused in multiple ways. So I will go over one of my papers, which I wrote on education on sustainability. So here I focus on module-based learning methods to introduce sustainable manufacturing in engineering curriculum. This highlights new trends in epistemology of higher education curriculum itself. And we have seen a lot of these happening during COVID-19, the way we have had to change our teaching methods, teaching ways, learning outcomes have become different as a result of this. But I'll just go over this briefly and kind of infuse some thoughts and questions can follow. The concept of learning and associated learning methods has undergone a radical change in recent times, and this is even pre-COVID. We have been seeing a complete change in learning methods and associated concepts. So for example, the definition of the university has gone beyond physical boundaries to lose the identity of place. I'm sure you've all heard of online education modules or online universities that have come up. The lecture and class times have been made flexible to accommodate a wide variety of students, thereby losing the identity of time. So the identity of place and the identity of time has changed. There has been universities that have caught up with this, and they are now at the leading edge of some of the online education methods. These include very highly accredited universities such as Harvard, MITs, and the likes. They have gone on this, they have kind of been the pioneers in this direction in engineering education, I would say. However, the concept of place and the concept of time has significantly changed over the past decade or so. The second change that has happened is the deconstruction of the subject. In this method, the deliverance of the knowledge or the traditional subject is packaged in a new way to enable the modularization of the curriculum. So what you are teaching, that subject is broken down into modules, and the key attributes of these modularization concept, there are 3 attributes, which is the deconstruction of the traditional subjects as the epistemological units of study, the deconstruction of a time-bound undergraduate course as the chronological unit of study, and the deconstruction of the single university as the topographical location of the unit of study. So this deconstruction has happened over the past several years over multiple university systems. So the approach that I took for module-based learning in sustainability is that the focus on key skills, you have to develop key skills identified as an outcome of the modularization. This development aspect arises from the need to fulfill demand related to transferable skills, cross-curricular skills, core skills, and key skills. The 4 types of key skills needed for students are communication, numeracy, the use of information technology, and learning how to learn. The second point here is the learning from experience, commonly also known as experiential learning. This method takes the student out of the physical boundaries of the university to engage a different set of teachers for the teaching undergraduate students. This instruction method does not deliver the required knowledge in a specialized or articulated form, but is tacitly delivered from experience. And finally, the web-based curriculum. We have talked about web-based teaching methods very significantly over COVID, but web-based learning methods poses biggest challenge in education in future, primarily because the web content is the hardest to monitor and control. So it is not your traditional ABET accredited courses or anything. It depends very much on the learner and the cost of learning that is imparted. So it is very hard to monitor and control. However, the internet does provide many advantages, such as working space for co-construction, negotiation, and revision of knowledge over time. The connection and engagement of disparate students from diverse backgrounds and geographical locations in learning activities, a space where collaborative projects can be developed, and a vivid and complex environment for creation of simulations, models, and visually based projects supported by real interaction. So these are some of my thoughts towards the future of learning that we can focus on, and how can we current methods of learning, how can we modularize those in the domain of sustainable engineering education. Here I have given example implementation of sustainability education modules. So how can you implement sustainability education into the type 1, where is example of integration into existing chemical engineering courses. So there are concepts of green chemistry, environmental impact potential, resource use, energy use that can be very seamlessly seamlessly integrated into thermodynamics, mass transfer, heat transfer, reaction, and transport courses. The engineering design, as I mentioned, is one of the significant areas where we can integrate these process integration, intensification, green design, process safety, metrics, and indicators of sustainability concepts into that design. And of course, finally, we come to process control and optimization and supply chain operations, where we can incorporate some of the sustainability topics there. This is so this spreads out our teaching over the 8 semesters or so of teaching. However, we can definitely take inputs into this from these courses, and we can incorporate a new single course for education and sustainability. Here I talk about manufacturing systems, but again, chemical engineering can have some things like that. But this would be taught in the final year of engineering, probably in tandem with your senior capstone design project or senior capstone design course. We can have a single course designed in that direction. And then, of course, we can have short courses on sustainability for industry professionals. So who are currently working in the industry on the job training, but not conversant with what sustainability is, what are the latest modes of teaching. So having a knowledge of the industrial sectors as sustainability implementation areas, and developing specific modules based on knowledge of sustainability implementation areas. So these are some of my thoughts that I had. In conclusion, I would like to say that sustainability requires a rigorous computation in engineering domain, taking into account multiple perspectives. And education is key for imparting knowledge in these multiple domains. So with that, I would like to conclude, and thank you very much for this opportunity to speak at this distinguished panel today. And I'll be happy to answer any questions.
Vivekananda, it is really very much, you can say this presentation can strengthen our knowledge. Particularly, I have already informed you that we are going, of course, for the students learning type of life cycle assessment project. So regarding this will be a very, very helpful material for that. But the thing is that on Saturday, now it is almost at 8 o'clock. It is 8 o'clock is over. So naturally 8 p.m. So naturally all my students, they left. So only we three are here. But these things have been recorded in YouTube, and we will use it in future. And in case of any doubts and any such questions, so that we will get back to you, because you are always available. But very, very thanks, because still at this, I just informed some few days before. So still, in spite of busy schedule, you could accommodate us. And regarding your say memories and all nostalgia part, so we will send you all the such photos and some video clippings what we did in our department. Which is very much connected with this program. So thank you very much. Now let us go to Sharup's presentation. That is also very much required for us, this IoT presentation. So at least if nobody will be here, at least I will be here to listen it very eagerly. And also
no worry, that's fine, Maharajji.
That will be recorded. We will use this for our future age. So that is the thing.
Sure, no problem. So, Maharajji, I have actually a question for Debolina.
Yes.
So, if that's okay to ask.
Yes, surely.
Debolina, first of all, I see a good synergy between what you are doing and what we are doing at University of Florida, my research group and my institute. We do have a significant focus on sustainability. And I think many of the things which you talked about would have a good overlap. So we should probably talk at some point.
Absolutely.
Yeah, let the next couple of weeks pass, because those will be crazy probably. And also many of us would not be available. But maybe in the beginning of New Year, I will send you an email, or feel free to do that from your side too.
Sure.
And then we'll talk a little bit, just see what are the common areas of interest and if we can collaborate. Okay.
Absolutely.
So that's one thing. But I do have a specific question for you. You talked about the sustainability and then energy research. Based on my own research, I see that 29% of, at least in US, carbon emission coming from transportation industry. That is significantly contributed by the cars we drive, right? Different vehicles that run on fossil fuel. So of course, electric vehicles are going to make a big impact, but what's your opinion about that? Do you think that's the way to go? Do you think that's going to happen? And the push for the current Biden administration on making vehicles electric at least 50% in next few years, do you think that's going to be successful? What's your take on that?
So I unbiased towards any administration or administrative decisions. Um, I believe that policy is made first and then science follows, which to some extent it should be in that in that way. But um, the electric vehicles have their inherent issues that I feel need to be addressed first. And that has to do a lot with the disposal or recycling of the batteries and efficiencies that they are using. So there is a significant research challenge as well as like recycling challenge that if we want to change the entire vehicle fleet, the disposal is very, very little talked about in open domains. Of course, in the research domain, you will hear a lot of people talk about the disposal and the reuse challenges that we are supposed to face with batteries or electric vehicles for that matter. There is a current push towards hydrogen as a energy resource and hydrogen liquid energy carriers. So that is another challenge area. But again, in all of this, I personally believe that significant life cycle challenges are not discussed to the extent that it should be, or even like it's a lot of futuristic thinking when you're thinking that electric vehicles are going to take um, over. Maybe they're good for short distances and European countries because they're more densely populated. But in the United States, if you are looking at vast expanses of land, just take, for example, Texas. If we have to go across Texas on battery vehicles, it's not feasible to have that sort of an overhaul of energy systems and have batteries like power these the stations that would charge your battery. So there is a charge anxiety that definitely goes on in when you're talking about overhauling the energy system. But to me, the most important part is to create these new vehicles which are having this capabilities of battery or electric powering and charging. And that is more of a concern to me unless we have a good way of recycling the materials that we're putting in that, like the manufacturing of those vehicles. That itself is of a bigger concern to me than all the other issues in the supply chain of those energy overhaul systems. I hope that answers your question.
Yeah, these are great points. Definitely the disposal issue have been overlooked. The charge anxiety issue has received significant attention. But just to let you know that electric vehicle, of course, can be enabled by regulation, but that should be the future, right? Because of the significant benefits it brings
Again,
to
the
us.
regulations, hopefully the regulations will target towards the proper science and technology development in that direction. However,
Exactly.
I'll
Yeah.
also tell you, like having worked on biofuels, there were regulations and there were mandates put in for biofuels, especially for cellulosic based biofuels, cellulosic ethanols. The mandates were not met. You could not meet mandates in the United States. There were only two demonstration plants, but not producing plants that would do cellulosic ethanol. So even though there was a lot of research dollars, a lot of mandates and regulations put in place for the use of biofuels, it didn't happen because the technology was not there. Technology is still not there for cellulosics to ethanol or biofuel. So again, it could be good to put in money and see if we are able to meet those targets of recycling and getting those rare earth metals to be recovered after the end of life. But I don't think we have reached that point where that has become a significant issue yet. And that is a concern area for when you look at the life cycle of this. So it could make sense in population dense cities where you have short distances to travel and those kind of things, but overhauling the entire energy system and going all battery operated or electric vehicles could pose significant challenges in the future.
Yeah,
We
I
want the
appreciate
country
that.
to
Absolutely,
become.
absolutely agree on that. And I hope that the research efforts can find solutions which are practical, which are worthy for mass adoption. So it remains to be seen. But I see a promising future there.
Yes, yes,
I
yes.
probably is not as
And if you look at the work that is being done by Argonne National Lab and all the national labs in this direction, it's significant research is being put in there. But again, another point in sustainability that I always emphasize is the overemphasis on greenhouse gas emissions. I mean, greenhouse gas emissions is a problem, but that is not the only problem that people face. There are significant other challenges like water use and water depletion that comes along with these technologies. For example, corn ethanol, it uses way more water than you can imagine. And when you look at the different fuel cycles, their comparison is way, way different than what you can expect. So water use, and that has depleted aquifers in the Dakotas, and that has created significant environmental stress. So sustainability is not only greenhouse gas and global warming that we are thinking of. So that is something that needs to be very cautionary. People have to be very cautionary. And the same argument goes for shale gas exploration. Are we using too much water to do the shale gas explorations, and what are we doing with the disposal of the water? Those kind of issues are there. But again, having the life cycle perspective and also going regional and local rather than global sustainability issues, those are probably some of the ways in which we can tackle these problems.
Yeah, I completely agree on that. The water quality management and the impact of let's say energy production on water quality overall is a big issue, and I fully agree with you on that. And being in Florida, I see that firsthand. Our coastal waters are being severely impacted by agricultural lands, wastewater runoffs, as well as industrial leakage. So basically that's a huge problem, and it's going to be more and more of a problem. I can give you a personal experience. Just a couple of months ago, I visited some of the beaches with my kids, and then they were excited. We took all our equipments, and then we wanted to be in the ocean, right? And this is Gulf of Mexico. We go there, and 100 meters away, we can smell rotten feces. Basically, this red algae bloom killed millions and billions of feces, and they are all lying on the seashore, and I could not be there for more than 5 minutes. So you see the impact of coastal water body by our industrial leakage, as well as maybe biological excretions and other things. So basically that's going to create a huge problem. And I agree with you that probably we're giving too much emphasis on greenhouse emission, which is very important, but we also need to look at the holistic picture, right? All aspects of sustainabilities have to be considered together. Yeah. Okay, so we'll talk more about that. That's exciting. Absolutely. And I'm glad to meet you, Vivekananda, for the first time. And thanks, Maharaji, for creating this platform to meet people like Vivekananda, people like Dr. Sarkar. Greatly appreciate the opportunity. So we'll be in touch, Vivekananda.
Absolutely.
So let me see if I can share my screen.
Oh, surely. Please do this.
Okay. So just let me know, Maharaj, if you can see my screen.
Oh, surely.
Okay. Okay. So I'll get started then.
Yes, please.
So again, thanks everyone for making it happen. It's definitely a great forum and my pleasure to give this talk about this topic. As you can see here, IoT, that stands for Internet of Things, and Industry 4.0. I think these are the terms which by now are very familiar to most of us. I am Dr. Sarup Punia from University of Florida. I am the director for an institute called Warren B. Names Institute for the Connected World. This particular institute focuses on pretty much every aspect of Internet of Things technology and its applications. So what I will do, I'll talk about the institute a bit. That's what I do as a director when I give a talk. As a custom, I do that. So basically, the institute was established 5 years ago with the goal to create solutions, IoT solutions for solving global problems. And of course, as you can see, that's a lofty goal. And we wanted to impact areas like health, environment, agriculture, transportation, education, and more. Because we believe that the Internet of Things technology is the future and it will impact our industry, it will transform our lives. So that was the goal. With that goal in mind, we created the institute. It was established through generous donations of 2 individuals. I'll talk about that. But another goal was to make the IoT technology as a pillar for the 4th industrial revolution or Industry 4.0. I'll talk about that briefly. In the institute, we are looking for partners, collaborators, and sponsors from industry, academia, as well as government. We already have a lot. I will talk about some of them as you move along. But of course, we'll be happy to have you as a partner. So if you have interest in IoT technology, if you have interest in transforming different application domains with IoT, we'll be happy to talk to you and work together. As I mentioned, the institute was developed through donations from 2 individuals. One of them is David Names. The other one is Sachio Semoto. Both David and Sachio are alumnus from University of Florida. David was former chairman and CEO for Discover Financial Services, including Discover Credit Card. I had opportunity to meet both David and Sachio on many occasions. Sachio Semoto is a Japanese entrepreneur. He has founded successfully many companies, including eAccess, eMobile, and is extremely successful as a businessman. So David and Sachio donated money towards forming the institute. David donated money in the name of his father, Warren B. Names, who is also our alumnus. He's an IoT pioneer. In 1970s, he was building smart home or smart connected devices using mechanical relays and discrete electronic components. So it's really exciting to see the vision he had towards a connected future, towards future where smart devices can play a significant role. So these are the people who are involved in the IoT Institute from University of Florida. Of course, there are a lot of external partners, and these are the faculty members. Of course, we have about 100 graduate students working in the institute. And these faculty members represent a really diverse group of people, as you can see in terms of their expertise and department affiliation, and they're extremely diverse. They bring in expertise from different technology areas like artificial intelligence, sensing, communications, electronic hardware, software, analytics, and many other areas. But they also represent many application domains. We have people from the College of Medicine, from Department of Agriculture, from College of Education, from Department of Transportation. So these are the people who not only develop the core foundational technology for building next generation Internet of Things technology, but also using them to drive new application domains. As I mentioned, the applicability of IoT technology is vast, and we are exploring together how IoT technology can be applied in many different areas, including areas where technology solutions have not been used in the past. And I'll give you some examples there. But like Debolina, I would also point out one important aspect. Even if we do spend most of our time on research, on developing new frontiers of technology and developing new application for the technology solutions we develop, but also we have a passion in terms of education and training, and we are creative also in that aspect. One of the significant focus of the institute is to develop a new curriculum and a new educational content for teaching artificial intelligence and Internet of Things. So these are the two technology frontiers which I believe would be changing the technology landscape of future significantly and impacting pretty much every field you can think of. And you can see that today happening, and I believe it will be there for next 3 or 4 decades at least. So in terms of educating our students on those two frontiers, and in terms of making the next generation of workforce who are trained with IoT and AI, we are developing curriculum modules, we are creating opportunities for scholarship, and we are also introducing new courses. So few specific examples I would like to give. One of the core emphasis, again, this is also similar to what Devolina mentioned in her talk, has been experiential learning, learning through hands-on experience, and that's a very important focus for us. If you want to teach IoT, different aspects of Internet of Things technology, and you want to teach AI, then we believe the most effective way to teach would be to let students have experience on these technologies using hardware software platforms. So learning by doing, learning by making are the important models of education and training we are following in the institute. But towards that, or based on that model, we have been developing course modules, and some of them are already available in public portals. One of the key aspect of that exercise is something called Haha board, or hardware hacking platform, which we have developed. It's a configurable Lego-like platform where students can implement different Internet of Things devices and explore different aspects of the device, including security, reliability, safety, and other things. And it is funded by 2 National Science Foundation grants, which I received in recent times. We also have introduced a scholarship which can train about 50 students on different aspects of IoT technologies and security. And it's a collaboration with Florida International University. I am the principal investigator for that scholarship grant from National Science Foundation, and we already have recruited about 50 students in that scholarship grant. I'm collaborating with a researcher in College of Education called Pavlo Antonenko. He's the director for the Educational Neuroscience Lab. Pablo is a fascinating person. He is obsessed with developing new educational technology. And recently we received a grant from National Science Foundation at the United States to develop security curriculum for upper elementary students. These are the students who are in grade 3 and grade 4. And we have developed some interesting hands-on curriculum for those kids to learn different aspects of IoT security and crypto modules. So there are a lot to talk about. Again, the focus of today's presentation is not to go deeper into the curriculum, but if you're interested, I'll be happy to do a deeper dive on those. I'll be happy to point out what we have developed, what we have shared in public portals, and what we are developing, because we believe there is a significant need for educating the future generation on IoT and AI, and we are trying our best to contribute in that area. So with that, we'll talk about some interesting research we are doing in the field of IoT. But before we go into that, because IoT or Internet of Things probably has different meanings or different interpretations for different people, I would like to define it from my perspective. But before we go into that, let's zoom out a bit and see what are the different types of computers we have. Again, this is a favorite question I ask in my class, that what is a computer? And what are the different types of computers? That's the second question I ask. And then third question I typically ask is that what a computer would be like in, let's say, next 10 years or even next 50 years. What would be a computer like if you project into the future? And this is a question students really love to answer, because that help them to become creative and see or foresee the future in terms of the capability or evolution of computers. So coming back to this first question, which I typically ask, is what is a computer? Of course, you can answer that question as, hey, something that computes, something that can run an algorithm, which is nothing but a systematic set of computational steps, right? So that's an algorithm. And if you think that to be a computer, I did my undergraduate studies from Jadavpur University, the Department of Computer Science, of course, long ago. 1995 is the year when I graduated. But the first thing I learned there is that computers can compute, but it has some fundamental limitations. Of course, that limitations you can see today, even in the age of AI, you can see that computers cannot do everything, because the computers are limited in terms of the capability of running an algorithm and nothing beyond that. So AI is nothing but an algorithm. So whatever we design as an algorithm, that it can do. So it has some fundamental limitations. If you are interested, I'll be happy to talk about that. But within the realm of its limitations, it can, of course, do magics, right? I have seen that. So that's computers, but the computers can be classified broadly into two categories. One of them is called general purpose computers, which has the versatility and programmability. It can do different things as you can program the computer to do, and it can cater to diverse use case scenarios. On the other hand, we have computers like which is typically called embedded systems. These are the computers which have customized design, unique use case constraints, and for these computers, the hardware is designed for the specific software and vice versa. So which means that they have tight hardware software integration. These are the computers which are application specific and optimized for the target application. And there are numerous examples for that. The refrigerator, the autonomous vehicle, the music player, the smartwatch, thermostat, smart toaster, smart light bulb, you name it, right? So it's there everywhere. So that are the embedded systems. Now, over the years, these embedded systems have evolved into IoT. Right now, there is no true embedded systems, in my opinion. These are the computers which have evolved or transformed into Internet of Things. And it has transformed by adding few components to it. What do we added to embedded systems? The first thing we added is a generous amount of connectivity. So you can see it as a recipe. So embedded systems, which are good old computers optimized for specific use cases, you add a lot of connectivity to it, then you add smartness in the form of machine learning or AI, and then you add something called interoperability, because these computers now most of the time do not work alone. They work with other computers and they interact with the physical users on a daily basis or on a regular basis, right? So they have to be interoperable with other devices. They have to be interoperable with variety of users. So if you add that together, you have got the IoT. And this is really the simple recipe is really transforming our industry and transforming our life. And we'll talk about a few examples on how they are doing that. But because of this immense potential of IoT, the number of IoT devices is growing exponentially. And right now, by a specific account, there will be 24.1 billion devices by the end of 2030. Actually, it is an underestimate. We expect to see a much larger number of devices across the globe, which are smart and connected and transforming industry and our life. If you think about the IoT, IoT is not just one device. IoT is not just one device connected to the internet, right? It's basically a collection of heterogeneous set of devices which are connected through network to the internet and to what we call cloud. So this particular slide is giving you a high-level overview of the IoT architecture, which can be viewed as a 4-layer architecture. At the bottommost layer, we have what we call the things. These are the smart connected devices like the smart thermostat, smart RFID tag, smartwatch, smart network router. So these are the devices which are at the bottom of this IoT architecture, or they form the bottommost layer of the architecture. We call them things or edge devices. That's a popular term which we use when we refer to these devices. Now, these devices are connected among themselves. As you can see, they are very heterogeneous. There are a lot of different types of devices, and they are also connected to the network. And of course, there are multiple layers of these networks. There is something called fog. There is something called base station. There is something called the top level network. So once we have them connected to the network, there is a virtual layer called cloud, which is nothing but collections of connected set of servers for shared computing and shared storage. That's called cloud. And finally, we have a bunch of software applications running either in the cloud or in the edge device or in between. That forms the topmost layer. So these are the 4 layers. Now you may ask that, hey, this particular architecture has been there for quite some time. That's quite true, actually. This architecture is nothing new, and not, of course, each of the layers are also not new, right? However, if you think about this holistic framework of IoT consisting of these 4 layers, there's a lot of room for research, a lot of room for innovation. So we sat together and found out what are the opportunities for research and innovation, and in each of these layers and as a whole for the whole IoT ecosystem. It turns out that there are a lot of interesting research challenges in terms of developing the IoT technology to meet the requirements for the next generation of applications. So these are you can see in this slide, I'll not go into details about that. These are the specific opportunities for research and applications. And some of them, this is not the entire list, of course, there are more opportunities for that. And if you're interested in doing research in developing IoT technology, I'll be happy to talk to you. Please feel free to connect to me. Now, what is unique about IoT? As I mentioned, there are a lot of interesting research challenges, but these are the 4 major areas where we can innovate. Number 1 is that these devices do interact with the physical world. If you think about a smart light bulb, a smart toaster, a smart lock, even a smart monitor, which can monitor the structural health of a bridge or a rail line or a house or an office complex. So if you think about those devices, they do interact with the physical world, right? And the moment they interact with the physical world, and one specific example I give is, let's say, the autonomous car, which is driving itself. they interact with the physical world. So the moment a device, an electronic device, interacts with the physical world, you have to think about a lot of parameters, including the safety, reliability, resilience. So all those things become more important because these devices are interacting on a regular basis to the physical world, to the human users. An autonomous vehicle, if it is hacked, for example, if it has a security issue and a malicious actor hacks the vehicle, and of course there are examples for that, then of course not only the security issue comes into play, there is an interplay between security and safety which you have to be careful about while designing that system and while verifying that system. So there's a really difficult research challenges that come into play because of their interaction with the physical world. The second one is that they collect a lot of data, and this data comes through sensing. So these sensors which are embedded into these devices, they collect data. And for example, if you have a surveillance camera fit on a drone for, let's say, monitoring forest fire, right? So that will collect data. Now, the moment it collects data, the storage becomes important because it can be gigabyte to terabyte of data you need to store. Not only you have to store the data, you have to interpret the data, you have to recognize meaningful patterns from the data, and you have to make inferences, most often in real time, about what's going to happen and make decisions on that. So collecting data and making inferences based on the data is a significant problem, also significant opportunities for applications of AI techniques. Okay. The third one is that these devices are connected between themselves as well as connected with the human users. And the moment connectivity, such a widespread connectivity is there, you have to look into many interesting challenges. Connectivity brings in the safety issue, reliability issue, security issues at the forefront. At the same time, connectivity also comes at a cost. It has to deal with the energy constraints, it has to deal with the real-time performance constraints and many other things. So there are a lot of interesting research challenges there. And finally, the autonomy itself brings in a lot of interesting challenges. Autonomy is fantastic. It gives you a lot of capabilities, but you have to also make sure that autonomy does consider the safety issues, does consider the reliability and long-term sustainability issues. So this is a diagram I borrowed from a specific website, as you can see below, but this was created by a group of people called Levelium, and they created a smart world using IoT devices. And here, this is just an example on how our life, how our industry and critical infrastructures will be transformed in the future using smart connected devices, which is basically IoT. And you can see here that IoT can play a significant role on pretty much every aspect, including, let's say, structural health monitoring, climate monitoring, precision agriculture. And this particular figure shows you a lot of major application areas of IoT, and that's why I borrowed this picture from Libelium website. Basically, it shows you that on one hand, it can help you to make your life smarter, which means that it can impact you by, let's say, monitoring your physiological parameters on a regular basis and guiding you on your health. It can also help you in home automation, office automation, automation of schools and colleges and buildings and shopping complexes. It can also help us automating the transportation industry, automating our manufacturing industry, automating, as I said, agriculture. And also it can help us to, let's say, detecting forest fire and helping us in preventing or mitigating natural hazards. So that's in a nutshell what IoT can do. And I think there is no doubt at this point that IoT would play increasingly important role in every sector. But one of the most talked about role of IoT probably the most impactful role about IoT would be in automating the manufacturing industry, and that's called Industry 4.0. If you look at the industrial revolution over centuries, there have been three major industrial revolutions. I think all of you are aware about that. In about 1784, we had discovery of steam engine and mechanization of industry that did replace a lot of manual work by machines. And that was the first industrial revolution. The second industrial revolution did focus on application of electrical energy in driving these machines, right? Earlier, as I said, machines were powered by, let's say, steam and other energy sources, but the discovery of electrical energy and a widespread network of electrical connections did enable second industrial revolution. The third industrial revolution that happened around 1969 was enabled by the discovery of computers and electronics, right? You can probably talk a lot about the history of computing and history of electronics. That's my favorite topic. But computers and electronics did enable a breakthrough in industrial automation, industrial data processing, predictable maintenance, repair, and many other things. And then finally, we right now at a stage where we see Industry 4.0 or fourth industrial revolution, which is powered by cyber physical systems, which is I would say, which is a broad class of smart connected systems that has direct interaction with the internet, and which is also enabled by a lot of sensors integrated onto it. With some differences pretty subtle between Internet of Things and cyber physical systems. I'll not go into that because it can also be debatable. But let's take these two as two, let's say, overlapping paradigm of smart and connected systems, which are enabling the Industry 4.0 or fourth industrial revolution by doing a lot of different things. And as you can see at the bottom, this is a diagram taken from also a website, which basically shows you how IoT is enabling the fourth industrial revolution by converging smart sensing, smart connectivity with the power of AI, or the power of sensing and connectivity with the power of AI. And how does it do that? One of them is to do material sensing. It can actually sense materials. It can automatically detect the composition of that, and then it can guide the industrial processes. It can help in maintenance, repair. It can help in running advanced algorithms for predicting the failure of a specific device. And I can give you one example that I had experience on. I was visiting local industry, and this is about two hours drive from our university in the area of, it's called Sarasota Bay Area. And this particular company was manufacturing the glass window. And for that, they had a big manufacturing facility, and in that facility, they had a glass cutting machine which was using diamond saw to cut the glasses. And they said, we don't know when exactly to sharpen or replace that diamond saw, okay? Because it depends on the workload, depends on many different factors. So they said, okay, can you use IoT and AI to detect when exactly that that glass saw has to be sharpened, right? And they even said, why don't you monitor the noise coming from that and run by using an IoT device, and then run an AI algorithm to detect exactly when to sharpen it or replace it. And that will definitely save a lot of cost, and that will definitely improve the quality of our products. So we took up that challenge, and of course we are working on a solution for that. But that's one example where IoT and the convergence of IoT and AI can help in manufacturing. But there's thousands or millions such examples. As you can see, the big manufacturing companies are already deploying IoT to do so many different things including industrial control. But the small and medium-sized companies for which we are working, they do not have IoT technology to develop application-specific IoT solutions to serve their needs. So there will be a growing need for developing an IoT/AI toolbox for creating application-specific IoT solutions for small and medium-scale businesses. So that's an area which, of course, can benefit significantly from your contributions. So in terms of three major areas where we need contributions from different sectors, number one, workforce development, because IoT and AI are new technology areas. We do not have well-rounded training for generating the workforce who have experience in IoT and AI. And of course, emphasis on hands-on training is extremely important. As I mentioned, we need standardized tools. That's extremely important for creating application-specific IoT solutions. And finally, IoT is truly interdisciplinary. Right, IoT is not just one technology, it's a convergence of technology solutions. And also in terms of application of IoT, as I have mentioned a number of times, it does reach out to pretty much every application area you can think of. Actually, I would challenge you to think of an application area where IoT cannot help. In terms of technology, security, energy efficiency, interoperability are three major topics which we are focusing on. And of course, there are significant opportunities for you to contribute in many areas of IoT technology solutions. So one of the emerging area of IoT is, as I mentioned, convergence of IoT with AI. And that's coming into play because so far, for last 2 decades, if you think about application of IoT, the IoT devices were mostly doing sensing and data collection, okay? And the brain of the IoT was in the cloud. So it was mostly centralized data analytics, centralized decision-making for IoT that were happening over the last 2 decades. But there is an increasing need for doing data processing and making intelligent decisions in the edge device or in the things itself. And that's called edge intelligence. And edge intelligence can be only accomplished if you can bring AI to the edge, which means to the endpoint devices, which are also called things. For example, if you think about a smart light bulb or smart toaster, if every decision it has to make, it has to go to the cloud, then that's not a good thing. If it can make its own decision based on the data it's sensing on the site, then that's much more attractive for daily usage, and also much more attractive in terms of improving its overall decision-making capability. So that's why more than 80% of enterprise IoT projects will include an AI component by 2022. That's a prediction, and I believe that's going to happen soon. Right now, it's about 10%. This is data taken from a company called Gartner, and they have a website. You can go there and check. They have a lot of interesting data. And this particular capability where IoT is converging with AI in the edge, which is also called AIoT, and that's a new field that's being created where edge devices are having intelligence, and as opposed to centralized intelligence created by running AI algorithms in cloud. Here we are looking at distributed intelligence at edge, where each small device used in the field will have its own intelligence. It may go to cloud every now and then for running complex AI algorithms, but most often it will be running AI algorithms in the edge device. And that is going to be the future of IoT. And I have no doubt about that. And that would be really enabling. So in order to really excite our students at different levels to come up with their own IoT solutions, to to combine sensing, connectivity, and AI for solving exciting problems, including problems which have not been solved before by using the power of AI and IoT. We introduced a competition across the nation called IoT Design Competition that was done for the first time this year, and of course we are going to introduce again next year. And if you are a student listening to this talk, I would strongly encourage that you think of creating a group and participating in this competition next year. This was sponsored by two big companies, Microsoft and Texas Instruments. They donated funding, they donated money, they donated equipments to run this competition. And our institute was the lead in running the competition. So here students come up with interesting ideas of using IoT for solving different problems. And there are many examples of that. I'll not go into details. The website and the website for the institute does have a lot of information about the competition. Some of the example projects students did from this competition. So I want to quickly mention that. But now for the next, let's say, few minutes, I'll talk about some of the cool projects, IoT projects we are doing in the institute. When pandemic came up and did impact us severely, we rose to the occasion and tried to do something. We believed that IoT solutions, particularly wearable electronics, smart wearable systems we thought can do significant benefit in terms of detecting, preventing, and monitoring the spread of the disease. With that goal in mind, we came up with many interesting wearable devices, and one of these devices, of course, got huge attention from the media, including TV, like the Fox News and others. So they featured our work. Of course, we have a large number of publications on this. So one of the specific solutions we came up with is called a smart mask. And in that mask, what we did, and this is a student, as you can see at the bottom, my student Naren is wearing a mask which we designed in-house. And this is really a smart mask in the sense it can sense presence of different particles, including droplets and even aerosols nearby. So there is a sensor which can sense particles of different dimensions. And based on that, it can give you adaptive protection. It was a really cool idea, and we have interesting demos if you like to see. So based on that, it can actually provide different layers of protections by specifically emitting aerosols, water-based aerosols nearby, so that the floating virus particles can come down to the ground and reduce the infectious capability. So that was proven through a lot of studies. If you're interested, you can go into the publications. You can easily search in Google and find the publications, and you can see a number of articles on the smart mask and many other wearable devices we have developed to monitor the spread of the disease and also mitigate. We have developed also a very interesting IoT device. Again, this is just a sampling of the projects which we are doing at the institute. And this particular one is good for India. And that's why I wanted to mention that India, unfortunately, is the largest exporter of fake medicine. I think many of you know that. It's not a good thing, but unfortunately, that's the case. And in many countries, a large percentage of medicines, including medicines we use for cancers, we use for protecting against malaria and many other severe diseases, are fake. And they are fake in many different ways. And there is a need at different part of the supply chain to detect fake medicines and to detect contaminated substances which we use for, let's say, supplementary for let's say supplements we use to let's say gain weight or lose weight, or to increase our energy level, things like that. They have a lot of chemical contaminants which can be extremely dangerous for your health, including neurotoxic chemicals. So we came up with a device, internet connected device, which can actually sense the material and which can detect chemical contaminants in that. And we have a number of articles including one in IEEE Consumer Electronics magazine called Eat But Verify. This particular device, based on the principle of nuclear quadruple resonance, it's a portable spectroscopy technique, can also detect unwanted chemicals in food, because in India, as I know, the food, many food articles, particularly packaged food articles, would come with dangerous substances, and I have first-hand experiences on that. So this particular device can detect that. We also have developed something called nanodot technology, where we can put a dot of which we can actually put a barcode, invisible clandestine barcode on different products, and we can verify the authenticity by using an internet connected wireless monitoring device. So there have been a lot of media coverage on these research articles. I'll not go into details about that, but if you're interested, you can look at that. I did talk to Debolina about electric vehicle and the future that might see a significant rise of electric vehicle adoption in both India and many other countries, including US. So we have been trying to develop technologies to solve the range anxiety problem in electric vehicles, and this is one of the technologies which we have developed, and many major media outlets, including Popular Mechanics and IEEE Spectrum, did cover that. They featured an interview where we proposed a new mechanism for addressing the range anxiety problem using internet connected smart sensors. We'll probably have a separate discussion on that. We have also developed, or we are developing, technology for environmental monitoring, particularly water quality monitoring. We recently got a planning grant from National Science Foundation to develop a hierarchical sensing technology for monitoring the water quality of Florida's coastal water. And this is a very nice diagram that shows that we can create a real-time water quality map by having a hierarchical sensing platform, where at the top end we can analyze the satellite data to get a very coarse grain water quality map, particularly when it comes to, let's say, microbial infection. We can get some ideas of that from microbial pollution from the satellite images. And then we can have hyperspectral imaging done by drones based on the information obtained from satellite images. And finally, in some specific areas, we can have microfluidic floating sensors to get more detailed water quality data. So this is a project which is ongoing, a large-scale project. We have got some funding to carry out this project, but of course it requires significant effort to create such a real-time water quality map, and we will be doing more work on that and looking for collaborations in these areas. So that's a quick sampling of the specific technologies we are developing in the institute. Again, we'll be happy to talk to you more about them. We'll be happy to solicit collaboration from any partner who are interested in these technologies. So with that, I will thank you for listening, and I will then hand over to Maharajji for the next step. Thank you.
Thank you, Saurabh. I have only one question. Actually, this question, of course, not very pertinent to the, you can say, pedagogy, but the management. That is, in our India, that because of this IoT and AIoT, there are lots of courses, new courses are coming up in the UG level. For example, say BTech in artificial intelligence, BTech in machine learning, BTech in big data analysis, and all these things. So the thing is that whether, and naturally, because of the all these issues are in the news, so the institutes, those are offering this type of courses. So there may be the computer science course that the 100% seats may not be filled up, but these courses, there is totally 100% filled up. All the students are opting for that. Now, what should be the fate of these people? That is a did you understand the question?
Yeah. So basically, what I understand is that, first of all, are these courses quote unquote legitimate, in the sense that are they being taught by the right people who have the right level of knowledge? Because if that's not the case, then students are not learning the topic well, right? So that's one problem. And the second one is that once they learn, let's say they're learning it properly, then are they going to be placed in the right company, right? Or are they going to do the right thing? So there are two aspects of this question. So the first part is that or do you have the right the teachers with the right knowledge, right skill set, right? So that would take time, or that is not really achievable in a short term. When computers came into existence, of course, it took decades before we had well-trained teachers, right? So one of the things which we are doing, we are also training the teachers. The institute has a significant effort for training our high school teachers and training our community school teachers so that's something we are doing. And this curriculum which we are developing are widely available. I can send you some links where you can download some of the materials, and these teachers can use them. That's one aspect. The other aspect is that, are these students going to go into the right market sector? That again would depend on also these companies who need IoT solutions, understanding the value of such training, right? But that will be the requirement in future, that part I can guarantee. But it will also take some time for these companies to understand what skill sets are needed, right? And are these students coming to them with the right skill set? It's a gradual process. Even in this country, that process will take some time. But you can see that this process will mature, hopefully within next few years.
Okay, thank you very much. Thank you, Devalina. Thank you, Swarup, for such a wonderful. I mean, this is really strengthening our knowledge base. It is really, I mean, helpful for us. And pray to Sri Ramakrishna, Swami Vivekananda, and Srima that our country can achieve that level, so that the ultimate benefit for the society. Oh, one thing I should mention, yesterday's program that was inaugurated by the new Vice Chancellor of Jalapur University, that is Professor Professor Shamanta Das. He is basically from that comparative literature department. So he's, he is a professor there. So he said that our association, the Vivekananda Institute's association with this Jalapur University, that ultimately they hope that will prove many fruitful results. Actually, I started with a mantra that is Sahabiryan Karavavahai. Let us do it together. And if we can, extend our helping hand, from all sectors, not only the ashrama, and but also all the academic institutions and the community, then ultimately the country's future will be strengthened. Here is Professor Bhaskar Gupta. Bhaskar, please. Professor Bhaskar Gupta. Professor Bhaskar Gupta is basically come. No, it is all right. It is all right. So he is the organizing secretary of this program. Earlier, chairman of the Joint Entrance Board, and also he was there in the Railtail and ONGC and all that. So many organizations. So like that. So I hope, and Devalina has told that you were telling me that you need association with the NGOs.
Yes,
Hello?
yes. So, yes. So for my project, and Swarup, it might be of interest to you as well. I've been recently funded a National Science Foundation grant developing sustainable regional systems.
Yes.
And I'm working currently on Texas, Louisiana, Mississippi, the Gulf Coast in the United States, but I'm also extending that work to the West Bengal region. And there we are working on disaster resilience in food, energy, water sectors. So that is the main goal, is to work on disaster resilience and in the food, energy, water sectors. So I think
particularly in the Sundarban area, Sundarban
yes,
Delta. Yes.
Sundarbans, but also what we have been currently seeing is that even the inland areas in West Bengal are seeing a lot of disasters, flooding. The city of Kolkata is a good example. Every time you have a heavy rain, you have significant flooding in several regions in the North Calcutta, like North Damdam region and all of those regions. So all of these are like very pressing issues and needs for the society currently, and definitely having a strong partnership with the universities as well as some of these social capital organizations such as yourself will be very, very important. In addition, also this could be a very good way for engaging some of the industries towards corporate social responsibility application areas. So we want to work with all of you in this direction, especially in the technology development. Swaroop has showed exceptional work in the IoT space. We are also looking from the chemical engineering domain. We are looking at IoT in a different perspective, of course, like getting IoT and Industry 4.0 incorporated into chemical engineering is one of the difficult challenges that I would say, because of the nature of the chemical processes being so much difficult. But of course, like the safety engineering aspects, we have a very strong safety research center at Texas A&M. Those are ways in which we can incorporate some of these technologies into this domain. But of course, like happy to start the collaboration, any discussions. I should be in India sometime next year, and an in-person meeting is always helpful to put things forward, move things forward in that direction.
Okay, please. Okay, so let us call it a day.
Thank you so much. And this was a pleasure to be a speaker and part of these celebrations with you all.
If you are available, we are having a spiritual program on 12th January. So they are all these downtrodden people. They were also called. They will perform some cultural shows and other things. Our Vivekananda SDO, subdivisional officer of this Vivekananda, he will be present. The Government of India Director, Ministry of Culture, she will also be present. Dr. Tarun Goswami, the editor of this Millennium Post, one of the largest selling dairy of our Kolkata and Delhi. So he is a great, scholar on Swami Vivekananda. So he will deliver that keynote address. So I will invite all of you.
If it is in person, I think my husband will be in town. So you know Rajiv, so he will be there.
Yes.
So
It is on 12th January. That's very good. That's very good. Thank you very much.
Thank you.
Let us call it. So I am ending this meeting. Okay.
Thank you. Thank you.
Bye.